Hi everyone, my name is Martin Yanev, a professional software engineer and a computer science professor at Fitchburg State University. And in the next 10-hour course, I will teach you how to master Java and the LibGDX framework for game development by building 5 amazing games by yourself. Every game will increase in complexity, so you will build your game development skills progressively. In the first project, I will introduce you to the LibGDX main functionalities and show you how you can display objects on your gameplay. In games 2 and 3, I will teach you how to randomize, interact, and clone your game objects using a single source. In game 4, I will show you how you can create a menu screen, how to record the top score, how to play background music and more. The course will end by developing the Get the Cheese game, where I will show you how you can animate your game character, how to extend the game map once you reach the border of your window, and how to design the text displayed on your gameplay. If you want to navigate through the course topics, you can do that by clicking the markers in the description. I have also added a Git repository where you can have access to the complete source code for all games. So if you want to boost your software development skills and you like my way of teaching, please subscribe to the channel and like this video. Now, let's get started. Today we're going to install Java for Windows, so let's go to the command prompt now. And here we are in the command prompt, and the first thing you want to do is to check if you have any available version on Java in your computer. So we'll do this by writing java-version, and as we can see, we don't have any version of Java in our computer. So let's change this. Write JDK in Google, and from the results, go to the first one, Java SE Development 8. It's important to go into Java 8. And after that, let's search down for the Windows version that is for 64 bits, as I'm using Windows 10. So here just accept the cookies. Okay, so we accepted them. And after that, let's scroll down a little bit. And after that, once we find what we need, which is the Windows version, simply we need to click to download it. So here is the Windows version for 64 bits, and I will select this field here, and then I will download it. Just bear in mind that it could ask you for registration, so just register for the website and then download the version of Java. So here I will press the downloaded file, and here we have a few options, of which I'm going to select the accept one. So let's select this here, and after we do this, we can start the simple installation of Java. Just press next everywhere, and finally the Java will start installing on your computer. So let's wait a bit, and after the installation is completed, press next. Then you will get a little bit more of installing software. So let's wait a little bit, and after everything is installed, just press the button here, close. That's it, and we're ready. Let's check if the Java is installed in our computer. So I will close the terminal, I will close the command prompt now, and after that I will just run it again, so we have a fresh start. And here write the same, java-version, and let's wait a bit. And now, as you can see, we have the Java installed in our computer. You're getting the version of Java, which is good. This means the install was successful. And let's check something else. I'll write Java C or JVac -version. So we don't have the JVac installed as well. And this is because we need to set the environmental variable. And I will show you how to do this. So go to Program Files in your Java installation. And here you have two folders. One of them is to run Java on your computer, the other one is to access Java from the command line. And here I will just select this folder, and then let's check here in the folder if we have the JVac. So in a folder that we have JVac, just copy the path to this folder. So just copy it, and after that go to my computer, okay, this PC, and then go to the properties. So once you go to properties, check the advanced properties, select the environmental variables, and we will add a new environmental variable here. Okay, it is actually very simple. So here are the environmental variables that our computer is using. In order to add Java to our path, we need to do the following. Select new here, as you can see. So right here, the name of the variable, we can call it just path, and then just paste the copied address by Control V. Okay, and we're ready. So press OK everywhere, and now the JVac is installed, and we will check that by first closing the command prompt and opening it again. So open it here, and after that write JVac vac, that's it, dash version. And as you can see, now we have the JVac installed. So let's move on and installing Eclipse in our computer. So in Eclipse dash downloads, it automatically recognizes the version you need for your computer. So just select here download Eclipse. So as it recognizes that my version is Windows 10, it will immediately prompt me to this. So now I can install the version for the Windows. Just select here download, and now it will start downloading. Let's speed up the video a little bit so we're not waiting too much here. And now it's downloaded. Just select the X file and now press run. That's it. And then you're getting into the Eclipse installer. So what would you like to do is to install Eclipse for Java developers, and then simply press install. It will take a few minutes. So first accept the agreement, and then it might take you about 5 minutes to install this. Now press launch after it is installed, and here we are in the Eclipse IDE. Press next, and then we're entering now Eclipse, and you will see the welcome window, but you need to close it here. So once you get this window, just close it, and then you will be able to open a project in Eclipse and start building your project. So this is what we're going to do. Let's close the window here, and then you can select create a new project. And once you do this, you will be able to create your first Eclipse project, and let's test if everything works. So let's write the name of the project, and after we're done with this, after you wrote the name, you can check actually the configuration. So here in this folder, these are where the files are stored. Okay, you don't need to do anything about this here, I'm just showing you so you know. And then once you check that this folder is there, press next, and here we can build our project by pressing finish. Okay, select this button here, and that's it. So our project is ready, and let's create a class here. So here we have our class, and okay, so inside this project, let's create a new class. Okay, and here press public static void main option and choose the name for your class. Okay, so I will call the class hello world, and I will just print hello world here so we can check that everything is working correctly. So here in the main class, we are going to write system.out.println for print line, and in the brackets just simply write hello world. And once you do this, go here to the execute button and press OK. So now you can see that hello world is printed on our screen, which means Java is installed correctly. Thank you very much for watching. Hi everyone, today we are going to install some plugins into the Eclipse so we can run our LibGDX application. So let's go to help here, and then I will select install new software. So press add here, and let's write as a name of our add repository Android tools for Eclipse. That's it. And here I will place this URL. Okay, so just write it down here and then select add. So once you select add, you're prompted to this window here, and just select all the tools. So you have all the tools that are Android based, that you can use them on Eclipse. Then press next. It is very simple, and now the software will start installing in your computer. Press next here as well, accept the agreement and press finish. And now it starts installing. You can see this in the bottom right corner. Okay, while we're on the half of our installation, you might get this type of warnings here, but don't worry about them. Just press install anyway, so the installation continues. If you get more than one, just keep pressing install anyway, and the installation will not have any problems loading on your Eclipse environment. Once the installation is complete, please restart Eclipse so we can have a fresh start ready for our new installation. Then what you would like to do is just to install all the SDKs. Okay, so keep this option, install the latest available version, Android APIs. Press next here. I would select here no, because I don't want to send my statistics to Google, but if you would like to, keep this to yes, and press finish. So now you start to run the Android SDK manager. Here just accept the license and press install. And here some installation has started. Now after this is done, you will get the message the Android SDK requires new build tools component to be installed. Just press open SDK manager and you will be prompted to the SDK manager here. So now you will need to install some of the most important tools of the SDK. So these are going to be the API 29 for Android R, for Android 10 as well. And just keep the default settings and select install 18 packages. Accept the license, then select Android SDK license, press here accept license as well, and finally press install. So now this installation would take quite a lot of time, so please be patient and I will see you once everything is installed. Okay, as you can see, all of our packages for Android SDK are installed in our computer. So the next thing we will need to do is to perform one next step, which is going to the help bar here in Eclipse, which has just restarted, and then go to the Eclipse marketplace. Simply write in the search GWT and then press the search button. Here we go. Okay, so you can see here the first result, which is GWT Eclipse plugin version 3. So just press install here and the plugin will start installing to your computer. Press the confirm button, then accept the agreement by selecting this button here and press finish. So as you can see in the bottom right corner, the installation has started. And once the installation is complete, you get an offer to restart your Eclipse, which you are going to take, and have the fresh start for the next installation. Here press install anyway, and here press the restart now button, so the Eclipse will restart. Then here press the help button, and again go to the Eclipse marketplace and we will download a tool called Gridle. So simply write here Gridle. So right here Gridle and press the search button. So we'll find the Gridle applications for our Eclipse IDE and select this option, Gridle for Eclipse 017. Press install here, and now Gridle will start installing into your Eclipse machine. Press confirm here and then accept the agreement and press finish. Now simply write in Google libgdx, which will prompt you to the web page of the libgdx. So select the first result and then select download. So here you can download the app for the libgdx. So now we started downloading, and it will usually be installed in your download folder. So I will keep it, and now it's completed. So let's select this file and see what we're going. And here is a start screen for the libgdx, and you need to do some simple things in order to start your new libgdx project, and we'll actually test it here so you're sure that everything works properly. So as a project, let's write tutorial 1, then the package name, I'll call it com Martin Y, then the class name will be game first. Okay, and here the first thing you need to do is to select the folder where you want your game to be saved. So it usually doesn't matter, but I will save it in the Eclipse workspace, okay, where all my projects are, but you can save it anywhere you want. That's completely fine. So press open here. And the next thing you need to do is to select the location of your Android SDK. So here press browse. So here usually in your names folder you can find the Android SDKs. So this is the folder of Android SDK. Press open, and that's it. Now you have your folder of the SDK selected, and you also have the location where your project will be saved. That's it. Okay, I will remove these two types of projects, so we will only have the Android and the desktop version of our game OS selected. So that's it, we are ready. Let's press generate and see what's gonna happen. Okay, let's try to change the destination here. So I will select here my name, then Eclipse, and then here I will create actually a new folder. So always do this, create a new folder inside the directory you want to write, otherwise it could delete everything in there. So what I will do here is I will write /game first, and I will press open. That's it. And let's select generate now. So as you see, we don't have any errors now, and our game will be simply created after a certain period of time. So I will see you when the installation of the game is completed. Okay, after our project is completed and it's ready, then what you need to do is to import it in the Eclipse. So here you can see on the project tab I have quite a few projects actually. If you just installed Eclipse, you have no projects there. So what you simply need to do is to select import. Okay, so here you will select import, and then keep this one existing projects into workspace. Here press next, and what you need to do here is just to add the folder of the project you just created with the libgdx. So as you remember, this project was installed in the folder that had my name in the user folder. So here is the folder, just select it, and inside it you will be able to find your project. Let's look for it. So it was called game first. So let's look for game first. There we go. So this is your project, and just select here, select folder. And after you went into the folder of our game, you will get these 3 projects available for you. So I selected here this field so you can see all the projects, and just tick all of them and press finish. Okay, so what you will see here is the first thing you will see the project first game or game first, and after that you will see all the other projects here. Okay, so just select the one for the desktop. Here we go, and here we will display all the assets needed to see your application on Windows screen. Then select the src folder, and here in the package, run this file. Run, and then as Java application. And let's see what is going to happen now. So you can see now you are getting your first test game here. And if you see this picture in front of you, this means that the LibGDX is working and you can proceed. Thank you very much for watching. Hi everyone, this is one of the first videos in this course, and today, after we had already the introduction to Java, it is time to talk a little bit about GDX, what it is and how we can basically use it. So the lecture today, the subject of the lecture today is how to create a LibGDX project and import it in Eclipse. So you already have Eclipse setup and you already downloaded the LibGDX file. So let's start now. I will select the GDX setup jar file, and then the window of the LibGDX should appear in front of you. So this is the LibGDX window, and here we have a few things. First one is the name of your file. Okay, this is going to be the folder, the name of the folder of your file. Then the main package name. Then you will define the main class. Here in the destination, this is going to be where your project is basically going to be located. Okay, so in this folder, all the files from your project are going to be saved. Then you need to have here the folder, and I showed you already how to find the Android SDKs and have the folder of the Android SDK. Then you have this tab here in which you can choose the platforms you want your game to work on. And since here we're going to basically test our games on desktop, I will always keep this desktop place selected. And the rest of the ticks, sometimes I'm gonna leave them, sometimes I'm going to remove them, it depends on the project. Then you have the extensions, and in the extensions, these are basically different libraries that you can choose whether you want to add or not inside your project. It is very simple. So if you are unsure, better select all of them so you know that you have all the extensions integrated inside your project. So let's create a simple project and I will show you how it's done. So the first project will be called intro project. Okay, then the package I will call Martin Y, and feel free to use your name here. Com dot, and then you can put your name or initials. Then the class name will be intro project. Please note here that sometimes you need to put for the name of the project, let's say 1_ and then the project name, but in the class name it is not a good practice to do this because it might not get accepted from Eclipse. And actually this is how I'm going to do it: 1_ intro project, and then the class name will be intro project. Then you need to define a destination, so go here and then choose your folder where you would like your project to be. In my case, I would like my project to be in the introduction folder that I created earlier on, but here I'm going to write / and then write the name of the folder that I want to create and place my project in. So see, if you leave everything like this, then the raw files of your project are going to be installed in the introduction folder, which is not a good practice. So here I also write 1_ intro project. Okay, and I will press open. And that's it. You can see that we didn't have this folder intro project in the introduction folder, but now once we create a project, this folder will be automatically created. I will just mention once again how you can basically find your Android SDKs. So they're usually in your computer in your folder with your name. Okay, so this is users, then the folder that is with your name. This is how you registered your computer. And here usually you'll find the Android SDKs that you installed in the previous lectures. So I'll press here open, and here we have the SDKs, and then I will this time leave Android and desktop ticks applied. Okay, and from the extensions
As I said, I usually leave box 2D only, but if in the future you create custom projects, I advise you to tick off the extensions. Then simply press generate and your project starts generating. It's important to know that in case there is some error or some message, the program will notify you, so you will know that and you will be able to change this. And that's it, your project now has been created. So you can see this message here, and also you can see that the generate button is again enabled. So you're ready. You created your project. Now I will close this and I will go in the Eclipse. So this is the Eclipse. I don't have projects here yet, but I will press the right button. Okay, so when I don't have projects, it doesn't work pressing the right button, but you see how this is done in the future. So here I will simply press import, and the usual workflow is to press the right button and then select import. But in that case, since we don't have projects, we can simply select import from the menu. Then you select existing Gridle project because you already imported and installed Gridle inside your Eclipse. Then select next once again, and here you browse the folder of your project. So here I'm in the introduction folder, and I will select 1_intro project, which was the folder created from the libgdx. Then I will select the folder. So when this finish, you can see all your folders are added here, and you have a few folders. So the first one is your project folder, which says intro project, and here you see the data of your Gridle project. We're not going to be using this folder. What we're interested in the most is the core folder. Okay, so inside this folder is your class that you generated and your initial file for running the program. Okay, and what is interesting here is that in this core folder you normally add all the classes and the packages for your game. So you basically create your game here in the core, and then in the Android and in the desktop you simply have one file. So you have the desktop launcher, and in the Android you have the Android launcher, with which you will be able to run your core code inside any platform you like. Okay, this is the idea. So we're not going to be working too much in this desktop or Android folder. It is possible that there we simply set the parameters of the window that is going to be displayed, but all the game files are going to be carried in the core project inside the src folder. Okay, also here we're going to add all the pictures, which are lately going to be implemented as well in the desktop and in the Android folders. And pretty much that's it. So if I run, so for example, this file cannot be run. If I select here run as, you don't get the run as Java program field. And this is because it's not a runnable file. But if I go to the project's desktop, and then I go to the desktop launcher, and then I select run as, I get as Java application. And if I run this file, you get a predefined project from the libgdx, which is simply a picture of the libgdx logo, and this is it. Okay, so that was everything, guys. If you get that picture, this means that you did fine and you created your project. I hope this lecture was clear, and I will see you in the next one, where we are going to discuss the SpriteBatch. Hello everyone, in the second introductory video of this course, and today we're going to be talking about two of the most important concepts in libgdx, the sprite and the SpriteBatch. And this lecture is actually going to be nothing overcomplicated. We're just going to see how a picture is getting displayed on our screen and what is the logic behind it, because this is quite different from what you're used to in Java. So here we are in our libgdx import project file, which is here, and we created it in the last section. So I'm going to remove these two things here. So this SpriteBatch and texture img are predefined, and this is the way that we are displaying actually the picture of the bet logic, so their logo, inside our window. So I will remove this because we would like to do everything from scratch. I remove this, and I also remove that one as well, and also the dispose function. That's it. Control S for saving, and you can see that now if I try to display anything, we're simply getting a red screen. And actually I will make the color of this screen different by selecting here 1 and 1. Okay, so now the color should be different. So when you select the color code to be only once, then it is white. So we'll keep it white for now, and I will create three things here. The first one will be the orthographic camera. So hover over here and then import the orthographic camera. So everything that you import is located here, as you can see. Then write SpriteBatch and then write batch, and also hover the mouse over here. Oh, sorry, batch. That's it. So this is already imported, as you can see. And finally write sprite and then sprite and then import. So as you probably know already from the introductory of the Java videos, now what we are doing is we have predefined classes orthographic camera, SpriteBatch, and sprite, and we're creating instances of that classes. So we're creating here objects. Okay, and what these objects are doing and why we use these classes. So the orthographic camera help us to see something on the screen. Okay, so the orthographic camera is showing us something. The SpriteBatch is going to draw something on the screen, so we're going to use it in order to draw some object, and the sprite is the actual object. So what we're basically doing is that we're taking this object, we're drawing it with the batch on our screen, and finally we display it using the camera. So after we set it up, these objects, now we need to write inside our create method, because we want to create them, right? So the first thing that we will set up is the camera, and let's write camera equals new orthographic camera, and the orthographic camera takes height and width of which we are going to display something. Okay, so if we would like to display the whole window inside our camera, this means that we need to pass here the width and the height of our window. So for example, the height and the width of the window are usually defined in the main file, so they are going to be different for Android and desktop, and for that reason in the desktop launcher we usually define the height and the width of the window. If we don't define it, don't worry, the window usually have predefined values, but for this test I'm actually going to define it, and you will see how this actually works. So let's write here. So this is our config file or config object, so this is how the application is set it, and let's write config dot title equals introduction, then config dot use G20. You don't need to know this, so use G20 equals false, and then config dot width equals 700, and config dot height will be equal to 400. Okay, and we don't have errors here, so this is basically how we set the width, the height of the window, and the header of the window. Okay, let's create our camera, and then we'll run the file. So we have our camera set it up. So as I said, our width and height of the window are 700 and 400, and we would like to pass this to the orthographic camera in order to display the full window. And this can be done by typing GDX dot graphics dot get width and then brackets, comma GDX dot get height, so GDX dot graphics dot get height, and that's it. So this is how from the graphics So from our window we got the width and we got the height. So we passed 700 and 400. That's it. And then once we set it where our orthographic camera is going to have a look, then we would like to set the batch and the sprite. So setting the sprite batch is quite easy. You simply need to write sprite equals new sprite batch, and that's it. Sorry, here is batch, of course. So this is how you set your batch. So you're setting how you're gonna draw your object, and then you need to set the sprite. So as I said, the sprite is the object that you're displaying, and since we are displaying a picture, then it makes sense that we refer that picture once we create it. So we need to refer the location of the picture, and since we don't have pictures yet here, we have only the bad logic one, which I'm gonna delete because I want to display another picture here, and I will actually put that picture inside the sources folder. So I would like to display this aircraft here, okay? And in order to do this, in the assets here, I will create a package, so new package, and the name will be data, okay? So now we have here the package data, and inside this package I will simply place all the pictures, and you can also place music files, basically everything you need in your project. Press OK here, and now you can see that in this file data I have this picture, okay? And how we are going to refer to it, I will show you how. So write sprite equals new sprite, and then inside write new texture. So texture is another class, predefined class, with which you're basically adding graphics into your game or application. So here let's write texture, and then simply you need to refer the file of your texture, and the file in our case is data/png aaa.com minus 2402.764.png. Well, maybe I will change the name of that picture once I upload it, because I would like something more simple for you. But yeah, here simply press the location, select the location and the name of the picture, and then we need one more bracket here. That's it. So this is how you're adding a texture inside your project. And let's sum up what we did in the create method. So what we did here is that we referred object to our sprite. So now the sprite knows to what object is referred. Then we set it up the batch, which is going to be responsible for drawing our sprite. And finally we set the camera to have a look at the whole window, okay? And this is very important. Then let's move on. So in this render method, let's say to our system what the batch actually is going to project to. So I write one line here, and it's always the same for every project, so don't worry too much about its meaning. So let's write batch dot set projection matrix, and then camera dot combined. Okay, that's it. And this is the way that you are setting up your projection matrix. It's always the same, so we don't need to go too much in depth about this. Okay, and there's one last thing. So here, when we want to start drawing our sprite, first we need to begin the batch, okay? So as I said, the batch is what we're going to be drawing our object. So we need to start a batch in order to draw any objects. So first here inside your render method, write batch dot begin. So now you begin your batch, and now the program knows that something will be drawn, and inside write sprite dot draw, and here write batch. That's it. And since we are having only one picture that we want to draw, then we would need to also end our batch. So simply write batch dot end, and that's it. This is how you end your batch. Okay, let's run now our project and see how the picture is going to be displayed. Let's press OK here, and you can see that we're having our plane. The window is obviously resized, but there is one thing to notice here. Our plane is displayed on some random location and it's not exactly centered in the window, right? So this means that we will need to set the size of this window. So the thing is, in our window, in order to be able to resize it, we first need to know its dimensions. So the window has obviously its coordinate system. So in LibGDX, the coordinate system is a little bit different. So in the middle of the window where my cursor is usually the coordinate 0, 0. And as we are going to the right side, we are getting the positive x direction. As we go up, we are getting the positive y direction, and you should know that. So here in the middle is the 0, up positive y direction, right positive x direction. That's it. This is all we need to know in order to be able to position things on our screen. So this means if we would like to display our plane in the middle, then we would need to drag the plane here down, so in this corner. So this means if our window is 700 on 400, so the width here is 700, which means we have plus 350 in the right direction and minus 350 in the left direction. Okay, and then actually let's draw this here. So as I said, we have a positive and negative direction of our window. Imagine that this is our window, and here, so in that end point we get minus 350 on 0. Okay, then here is 350 on 0. So then up, as the width is 400, here will be 0 on 200, and down will be 0 on minus 200. Okay, so if I would like to display my picture here, then I would set the locations 350, okay, on minus 200, so it's displayed in this corner. Let's try this. So let's write here sprite. So this is when we create sprite equals, or actually sprite dot set position, and then the position of the sprite will be, as we said, minus 350 on 200. Okay, so this is how we're going to position it. And I notice here in the Excel I did a slight mistake. So here is actually plus 350. Okay, so this plus here, and here is a minus. Okay, in that direction is minus. That's it. So now we positioned our picture. Let's see how it's going to get displayed. So run as Java application, select OK, and we cannot see our picture because here it should be minus 200, not plus 200, according our graph. So minus 350 on minus 200. Let's fix this and let's run the picture once again and see what's gonna happen. So now you can see that the full picture is displayed in our window, and now the corner of the picture starts from the end of the screen, which is fine and exactly what we wanted. And this is how you're positioning objects and basically displaying them. So just to sum up, once you have your sprite here, this is your object, and you can do a variety of things with it. You can actually do another action that I will just show you to be certain. You can even resize it. So if I write, let's say, sprite dot set size, and I write 100 on 20, then I resize the picture to 100 to 20, and let's see how it's going to be displayed now. And as you can see, our plane now is very small, but it's located in the same location. Okay, and that was everything for today, guys. I hope that you enjoyed that video and you learned a lot. This is the basic concept of LibGDX: to create a camera, to create a sprite batch to draw object, and to create sprite for your object. In our games we are going to use many sprites, so we're going to have a variety of objects and even more than one sprite batch option. So that was the basic here. Thank you very much for watching, and I will see you in the next introductory lecture. Orthographic Camera. Hi everyone, as we already created this kind of a dummy project where I showed you how you can basically display objects on your screen and how you can pretty much position it and resize it, and basically what was SpriteBatch, Batch and Orthographic Camera, I want to take a closer look at the Orthographic Camera itself. It actually doesn't matter what your window size is, okay, if your orthographic camera cannot display the full window. And in our case, obviously, we set it, the orthographic camera, to display the width and the height of our window, so we're displaying the full window. But imagine in some games you maybe have a map and you don't want to display the full map. You would like to display your map once your character is going along with the game. Well, we are not going to create here a hero and a character and a map and stuff like that, but I just wanted to show you how your orthographic camera is looking at your game. So let's set up different values for the orthographic camera and see how our picture position and size is going to change. Also, I must mention that the orthographic camera is normally used for 2D applications, so it is basically showing a piece of the window that you desire in 2D mode. So let's now delete what we passed to the orthographic camera, okay, and the first thing I will do is simply to set the size of the window so we see absolutely the same thing as we did before. So we pass here 700 and 400, and then I would like to remove this set size method so we get the full size of the picture. Okay, let's run our game and see what happens. So now you can see that there is no difference because we pass the same values as the window has. But what if we change these values in the orthographic camera? Do you think that the size of our window will change, or there is something else? Let's have a look. So let's change these values to 1000 on 800. And normally what I would expect, and I guess you would expect the same, is that the picture is going to resize and look smaller. So you can see the same here. Now our plane looks smaller. The size of the window is the same, 800 on 700, but the camera is showing our object from further distance. And for that reason we can see it smaller. And on the other side, if I reduce here the size, let's say if I make it 500 on 200, then if I run the application again, the camera should get closer to our object. And you can see here that the camera actually gets closer. So this is basically the idea of the camera, is to have a viewpoint regardless what is the size of your window. So you don't stick into the situation when you need to resize your picture in order to display it in your game. So yes, basically that was everything I want to share with you for today for the orthographic camera. It's quite important, and actually if you want you can play further with the camera and basically with the other objects and code that I wrote in this game if you want to get better and to really understand it. But I hope this was quite helpful for you, and I will see you in the next video. LibGDX Delta time. Hi everyone, today I want to talk to you for a very important concept in LibGDX and actually in the game's development in general, and this is the delta time. So it is very important in your game to have the delta time set it up, and I will tell you why. So imagine you have your game, a device that runs games with 30 frames per second, and on the other side you also want to run your game in a device that is running with 50 frames per second. So normally if your object is moving, let's say with 1 meter per frame, then depending on the different device your object will be moving with 30 meters for 1 second, okay, or on the other device it will move with 60 frames for 1 second, okay, because they have different frames per second. So pretty much the aim here is to make the distance that our object is passing independent of the frames but dependent on the seconds, and for that reason we can use delta time. And this is usually something that you don't need to care too much when you're creating your games, and it is usually predefined as a back process, but I want you to understand and get some idea of how the games actually work and how they can be run in different platforms regardless the frames per second that they are played. So let's do a simple experiment with the delta time. I already added private float here called delta time, and the delta time will be equal to 0 at the start. So in our render method, let's write delta time equals gdx dot graphics dot get delta time. Okay, so this is how we set this variable to be the delta time, and then I would like to display it. So let's write system.out.println and then delta time inside the brackets. Oops, sorry. Delta time. Okay, that's it. And here we're going to print the delta time. So let's run our project and let's see what is going to happen actually. And have a look here at the command line. So as you can see here, we're rendering usually, so my computer, I know that it renders normally the game with about 60 frames per second. So for that reason, every frame you see 0.016 seconds, which 0.016 is basically equal to 16 to 60 frames per second. Okay, but as you can see, this time is not always the same. Sometimes you get 0.017, sometimes you get 0.014, and so on. It is definitely not always the same. Even sometimes you are getting more frames or less frames. It depends. So this means if we have different frames and our object is dependent on the frames, this means that our object will be very laggy, because imagine sometimes it will move with 30 meters per second or with 30 frames per second, and in some other cases with 60, which is a double speed. Okay, so it will move forward faster and slower, and this will create some lag inside our game. So this is why we need the delta time. The delta time is the time between the current frame and the last frame of the game, and as you can see, this is the reason why this time is changing. So basically, when you use delta time, depending on the every frame, so if you have different numbers of frame, then the delta time is also going to be different. So if the delta time is different, then at this particular frame your object will change the time relative to the frames, but it will not change its speed. Okay, and I can prove you this. So let's create another variable here, private float distance equals 0, and then here down I will write distance equals distance plus 2 multiplied by delta time. Okay, so here we're incrementing the distance depending on the delta time. So here we're incrementing the distance with 2 times the delta time, and I will actually place this statement below, and here I want to display the distance. So let's run the code now and just analyze what we're seeing from the delta time. So I will run it here, I will leave it for a little bit, and then I will stop it. So what you can see here is the distance basically, and you can see that the difference between the distances is not pretty much dependent on the frames at all actually. So you can see that here we have 3.97, then we have 4, then 4.3, then 4.7, so it's increasing with 0.03 the distance. And this means that using delta time, we're increasing the distance of our object regardless on how many frames per second we're running our game. And this is very important. And I will make this number even more significant, so let's make it 20, and you see now the difference even more clear. Okay, here we go. So here we get 43.7, then 44, then 44.4, and you can see that the difference between these numbers is about 3.5 at any case. So this means our potential character will move with the same speed in every frame. So that was it, guys, for the delta time. You will not need this concept in order to create your games directly. This is usually happening behind the scenes, but I just want to explain you this so you understand better how your games are developed and how they work inside any device. So thank you very much for watching, and I will see you in the next video. Hello everyone, today we are going to talk about the life cycle of a game, and this is important concept to know before you jump in creating your own games. So here, as you can see, I have no additional data, and on the other side I have all the methods that are working with the game. We have create, render, dispose, resize, which is when we resize our window, pause when we want to stop our game for a second but do not kill the application, and then resume the game, which is actually connected to the pause function. We also have the ones that you probably already know, the create. This is when we create our game, so here we initialize the game, then render, and usually the rendering is happening 60 times per 1 second, which means 60 frames per second for most of the devices, or sometimes 30 frames per second as well. Then the dispose, which means that if you would like to kill an object to remove it from the game, we're going to dispose it here. And I want you to see how these methods actually work, so we're going to do today a simple test. Let's write in the create method system.out.println, and here I write the name of the method, create. Okay, so we will check when the create method is done, and then we're going to do the same for the rest of the method. So here I write render, then dispose, here I write resize, then pause, and finally resume. Okay, that's it, we're ready here. And now I will run our program, so you will be able to see when we're calling each of these methods. So here we created our window, and you can see render method is happening all the time. I will resize it. Okay, and then I will close it. That's it. So let's now analyze the data that we received. So let's actually go from the beginning. Okay, so firstly, when we create our method, we immediately get the create, so we create our application, so the create method gets called. And immediately after that, as the system needs to set the size of our window, we're calling the resize method. Then, as you can see, we get plenty of render methods, because every second we're rendering our game, as I said, about 60 times. And you can see here, if you search, you're getting called the resize method, and this is because, if you remember, I resized the window while it was opened. So once I do this, immediately the resize method is called and it starts working in the background. Okay, so once you close the game, you can see that you get this method. So you get the pause method and the dispose method. So first the application gets paused, and immediately after that disposed. And this is very important to notice here, because if you create variety of objects in your game, it is very important to add them in the dispose method, so you're sure that after you close your game, all of your objects are actually really killed and there is no processes working on the background. That's why it's important always to add your objects in the dispose method as well. And you would ask me, why do we need these methods here? Well, and how we actually get them. So we're normally getting them from the application adapter. So this sentence here, intro project extends action adapter, means that our file is implementing all the methods from the action adapter. And actually, if I press Ctrl and then select it, you can see that in the action adapter we're getting all of these methods actually. Okay, so this is the way that it works. So the application adapter has these methods predefined, and then we can use them here and actually override them, which means we can add new functionality inside these methods. So that was everything for the game structure, guys. I hope you understand it correctly, and this is actually quite different from the way we're creating games in Java, because LibGDX libraries has their special features. So I really hope you enjoyed this video and this helped you to understand the structure of the game, and I will see you in the next one. Hello everyone, since you learned the most important features of LibGDX, today I want to show you and to do some tests on how you can process user inputs inside your game. So we will learn how to press keys, press the mouse, and also scroll on our screen. Okay, so let's start. The first thing you need to do is simply to extend our intro project class also with the input adapter. So since we have all our methods here, I write here implement application listener, and I will import the application listener. Okay, and also this will extend input adapter. Okay, I think the extends input adapter should be first, so I will do it. Here we go, and you simply need to import the input adapter package here. Okay, we're ready, so we're now error free. And what we can do now is to override the input adapter methods inside, and then override implement methods, and you will be prompted to this window here, and the methods that we will be using are key down, scroll, and touch down. Okay, these are the methods. As you can see, there are also other methods like key up and key typed, but these are the methods that we are going to be using. So select here key down, scroll, and touch down, and when you press OK, you get all these methods added in here. Okay, so we got our methods, and let's delete this in order to have more clear ID. So here we will return true, and the same I will do for the next ones. So now we would like to do a simple test in order to check if these functions are working and the system is really taking the user inputs. So let's write here switch key code. So let's write here the first case, so case key and then space. So if we press space, sorry, here is keys, and then this means if we pressed space, then we would like to print space on the screen. So system dot out dot println space, that's it, and then write break, and we're ready here with this line. Then let's write another case, so case keys dot p. So if we press the P button, then system dot out dot println, and I would like to display in the console P. That's it. And this is our check for whether we pressed space or P keys. That's it. Okay, we're ready here. And then let's close that switch statement, and we'll return true. Then in the next method, in the touchdown, here you can see we're passing the screen X location, screen Y location of the touch, pointer and button. Well, pointer is a little bit more advanced concept, and this is usually when the user presses the screen with more than one finger. You know, some phones have the option to press the screen with more than one finger, and in that case the system is creating two pointers, one for one of the fingers and the other one for the other finger. But in that case, since we're still beginners and this is the introduction, I am going to create no pointers, and simply we're going to check the X and the Y location on where we touch on the screen. So let's write system dot out dot println, and here inside I write click plus screen X plus comma plus screen Y. Okay, that's it, and let's close this. So we're ready here because we want to print the location on where we pressed. And finally, let's update the scroll method. So here I will again write system.out.println, and in the brackets let's write scroll plus the, so here I will do scroll X, actually like this. So scroll X plus amount X plus scroll Y plus amount Y, and that's it. This is how we're going to display how we scrolled on our screen. Let's write a semicolon here. And finally, in order to run everything, let's write in our create method, let's write here system GDX dot input dot set input processor, and here in the brackets write this. Okay, so this is how our window is taking our inputs, and I saw some error here, so let's see what it is. Okay, let's import also the keys library in order to understand the keys, and we are ready to run the program. So I will run as Java application, press OK here. Okay, now I extend a little bit this window so you can see. So this is the window, and if I click on it, you're getting the X and the Y location of my click. Okay, if I press space, so now I press space, you get space, and if I press P, you get P, space P, space P, space P. That's it. And also if I start scrolling, see now what is going to happen. So now I'm scrolling my mouse, and you can see that is giving me the X and the Y locations of the mouse. Okay, so if I place the mouse here and I start scrolling, I'm getting -1 and 0, and this is depending on which area of the screen I am. Okay, so pretty much that's it, guys. Thanks for watching. This is the way you are setting your inputs in Java. Actually, this is the preferred way. There are other ways as well, but this is the most easy one, using these functions, and also extending the project with input adapter. And this is actually quite simple and easy to grasp. So thank you very much for watching, and I think now you are ready to start developing more complex games. Thanks for watching. Creating LibGDX game project. Hi everyone, welcome to this section where you will create your first more complex LibGDX game, which is called Money Hole. But about this I will show you just now when we go in the IDE. As you can see, I already have the game here, which is called Money Hole, as I said, and I will run it and show you what the game is actually all about. Let's run it as Java application. So once you run the game, you will basically see this screen with these doors. Actually, it looks quite nice, and the idea is to select some of the doors. So when you select some of the doors, and if another door is opening, and after that you see where one of the monsters is, then you can either change your choice and select another door, or you can select the same one. And as a matter of fact, you should always change your choice if you want to have higher percentage to win the game, but about this later. However, the idea of the game is, as I said, you have two monsters and you have one prize. So the idea is to get the prize, and the prize is a car. So if I check now this one, I got two monsters, so I lose the game, and I get the message you lose. In another situation, maybe you select the prize, so here you've got your car, and the car is displayed, so you won the game. This is basically it. And to create this game, we need to create several classes and build a comprehensive LibGDX project. But how we are going to do this? So here is, guys, all the classes that you need to have. And you can see here that first you have your core project, which I will show you how they are built in the IDE. So you have your core folder, and then you have your desktop folder, right? So in the core folder you have a few classes. You have the door class, which is going to be located in the game object package. But let's actually first talk about the packages. So you have the game object packages, you have the manager package, and you have the running class package, which you usually have for every LibGDX game. So the first what we're going to do is to create the game objects package, and inside you will create the door. Then we'll move on to modifying the running class. After that, we're going to actually create the main class, or maybe actually we'll create first the main class because it's the easiest one. So after we complete the whole three classes, we will build the game manager, and this will be your first test of the game, which is not going to be completed. And after that we'll add some game logic using the input manager, and finally the text manager to display the text inside the game. despite the classes, you need to know how the game is basically working. So we first have the initialization, which is basically the closed doors and the background and the initial text that you need to select the door. So this is our initialization part, and for this we have initialization function. After you pass the initialization and you perform some action, the system is taking input, then the initial state is updated, and then we render objects, which means that we change the way the objects are displayed depending on the input that we done. And after the objects are changed, then we go back to the take input stage, and again the system is going to take input, and then we'll again render depending on the inputs. And after we have result of whether you won or you lost the game, then the end section will be also updated and we'll reach it. And from there, actually I had to draw another arrow here. From the end section we can actually go back to initialization section, because you can restart the game, and we will add for this the restart function. Main class setup. Okay guys, so now I opened the libgdx or GDX setup file that we downloaded in the introduction videos, and I selected it to display the libgdx window. So we'll create a game that is called to_moneyhole. Then the package is going to be called com.martiny. Then the main class of the game is going to be called moneyhole. And what I want you to do is to select your projects folder, then write dash and create to_moneyhole folder for the destination of your files. And finally, you should know where your Android SDK is. Usually this is in the folder with your name in it. So mine is, for example, in Martin Android SDKs. I will deselect the iOS and the HTML options from here, and I will keep the box 2D, the desktop and the Android options available. So now I will select generate to generate our project, and I will see you after it is generated. Welcome back, our project is generated now. So what I will do is I will simply go to Eclipse, then select import, which is here. So let me deselect this first. Okay, I will select import, then existing Gridle project in the Gridle folder. Press next here, then next again, and here you need to find the folder moneyhole. Okay, so in my computer is in projects, the folder I created already, moneyhole, and that's it. And then press finish. So you can see, as all the files are with the same name, we're getting the moneyhole folder, the Android, core, and desktop. And basically we're going to build the game in the core folder as shown in the presentation, and then we're going to run it on desktop from the folder here. And for now, if you simply want to run the project on the desktop, you need to run the desktop launcher, and here what you will see if you run it, you will see the BetLogic logo. That's it. But we'll change this and we'll make this window available for our game. So I want to do some stuff before actually start coding, and the first thing you will do is to add the assets for the game. So you can see here we have the BetLogic picture, but what I want you to do is to add the pictures that are in the resources section of this section. So you need first to add all the pictures that are going to be displayed inside the game. Okay, so I actually have all the pictures now in my computer, which are this one. And the first thing I will do in the assets here is to delete the BetLogic PNG or JPG, and then here I will create a package. So new package, and the package will be called data. That's it. And now please make sure that the data is selected, and simply drag all the pictures inside this data folder or data package actually. select OK, and now you can see that all the pictures are copied inside this folder, and that's it. That's very good. We have it. So the first thing I would like you to do is to modify this desktop launcher class. Okay, I will actually delete it, and I will create a new class called main. So here write main, and this is going to be our main class. This is it. So just delete this and leave the first line. So now we'll start writing our main class. So first of all, you need to import so first you need to import com dot batlogic, okay, GDX backends. So choose this option here, dot LW JG application. That's it. And after we import this, we'll create our main class. So write public class main, and then inside you write public static void main, and then string args. That's it. And inside you write LW JG application configuration, okay, CFG equals new, and let me actually copy this because it is quite long. Okay, and that's it. Let me see if I did some mistake here. Yes, so we missed the L here. Right, L, and here L. So this is not recognized, and for that reason I will first import some other packages. So let's write import com dot badlogic dot JDX dot backends. Choose this option here, and then dot LWJG application configuration. Here we go, and now this recognized, and I will import one more package. Import com dot Martin Y dot Monty. And actually this one is not going to get recognized now, but later I will create it and we'll be able to run the game. Okay, so this need to be created by us. Okay, so let's add some parameters. Then config dot title, sorry, it's gonna be CFG dot title equals money how, and then CFG dot width is going to be equal to 800, and CFG dot height is going to be equal to 600. That's it. And we're ready here. I will actually comment out this for a second so we are able to display what we've done already. And let's run as Java application now and see what's gonna happen. Okay, nothing is happening because we need to add one more thing here. So I'll write new LWJG application new Monty CFG, and we're actually going to need to first create this Monty class here before actually running our game, because actually this Monty class will actually replace the money hole class here in the core. Okay, so in the next section we're going to create this Monty class. Thanks for watching. Monty class development. Hi everyone, welcome back to the IDE where we developed our Monty class here. So first I will comment in this, and you can see that here we have two errors in our main class, and this is because we didn't apply yet the Monty class. So the first thing I will do is I will go to the money hole core, okay, and here I will first delete this package com.martinY. So I simply delete it. Actually, let me show you how it's done with the mouse. So delete, and then simply delete the package. Okay, this package is not existing anymore, and let's create another package com.martinY dot money hole. Press finish here, and inside this package I will create a class called Monty. There we go, and that's it. Press finish here, and here's our Monty class. So let's start developing this class. It's actually not that long, it's about 15 lines of code, so you should be able to do it easily. Let's first do our imports. So let's press import com.martinY dot managers, and this is a class that we didn't create yet, dot input manager. Okay, and I will just copy this and create another class, import another class called game manager. So we get error here because the manager package is not created yet, but we will in the next sections. Then import com.betlogic libgdx. So let's import all the packages of the libgdx here, and we're ready to create our class. So I want this class to implement, so this implements application listener. Okay, and then inside let's write private orthographic camera, and then camera. That's it. So here we added the orthographic camera, and let's actually import it here. So I did a spelling mistake here, camera, and let's actually import it. So I imported the orthographic camera, and after that let's write private sprite batch, and then batch. That's it. So we added the sprite batch, and I will import it from here. That's it. And then write private float w, and then private float h. So these are basically two variables that we are going to use later on in this class. And then let's write public void create, then two brackets, and after that I'll write this dot. So in this method we use the object that is passed, so this dot w will be equal to float gdx dot graphics dot get width, and that's it. Then this dot h equals, and again in the brackets, float, then gdx dot graphics dot get height, because we want to get the height. That's it. And then here in the brackets we're going to write this dot camera equals new, and again orthographic camera, this dot w, comma, this dot h, and here simply write dot set ortho false. Okay, so basically here we're setting the camera position. Let's write here public, basically setting the camera position that we're using in order to capture what's happening inside the game. Okay, that's why we use orthographic camera, and we created this object here that is called camera. That's it. Then let's write game manager dot initialize this dot w and this dot h. Here we go. So here we're getting error because, as I said, we didn't create the game manager yet, but we will in the next section, so you will not have this issue anymore. Okay, we're ready with our create class, and let's create the next class which is going to be public void dispose. So here we will dispose the batch, and then write this dot batch dot dispose. So here we are disposing the batch, and then we will do the same with the game manager dot dispose, and then the brackets. Okay, and finally we have this last method which is called render, and here actually we're going to set what is going to be displayed on our screen. Okay, so let's write public void render, and here inside this method let's write gdx dot gl dot gl clear cover, and here let's write 1.0 f, then 1.0 f, then 1.0 f, and h is going to be 1.0 f. So here we're selecting the cover type, and then gdx dot gl dot gl clear, and here we're adding the mask which is going to be set to 16384. And these are actually variables that when you are developing the game yourself, when you think about it, are basically managed by you. So you can basically try different values of the mask and then apply them and see if your game is going to have the right positioning. So let's write now this dot batch dot set projection matrix, and then inside here write this dot camera dot combined. Okay, so here we're setting the projection matrix, and after that let's write input manager dot handle input, and write this dot camera. That's it. So here we set the input manager. Okay, and we're getting error, as I said here, because we don't have the input manager created yet, but we are going to create a class later on. Then let's write this dot batch dot begin. That's it. And then let's add the game manager dot render game this dot batch. We're ready here, and then let's write again this dot batch dot end, and we're ready with our render method. And finally we will write the resize method, the pause and the resume method. So let's write public void resize, and inside we will write final int width and final int height. That's it. And inside this resize method I will actually I want nothing, because we don't need to specify anything about the resize functionality. So then I write public void pause. Okay, so this is our pause method that we must have, and then public void resume. So here we have our resume method, and that's it. We are ready with the typing of the code. So let's now have a look and explain how this actually works, how this class is actually working. So the question is, what is happening in the code here? Well, it is actually quite simple. So first of all, we're calling this orthographic camera in order to have a good viewpoint on our game. Okay, so it makes sense since this is the file from the core class that is running it. And for that reason, we use this camera, and we use W and H as a viewpoints. And for that reason, we're adding them here. Okay, and this create function is basically the initialization of the game, and for that reason we use the initialize here, right? So once we are done with this, then we would like to display some things after we initialize the game, and here we actually render the game. So the first two lines of code, so these ones, they are basically clearing the game with the white color and then updating it to the next objects and pictures to be displayed there. We are basically calling the SpriteBatch and draw it with this set projection matrix method. And pretty much that's it. And then we're calling our managers, which we are going to create in the next video. That's it, guys. One last thing I would thank you very much for watching, and I will see you in the next video. Deep dive Monthly class development. Hi guys, welcome to this deep dive lecture, and as I explained in the deep dive lectures, I'm going to share with you a detailed explanation of the code that we are writing inside our Eclipse IDE. So in the end of this lecture, you should not have any questions regarding what we are doing in our main lectures. So as of today, we're starting this, and firstly I'm going to talk about the Monty code that we just wrote in the previous lecture, and I will simply go over it. Okay, so as you know, normally we're first initializing our variables that we're going to use throughout the project, and that's why firstly we declare the camera, which is our viewpoint for this game. Okay, so we created the orthographic camera, and then we declared a SpriteBatch object, which was called batch here. Then we simply set the variables w and h, which later are going to refer to the width and the height of our screen. As you can see here in the create method, we actually did something similar in the introductory videos, but here I did it in a little bit more advanced way. So what I simply did here is, in the create method, I declared the w variable that we declare here. I declare it to be equal to the gdx.graphics.getWidth, which is the width of our window. Okay, and also h to be equal to gdx.graphics.getHeight, which refers to the height of the window of our game. Okay, so these two values here, w and h, they hold the values of the width and the height of our window. And after that, when I create the orthographic camera, I simply pass the w and the h to this orthographic camera, and this means that the orthographic camera will display the whole window. Okay, so everything that is in the window, we're gonna see it in the full size. If, for example, I will do the width divided by 2 and the height divided by 2, this means that our distance from the object that we're going to see is going to be double the real size of that object. I hope this makes sense. Also, I set up this setOrtho function, which, as you can see when we hover over this method, actually, this sets the orthographic camera projection on the window, which is exactly what we were doing when we declared this, that we want the camera to display the full width and the height of the window. Okay, and as you can see, to this function we're passing usually the y down variable, which means that the down direction is the -1. Okay, and also you can see that here we also use this function setOrtho, which basically has some setup for our window. And this is it. I will not go too much in detail for this function, but basically we're using it in order to set our viewpoint on place, so we're sure that we see exactly what is displayed in our window. Then let's move on to the SpriteBatch. So normally, as we always do, we declare here the SpriteBatch, and this is what is going to draw our objects inside the game screen. Okay, so we declare the SpriteBatch, and finally the game manager class, we didn't use it yet, but here we initialize the game manager class, and later I will talk about this game manager class. But what we do here is simply using all the objects inside the game manager class as a sprite, or as something, as some objects that we want to display in our game. So basically here we're setting the camera, we're setting the method for drawing our objects, and then all the objects are going to be in this game manager class, and we're going to call them with the initialize function. We also pass here w and h for the width and the height of our window. But as I said, later on, when we develop the game manager class, I will talk about this in more depth. Obviously, after that, we would like to dispose our batch. So everything that we created, so we created a batch, and we would like to dispose it when we close the game, and we would like also to dispose the game manager once we close the game. So we don't have any processing processes running in the background. Then here in the render method, this function here is basically doing nothing to our game, because simply here we're setting the background color of the window, but since we're displaying picture afterwards, we're not displaying actually the background color. So this is just a standard sentence that should exist in order for our game to run. And GL clear, this I added here as a mask of the game, okay? And this is part of the GL20 class. And if you see, actually usually you can check for some function that is predefined when you press Control and click on it. So this is what I'm going to do, and you can see here that we are passing the variable mask. So this is an integer that we set for a mask. I don't think we're going to use actually that variable, but I put it there so you know that this thing exists. Then, as always, I told you last time that this is a standard statement. So batch dot set projection matrix. So in that way we're basically rendering our project, and I will show you here what it means. So this function is basically used for drawing and flashing our variables, okay? Nothing too much in depth. You don't need to know that. You just need to put it in every game that you create. Then here in the render method we are also calling the input manager and handle input. Again, the input manager is not created yet, but soon we're going to create it. So the input manager will handle all the inputs from the user. So we would like to initiate it with this method inside our render method as well. And after we are ready with that and we initialize what we wanted, then we go to this batch begin method. So remember, in order to begin drawing something on your screen, you need to write batch begin and then write what you want to display. So here everything we want to display is inside the game manager class, and we do it with the function render game. So once you have this and you displayed what you wanted, then you write end batch, and that's it. This is how you render your game and how you switch between the frames, okay? And don't worry that I guess you probably have errors here displayed. This is because I'm running currently the completed game, that's why I don't get errors. But you would get errors if you have the game manager and the input manager not ready created. And that's it pretty much, guys. These other methods are actually predefined, and basically they are not doing any job. It's just because the Monty class is implementing the application listener, they need to be here, okay? Because if you check the application listener, okay, you have all of them here inside. So once you create your game, they also need to be there. But if you don't use the pause and the resume method, you don't need actually to add any values inside them. They just need to be here. So that was it from this first deep dive video. I hope you enjoyed that sequence, and I will continue doing this so you can look at the code in more detail. So thank you very much for watching, and I will see you in the next lecture. Class development. Hi everyone, today we are going to create our door class, and basically the door class will control the doors that are going to be displayed. You remember them very good. For now we're simply going to set the doors that are closed and are going to display it in that way. And then we're going to add the function on opening the door once the player clicks on these doors. It is very simple. But let's head on to our project in the IDE, where we can start typing our code. Just one thing before starting to create the door class. I want to go back to this main class, and here instead of marty.monty, we actually wrote this package with different name. The name was marty.moneyhole. So this is what we need to write here. So I write now dot moneyhole, and here I write Monty. That's it. And now everything is accepted, which is actually quite good. Also here, after LWJGL, okay, add this. So now we are ready with that, okay? And here is our Monty class, which is completely fine. And then we have our main class as well. So the next thing we will do is to create the door class. So inside the core and inside the src folder, we will create another package, and the package will be called com.martiny.gameObjects. Okay, you can press finish here, and we're ready with this class. So with this package, sorry. So inside this package, I will create a class called door, and this is basically going to be our class that is defining the doors and that is going to call the door. So here we are in our class, and let's start typing. So first, let's import com.betlogic gdx graphics.g2d, which is our graphics, and then batch. Then we will import com.betlogic.gdx graphics.g2d.SpriteBatch. Okay, then we will import another package from the toolkit, com.betlogic.gdx math.vector, and this is going to be the 2D vector. And after that, import com.betlogic.graphics.g2d.sprite. That's it, we're ready with this. And then we write public class, and here we write door, and we start creating our door class. So first of all, let's write public sprite, and then open sprite, and then let's write public sprite close sprite. That's it. And after that, let's write public bool or boolean is open. That's it. And after that, let's write public boolean is goat. And finally, let's write public vector2 position. That's it. Actually, I'm gonna bring this back here because I want them to be on the same indentation level. It actually doesn't matter, but this would help our code. Okay, and we're ready. And now I will continue writing. So here let's write height, and then public float width. That's it. Let's write then public door, and here inside the brackets, let's write this dot is open equals false. Then this dot is gold equals false. And then let's write this dot position equals new vector 2 and brackets, and then another bracket again to close the door loop. And after that, let's write public void render final, and inside write SpriteBatch. So here we again add the render function. Here we go, and then if is open, then write this dot open sprite. That's it. Then dot draw, and then what brackets and write batch. That's it. And then again batch. Okay, then same column, and after that let's write the curly bracket, and then in the else case we will write this dot close sprite dot draw, and here in the brackets I write batch, and let's add one more bracket here. So batch in here, batch again, and let's close it. Okay, we're ready with that. And here we just need to add some parentheses, and we're ready. This is our code for the door. So here we didn't do much except we added the door parameters for open door, closed door, to check if we have gold behind the door or not, and to check if the door is open or not. And later we're gonna actually implement this into our logic behind opening the door. And then here set that when we call this class, we need to set the parameters isOpen and isGold to false, and the position to the new position of the 2D vector. Okay, so here we're creating one 2D vector. We're setting the isOpen and isGold to false, and then inside our class we are changing the render method. So we're accepting the input and then we're rendering the game depending on if the isOpen and isGold is true or not. And this is what basically this method describes. So that was everything for today, guys. You're done with the door method, and bear with me in the next section where we're going to create all of our managers and we're going to start writing the game manager. Thanks for watching. Door class development. Hello everyone, today we're going to talk about the door class that you just created. So I will just go over the variables that we created inside it. So we created two sprites for open and closed door. We also created two booleans, isOpen and isGold. We also created a vector2 for position, and we also created width and height of the door. Okay, so these are just the variables, and here they don't have any value yet. Okay, and the first two objects that you can see, open and closed door, these are sprites. So the sprites are normally objects. So as you will see later on, the open sprite will refer to door that is opened. It will actually refer to a picture of the door that is opened, and the closed sprite will refer to a picture of a door that is closed. And we're using these two sprites because, you know, the sprite is basically referring to the object that is going to be displayed. Then we have two boolean variables, and you know the boolean have values of either true or false, and as we can either open or close the door, this boolean will be true if the door is open and false if not. And then if we find a gold behind the door, we have a boolean isGold equal to true, and if not, equal to false. And then we have this vector2 method, and I actually pressed it in order to display you what it basically is. So this is how the method looks like. Okay, so what vector2 is usually used for positioning things on our screen, and if I hover over it, it says encapsulates 2D vector. So it's used for 2D objects, and it allows it's allowing chaining methods to return reference to itself, and that's why we connect it here to the position. And then we have two simple variables that are of a type float, and they are the height and the width. So we're going to use this position vector in order to create three doors on our screen. So next, after we do this, you see here that we have our constructor of the door. So in this constructor, we want always, when we set a door, to have this isOpen and isGold selected to false, and we also want to have a position of that door. Okay, and this is how we initialize a door. Then what I wrote is simply a render method in which you have two conditions. So in the one of the conditions, we check if the door is open. Okay, and depending on whether it's open or not, we're drawing the open door or the closed door. So if the door is open, then we use the open sprite and we're drawing the SpriteBatch. Okay, and if it is not open, so in any other case, we're simply drawing the closed SpriteBatch. And pretty much that's it. Quite a short class. That was the deep explanation about this one. I hope you understand it quite well. In any case, if there are more questions, please write me down in the Q&A section. Thanks for watching. Manager class. Hi everyone, today we're going to create the Game Manager class, which is basically responsible for initialization and reinitialization of the game objects. So in order to have our objects appearing on our gameplay, basically, we would need to create this Game Manager class to manage them. So here we are in the IDE, and actually now we're not only going to create the Game Manager class, but we're also going to create in the other classes, but we're not going to write them just yet. So let's create a package. In this package will be called com.martiny.managers. And that's it. We have our managers class and managers package, sorry. And then inside you can create your game manager class. Okay. Then I will create two more classes, the input manager and the text manager. So let's write input manager, and then I will create the text manager. There we go. So these are all the managers we're going to use. Obviously, I will start by writing the game manager class. Actually, we're not going to write it fully today, but we will write some bit in order to run our code for now. Let's press Ctrl S here to save the main class, and then let's go to Monty, and let's just see if there's anything else to be fixed here. I think no. So let's go to the game manager class and start writing the first bit of the code there. Okay, let's write our game manager now. So firstly, let's actually import from the game objects, let's import the door. That's it. And then let's import com.bedlogic.gdx, okay, and then we need to import some other packages as well. com.bedlogic.graphics.texture, and then we will import com.bedlogic.gdx.graphics.g2d.sprite. So we have our sprite here, and then import com.bedlogic.gdx.graphics.g2d.sprite.batch. That's it. And then let's import com.bedlogic.gdx.graphics .mat.vector3. So this is our 3D vector. And then let's import com.bedlogic.gdx utilities.array, and some more things to import: com.bedlogic.gdx utils.init array. That's it. So let's start writing the body of this game manager. So we'll write public class game manager, and inside let's write static array, and inside the array we're writing door, and then doors. Okay, and let's write a comment that this is an array of doors. Then let's write static texture door text or door texture, and here I will write a comment that is saying texture image for the door. That's it. And then let's write static texture, car texture, and here we write texture image for the car. Okay, quite simple. Here we're just writing variables. So let's write static texture, gold texture, and here we write texture image for the gold. Static vector then, so this is going to be a 3D vector, and let's call it temp equals new vector 3, and that's it. Temp vector to store the input coordinates, and this is what we're going to use this vector for. Then let's write private static final and then float, and here let's write door resize. So here what we're just doing, we're adding our main variables. So this is going to be equal to 2500f, and after that let's write private static final float door underscore vert underscore position underscore factor, and this will be equal to 3f. Then let's write private static final float and then door 1 underscore horis position and then factor, and this is going to be equal to 7.77f. And after that let's write private static final float. I know this is like a lot of variables, but we need to do this in order to start the logic. So let's write door 2 horis position underscore factor equals to 2.57f. Then let's write another variable private static final float then door 3 underscore horizontal position underscore factor, and this will be equal to 1.52f. and then let's write static float width and height. Okay, so we set our width and height, and then let's write static sprite back sprite and then static bool, so this is gonna be a boolean, has won equals to false. So has won at first will be equal to false, but then we will change it. And after that let's write public static void initialization, and inside we can write float width and then float height. That's it. And here we define this initialization method, and let's write inside game manager dot width will be equal to width, then game manager dot height will be equal to height. Here we go. And then door texture will be equal to new texture GDX dot files dot internal, and then we will define the position or the location of the picture. So this is going to be the texture. Okay, we're ready with that, and let's write now car texture equals new texture, and we're going to do basically the same. So here we will define the pictures where the car and the door are displayed. So I will do the same here, and that's it. And then let's write gold texture, so we're also going to define the gold. This is going to be equal to new texture GDX dot files dot internal, and then we will define the location, which is in our case data slash door open goat dot png. That's it. And after that, let's write init door, and we're ready here. So let's create now another method, which is public static void render game. So here we're going to actually update our game, and let's use here the sprite batch. So we're creating object of the sprite batch called batch, and here I will actually create a for loop which is going to be for the door in doors. So doors is array. We're going to render each door that is being selected. After that, let's write public static void dispose. Okay, and then let's write door texture dot dispose, and then a semicolon. After that, let's write sprite texture dot dispose, and then goat texture dot dispose. So here we're basically disposing what we've just created. Okay, let's write here the curly brackets to close this loop, and after that let's write public static void init doors, and then doors equals new array, and here we're going to create the array from door, and here let's just write a comment, initialize new doors, and add it to the array. So now here I'm going to create a for loop, and inside let's write int I equals 0, I lower than 3, I plus plus, then door dot add new door. Okay, and we're ready with this one with the init doors, and then let's write the comment set the doors display position. Okay, so here we're gonna set the display position of the doors, and let's write doors dot get dot position dot set width slash door horizon underscore factor, and this is what we just defined in the beginning of our code. Then door vert position, and then factor. That's it. Then let's write doors dot get one equal dot position dot set width dash door 2 underscore horizon position that we just created in the beginning of our code, and after that write comma height slash door vert position underscore factor. So actually I added an extra curly bracket here. Let's remove it now. So I will simply delete this one, and now this error is removed from here, and yeah, the rest looks okay. So since we're already here, let's continue with the next door. So get 2, and we're getting the next position of the doors. So dot position set width, and here we're basically going to do the same, but just with the third door. So door 3 underscore horizontal position factor, which is the position, basically the horizontal position of this door, and then the other parameter is going to be the vertical position of the door. So this is how we positioned the doors on our gameplay. Okay, and then let's write for door indoors. Okay, so this means for each door, and basically here what we're doing, actually I'm going to write a comment about that. So here we instantiate the sprite for the closed doors. and basically we're using its texture to do this. So let's write door dot close sprite equals new sprite, and inside the brackets door texture, then semicolon. Then let's write door dot open sprite equals new sprite. That's it. And then door dot width will be equal to door dot close sprite. So basically this is the method that we're closing some of the features we just opened. And here this will be equal, the close width will be equal to the close sprite multiplied by the get width of the resize factor. Okay, so this means once we select the door, it will resize. And then the door dot height will be equal to door dot close sprite, and then get height multiplied by the width slash door resize factor. Then door dot close sprite dot set size, and in the brackets door dot width comma door height. That's it. And then the last thing, door dot close sprite dot set position, and then let's write door dot position dot x comma door position dot y. That's it. And here we're basically going to set the dimensions for the door when it is opened. So let's write here door dot open sprite dot set size, and in the brackets let's write door dot width comma door dot height. Then door dot open sprite dot set position, and then door dot position dot x comma door position dot y. That's it, and we're done. So we're ready with the game manager class until that point. And actually I'm going to remove this automatically selected brackets. So now we should be able to test our code and see some data displayed. So before running the code, we just need to add here in the Monty method this dot batch equals new sprite batch. Okay, this is the new in this method. Just here, right, I have to fix my spelling mistake. And here we added a sprite batch, and let's add the application listener as well. So I applied it, and here also I noticed that we have a spelling mistake. So here is with A, so pause instead of pause, and this should be it. Let's run our code now and see what's happening. So once I run the code, you can see all the doors displayed and positioned in the correct way. They still don't have any functionality, but this is yet to change because we are going to add it in the next lectures. And this was for today, guys. So thank you very much for watching, and I will see you in the next lecture where we're going to start updating the input manager. Thanks for watching. The game manager class. Hi guys, you just created the game manager class. We're actually going to add way more information there, but I just want to explain you the code that you wrote until now. Please note that the game manager class that I'm showing you is the full game manager class with all the data added, but here we're just going to talk about the game manager class objects and code that you just created. So as you can see, the main thing we did here is to initialize our images in the game and the initial variables. So here we're first adding array of doors, Obviously we have 3 doors, so that's why we need array in order to display them on different locations. We also add this door, car and goat texture. So usually the texture files, as you can see, we here use the texture class. So the texture, as you can see, wraps standard OpenGL ES texture, and if you continue reading it, you will see that the texture is basically wrapping an object such as image that we would like to place in our game. Okay, so that's why we will need to create objects of a type texture in order to implement our pictures. Then we are creating this vector tree in order to store the input coordinates, and this means when we want to click on the door, we want to store these coordinates and see if the user has won or lost. But just think about it. For now, we're only initializing the initial parameters. And finally, I'm creating this int array object. So this is an array of integers, and here we're going to store the doors that have goats behind them. So the instances of the doors with goats behind them, but later we're going to add that logic, of course. Also here, I'm just creating the resize factors because, you know, the images that we're adding inside our game are not always the exact size. So I did some tests before showing you the game and found out that we need this resize factor for the door, and then for the goals I'm going to create another resize factor, and so on. So this was the reason why we use these resize factors. When we draw our objects, they to be the right size. You can obviously experiment once you have a picture that you want to display inside your game. You can experiment and see what resize factor you want to use for it. And then we simply declare width and height, which we are later on going, of course, to use in order to display our objects correctly in the gameplay. So don't worry about these other variables because we haven't created them yet. You also, I think, created the has won variable. So obviously this variable is false at the beginning because we haven't won the game, but later on we're going to add some logic to make it true once we win the game. So then in the initialize method we did very simple things. So the first thing I did, I wrote GameManager.width equals to width and the height equals to height. And you need to do this because remember, this one is a method. So the method, you pass values to it and then work inside, and then the method is giving you certain output. So in our case, if we want to use the width and the height that we declared earlier on, we would need to pass them from the Game Manager class. Okay, so as this is a lower level function, we would need to pass from the bigger picture, the Game Manager class, we need to pass the width and the height, and then we can use them inside this method and initialize our game. In the next 3 lines, we simply added the pictures. I think I explained this quite well already. So we're obviously using here the door texture, car texture, and goat texture, and simply applying the pictures to them with these lines. And then we are running this init doors function, which we actually declared later on. But in Java, you can declare later the function and then run it in the method before it. Okay, so that's fine. So then the render game method, we simply did the for loop for drawing each door. Okay, we haven't yet used here the text manager and restart sprite, but here what we simply do in this for loop is to display every door. So as we have an array of 3 doors, okay, so we use one picture of the doors, but an array that is multiplying it by 3, okay, we want to display each of it. So for that reason, here we say for door, so for object door, okay, and here we're using the door class, which we already defined, and for every door in the array doors, okay, we want to render it. So we run the render method. Okay, so this means that we want to display each door of this array. Then we run the dispose method. So I think so far in the dispose method we just have the car, door, and goat texture. Okay, and we dispose them obviously when we finish the game. And finally, this huge method here that we wrote. So let's talk a little bit about it. in the init doors method, we're basically creating the doors, and that's why I run it in the previous function. I think I run it in the initialization function before it. Okay, so this init doors method has first we're creating an array of doors, okay, and then we're running a for loop, and obviously our for loop is going to be from I equal to 0 until I is smaller than 3. So once I starts to be higher than 3, then we would go out of this for loop. And what we simply do here is that we're displaying each of the doors, and we're adding it actually to our array. So once we have this doors array filled with 3 doors objects, then we can simply get the first object, so we're getting the 0, and then we're displaying it. So we're using the width of the window and the scale factor for the position of that door. Then we use again the second object, which is first in the array because the array starts from 0. So we're displaying the second door in some other location depending on the scale factor that I chose, and the width and the height are the ones from the window. So even once we resize the window, we're going to get the width and the height of that game, so of the window of that game. Okay, and this is basically the way that we're setting the display positions of our doors. Then here we're adding the sprite for the closed door. So once you select a door, then you would like it to open, right? So here we simply do initialization of this closed door object. Okay, so first what I'm doing, for every door in doors, door.close sprite, and here I'm writing a new sprite texture of the door texture. Okay, and we're also creating an open sprite. So the close sprite, okay, refers to closed door, and the open sprite refers to open door. And for closed door we have one type of picture, and for open door obviously we have another type of picture. So here I'm simply setting the width and the height of the closed door, then the size and the position of the closed door as well, and the same we're doing for the open door. And this is it, guys. This was everything that we did in our Game Manager class so far. So thanks for watching, and bear with me in the next lectures. Input management. Hi everyone, today we're going to create the Input Manager class. We actually created it, but today we're going to add some more data inside it. So with the Input Manager, we actually start implementing the logic behind the game. So there we will add an appropriate structure in order to implement that logic. So here we are in the IDE, and I'm going to go to the Input Manager class that we created in the last lecture. And here I will delete this. I will keep the package. So here I import com.martiny.game objects, and here we will import the door class. Here we go, and then let's write import com.betlogic.gdx. So this is going to be GDX pack here, and then import com.bedlogic.graphics.orthographic camera. So here we're also going to upload this, and after that let's write public class. So here we are going to write the body of the class, input manager, and then public static void handle input, and then final, then orthographic camera. So basically here we're handling the input while looking from the orthographic camera, and let's write an if statement here. So if gdx.input.justTouched, so if we receive a touch input, then the game manager dot temp dot set float, and then gdx dot import get x comma float gdx input dot get y, comma, 00f. So basically here we're starting the game manager, and then let's write camera dot on project, then game manager dot temp, and after that final float touch x equals game manager dot temp dot x, and then final float touch y equals game manager dot temp dot y, and then let's write for int I equals 0, I smaller than game manager dot doors dot size I plus plus. So in this for loop, let's write final door, so we're creating a door object, and then door in brackets game manager dot doors dot get I. That's it. We're ready. Actually, I don't think I need this too. Okay, so we're done with the input manager class now. And that was it for today, guys. We implemented the most important parameters, basically the touchpad parameters, into our input manager. So thank you very much for watching, and bear with me in the next video. Deep dive, input management. Hello everyone. You just created the input manager, which is quite a good achievement. And here I am to explain a little bit what the handle input loop is all about and how we did the logic behind it. So obviously this what you created was not the full input manager, but here I'm going to explain you what you just created so you're clear about it. So basically what we're doing here is we created this handle input function, and there we're passing the orthographic camera, okay, and inside I'm writing an if loop. So here we say that if we just touched, so at the location that we touched on the screen and we're aiming to touch on some of the doors, then we're simply getting the X and the Y location of our input, so where we touch it, and we simply pass it to the game manager, okay. Then we unproject the camera, and then we set the touch X and the touch Y variables to be equal to the X and the Y variables in the game manager class. And then we simply get each variable of the game manager dot doors, okay. So we're simply getting every variable and we're putting it inside our door object here. And this is pretty much what we did in the previous lecture, guys. Thank you very much for watching, and I will see you in the next lectures. Handling the doors. Hi everyone, today we're going to talk about how we can handle the doors, and basically, as I told you, we need to implement the action of when we press the doors to open, and when we press them again, they to close, let's say. So to do this, to press the door and to see something behind it, we will need to implement some game logic. And let's head on to the IDE where we will modify the game manager and the input manager in order to do that. So here we are in the game manager class, and first of all I will go to this for loop here, and after this final door value I will add some other statement which is basically going to handle the doors. So let's say if not door, so this sign means not, is open, and handle door comma touch X, touch Y, and then I. So if this is true, so if not door is open, and this means that the door is closed, and the handle door is available, then we will do the following. So here I would like to break this statement, if this is true. And now you can see that here we're getting some error, and this is because we didn't create yet the handle door function. So we will do it now in the input manager class. Okay, so let's create it here after this handle input method is closed. Okay, so make sure that when you put the cursor here, the other curly bracket highlights, so you know that you're outside of this method. This is a very good thing to know. And let's now create our handle door method. So I write the method by public static boolean handle door, and inside, so the parameters that need to be passed are the final door. So we pass object of door of the door class that we just created, then final float touch X, and final float touch Y, and after that let's write final int door index, and that's it. These are the initialization parameters. And then let's write if touch X is higher or equal to door position, and the touch X is lower or equal than the door position X plus the door width, and if the if the touch Y is higher or equal than the door dot position Y, and touch Y is smaller or equal than door position Y plus the door dot height. Okay, so we're adding the position and the height. Then I will simply create a switch statement. So let's write switch game manager dot level, and then let's write case start. So for the word start, we're checking the following. So if the word is start, then we write door game manager dot doors dot get, and game manager here dot get gold indicates door index dot random dot is open equal to true. So here we basically select that we show the random gold, and then game manager dot level equals game manager dot level dot confirm, and that's it. We break this statement if it is true, and then in the case that we have confirm door dot is open equals true, then game manager dot level equals game manager dot level dot end. And actually I will explain you what the level value and the start and confirm is a bit later. But now let's write if not door is gold. So if we don't find the gold, game manager dot has won equals to true. So if we don't select the gold at the last time, then we won the game. Then break. Okay, we exit here, and then we'll return true. That's it. And from let's go out from the other loop and return false, and we're basically ready. So now, why we're getting these errors here? This is only because this level value is going to be now defined in the game manager, and I'm actually going to go there and pretty much set it there. So we'll go to the manager, to the game manager, and add this value level, and the value level will have the start, confirm, and the end states. So let's go there and just do it. But actually before that I noticed that we wrote too many curly brackets. So let's remove the last two, So let's remove the curly brackets here. I don't know why they became so many, but let's remove them because we will need only one curly bracket here. Okay, so yeah, this is the function, and let's go to the game manager in order to add the other parameters. So here let's first add a static variable, so static int array. So this is going to be our initialization array. Then goat indices. So these are going to be the indices of the goats, and you will see how they are implemented. Then let's create this level of value that I was talking to you about while we were in the input manager. So here I will go just below. So here I will write public static enum level, and then we're creating this enumerator level variable, which will have the following values: start, confirm, and then end. Okay, we're done with that, and then simply I'll write static level. So here I'm creating a static variable that is called that is of a type level with the object level. So here I will just need to import this level. So I just imported it. Now it should be somewhere here, I guess. Yeah, here we go. You can see it in the logger. That's it. After that, let's go just under the init doors here. Okay, so since we're just under the init doors, I will write goat indices equals new int array level equals level dot start. So let's actually go up because I think maybe I've done a spelling mistake. So here it should be without this e, so goat indices. And you know, this is normal things to do this type of mistakes in Java. You just need to use the engine in the best way so you can easily fix them and find them, of course. So what we want now is inside this init doors method you see here. So I want inside it, but outside this for loop, which is done, I want to add some variables for the whether we select a goat or we don't select a goat. Okay, so here we want some logic on whether we select goat or car, and actually let's do it. So let's write doors dot get 0, open sprite dot set region, and then get texture. That's it. And just under it, sorry, here is goat texture. There we go. And under it, let's write doors dot get 0 dot is goat true, then doors dot get 1 dot. Actually, I'm going to copy this here for simplicity. I advise you to do the same actually, because there is no point writing the same over and over again. And here the doors, okay, I'll just change this. So doors dot get 1 is goat, and here will be equal to false. Okay, and after that, for the door 2, we will put here 2 and here 2 as well, and then here will be true. Okay, so these are the textures for the open doors. Okay, and here as well we have car texture. Okay, so basically here we make open sprite with gold texture and is gold equal to true. Then when we're getting the car texture, the gold is obviously equal to false. And finally, when we get the gold texture, for example, in door 2, obviously the gold is equal to true as well. Okay, so here we're starting to write the method. So let's write public static int array get gold indices, and actually this is what the function is going to do. We're going to get here the gold indices, and let's write int select door index. So what we're doing here is that we're creating the door gold indices dot clear, and what this is basically doing is it is removing all the previous values of the gold indices array basically. So next I will do a for loop which is int I equals 0, I smaller than doors dot size I plus plus, and then what we're doing, we will just exclude here the selected doors. So let's write now if I is not equal to the selected door index and doors dot get I dot is gold, then what we would like to happen is the gold indices to be added. So we're adding the I index, and then we will return in the end of this function, we'll return the gold indices, and pretty much that's it. We're ready with this loop. Let's again just remove the curly brackets that are added here. So here what we have is this function int array, okay, and this curly bracket, I think it is closing the whole game manager, so that's fine. So here I noticed one mistake. So here instead of level, it should be level with capital letter, okay, and for that reason we had this problem here, but now we don't. So start is no longer under mark, and now this looks like it is problem free. Let's check the input manager class and see if we have any issues there. Everything looks fine. Okay, now we're going to test the game, but before running it, let's go to the Monty and enable the input manager handle input. Okay, so I will delete these slashes here. So now you're able to run this method from here, and this should enable your game to run now. Let's have a look and see what is going to happen. So basically this is your game, and if I select here, then I get the monster, and if I select here I get the car. So this means that I won the game, and this is basically the logic. We cannot yet restart the game, and we don't have background or text, but in the next sections we're actually going to do that. So bear with me to the next sections where you will considerably improve your game. Thanks for watching. Deep dive. Handling the doors. Hello guys, today we're going to talk about what we just did in the handling the doors section. So what we did, we created an enumerator with start, confirm and end values. Then down here we were setting the textures of the open doors. So basically what is going to be behind the doors, okay? And we use here this set region method which basically is going to set the coordinates of the opened door, okay, as the same as the ones that is in the gold texture, okay? So if you want to have the two textures, for example the gold and the open door, you want the opened door to be in front of the gold. So if you want, them to be displayed in the same region, then you can use this function to do it easily. And then we simply set the isGoat variables to either true or false, okay, depending on the door. So here we're doing this for each door that we have, and we have obviously 3 doors. And obviously if we have a car behind the door, so if opened sprite to the door is car texture, then isGoat is equal to false, because we don't have goat behind the door. And then here we're simply getting the indices of the goats. So firstly we clear this vector, the goat indices, so we remove all the values from it, and after that we're adding to it all the values of the doors there. So we loop here on the door.size, which is equal to 3. So let's say we have our first door, and if I is not equal to the selected door index and the door get I is goat, so if we haven't selected the door and we have a goat, then we're adding this index in the goat indices. And that was it from the game manager class. And then let's move on to the input manager class. So here you wrote the function, well, not the full one, but you wrote the function handle door. And basically what we're doing here, we're saying that if we touched on a door, so here to record our touch, we're simply saying that if the touch on X position is higher or equal than the door position X, and the touch X position is smaller or equal to the position Y minus the door width. And I'm usually doing this in order to be sure that everywhere I click on the door width, I will get my click recognized as an input to that door. And the same I'm doing in the Y direction. So there is only the area of the door that I'm interested in. And then here we're doing a switch case statement, which we talked about in the Java introduction section. And simply here we're checking if we did this section in the start. So if we selected this door in the start of our game, this means that we just want to confirm this section. So the game manager.level will be equal to confirm, okay? However, if we're in confirm state and we're checking here if there is an open door, and if there is, this means that we're in the next stage. So the next door that we select is going to be our end stage. So either we're going to win or lose the game. So in case that behind the door we don't have goat, so door.isGoat, we're using not, so this symbol here means not. So if we haven't selected the goat, then the game manager has won equal to true, which means that we won the game. So then we're going to refer to our text manager and we're going to display the text for winning the game. That was the logic behind on what we wrote so far. Thank you very much guys for watching, and I will catch up with you in the next one. Restarting the game. Hi everyone, welcome back to the IDE. Today I will show you how to restart the game. So we already included the main game functionality, but we didn't yet include the restart functionality of the game. So the first thing I will do is to go to the input manager class, and let's go to this function here, and just under the second curly bracket, let's add the restart statement. So let's write handle restart, and then in the brackets touch X and touch Y. That's it. And now we get error here because we didn't implement the handle restart function yet, but we will now. So let's go down here under the second return false and the curly bracket, and here we'll write the handle restart function. So let's write public static void handle restart. That's it. And in the brackets let's write final float touch X, and then final float touch Y. That's it. And here inside, let me fix my error here, and inside this I'll write if touch X is higher than or equal to game manager dot restart sprite, and this method is not recognized because I didn't add it yet, but we will now. So then get x brackets and touch x is more than or equal to game management dot restart sprite dot get x plus game management or game manager dot restart sprite dot get width and touch y smaller than or equal to game management or game manager dot restart. So we want to make sure that everything is connected to the restart sprite. So and touch y smaller than or equal to the game manager dot restart sprite dot get y plus game manager dot restart sprite dot get height, and that's it. So I'm just going to remove this curly bracket here, and I'm going to close this one. That's right. And as I said, we're getting all these errors here because we didn't yet included the other restart sprite function in the game manager class. So here I write game manager dot restart game, and then the brackets here. Okay, and here we'll need one more bracket. Okay, here this curly bracket actually had to be on the other side like this, so we actually open it. Okay, so now we don't get errors with the curly brackets anymore, just with the methods that are not yet implemented in the game manager class. But now I added them there, so everything would be fine. So let's go now to the game manager class, and here the very first thing I will add is just below the width and height. So here let's write static sprite restart sprite, then static texture restart texture. That's it. And then here under the back sprite, let's write static final float restart, sorry with capitals, restart resize factor equals to 5500f. Then here, just below the start sentence, so we're just above the render game method, let's write restart texture equals new texture gdx dot files dot internal, and then here we'll write data restart dot png. So this is our restart button. Then let's write restart sprite equals new sprite, and here let's write restart texture. That's it. And then restart sprite equals set size, and here let's write restart sprite dot get width multiplied by width dash restart resize factor, comma restart sprite dot get height multiplied by width divided by restart underscore resize that we just defined in the beginning underscore factor, and then let's write restart sprite dot get set position 0 0. That's it. Actually here I'll remove the other semicolon, and yeah, here I also wrote another semicolon. But anyways, this should be fine now. So we're done with that, and the last thing that is left is actually a few things. So the first thing I will do is I will go here under the door render, okay, and here I will add the following: restart sprite dot draw, and in the brackets batch, and that's it here. And after that, let's go to the dispose method, and of course we need to add the restart in the dispose as well. So let's write here restart texture dot dispose. That's it. We're ready here as well. So finally here in the very end, I'm going to write the restart game function. So let's write public static void restart game, okay, and then this is going to be the code that will shuffle the positions of the doors inside the door array, okay. So this is what I'm going to actually write here, so you're aware of this, okay, inside the doors array. That's it. And after that, let's write doors dot shuffle. So this is basically how we're shuffling the arrays inside the doors before opening them. So when you restart the game, you don't get actually the same objects behind the doors. So let's write now door dot get 0 dot position dot set, and in the brackets width, then dash door 1 horis position underscore factor comma height semicolon door vert position underscore factor, and that's it. Then doors dot get 1 position dot set, and then width dash doors 2 underscore horis underscore position underscore factor, like our variable is selected. Then comma height door vert position underscore factor. That's it. Then doors dot get 2 dot position dot set, and then in the brackets width door 3 horis position underscore factor comma height dash door underscore vert underscore position underscore factor, okay. And after that, let's write for I equals 0, I smaller than game manager dot doors dot size, I plus plus game manager dot doors dot get I dot is open equals false. Then here we're going to write the restart sprite positions. So let's do it. Let's write game manager dot doors dot get I dot close sprite dot set position, and then game manager dot doors dot get I dot position dot x comma game manager dot doors dot get I dot position dot y. That's it. And let's write that our game manager. So game manager dot doors dot get I, and then get I dot open sprite dot set position, and then game manager dot doors dot get I dot position dot x, and then game manager, okay, game manager here dot doors dot get I and dot position dot y. That's it. And then let's write game manager dot has one, and we will make this equal back to false. And after that we'll basically reset the level, so we'll set the level to start. So let's write game manager dot level equals game manager dot level dot start. Then let's close the bracket here, and let's delete the unnecessary brackets, which are these two, and that should be it. We look like we don't have any errors, so let's run the code and see what is going to happen basically. So I run it now. Okay, there is an error here. Let's see what it is. So here is get instead of got, of course, and this was the error. Let's run the code once again and see if we're going to display any errors now. Press OK here. So it seems that we don't have any errors. So you can see here the button, you cannot distinguish it too much, but once we add the background, then you will be able to distinguish it. So press one of the doors, then press the other one. Okay, you got the car, and then press the restart, and then they are closed. And if I press here, there is no car here, so this means everything is properly updated. That was it for today's lesson, guys. Thank you very much for watching, and I will see you in the next lecture, and I wish you good luck with your coding exercise in the game. Hi guys, welcome to this deep dive lecture, and today we're going to talk about the game restart code that we just wrote. So now we can simply restart our game, which is quite nice, and the main function we used to do this was this huge restart game function. So here the first thing we did is we use this shuffle function, and I will select it so you can see it. And here you have a loop which shuffles variables, and what we want to shuffle is what is behind the doors. So this is why we're shuffling our doors array, so we get the items inside, so the ghost and the car, in different places. Then we simply reset the doors position. Okay, so we depending on the shuffle, we're resetting the doors position, and this I think I explained to you that we're getting the first door of the array, then we position it and we write set in order to set the position, and we simply use the resize factors and the width of our window in order to position the doors on the right places. And then in the for loop we're looping over the array of doors. Okay, so we're looping over 3, so for every door basically we want to set the isOpen parameter to close, so all the doors are closed, and then we're resetting their sprites, or what is drawing them. Okay, so we redraw them on certain positions. Okay, and then we can start the game back on. Then we would like to restart the has one parameter to false. Okay, and also to restart the level of the game, which now is start. Remember, once we end the game, this enum becomes end, but once we start the game, it's again start, and this is what we're doing here. So basically we're resetting all the parameters to the initial ones. Okay, and obviously in the dispose function here we would like the restart texture also to end once we close the game. Then, as every other method, we would like to draw the restart sprite, which is actually our restart button, and this is where we're actually initiating our restart button. So here, if you can see in the initialize method, what we wrote is the restart texture, and we're creating new texture and then passing simply the picture of the restart button that we have predefined in our asset. Then we're initializing the sprite, okay, or what is going to be drawn, and then we set the size and the position. So the position you can see is 0, 0, that's why it's in the top left, is in the bottom right corner, and then we're setting the size, okay. So the restart sprite get width multiplied by the width and the resize factor that we use. So we simply resize the full picture of the button with our resize factor. And then yes, in the beginning we obviously have to initiate our restart sprite, which we did, and this is all about we did in the game manager class. And in the input manager class we created this handle restart function. So we created it in order to enable our input once we click on this button to detect our click, and then we to go back, okay, and restart the game. How we did this? Well, we did the same as the previous time. So see how big line of code we wrote here, but simply again what we're checking here is if our click is in the bounds of the button. So that's why touch X, we ensure that it is not higher or equal to the X location of the restart sprite or of the restart button, and we also ensure that the touch X is not smaller or equal to the same but plus the restart sprite get width. Okay, so basically in this sentence you can use it in every game, but here we're simply allowing from all the gameplay only if we press on the width of the restart sprite our computer to recognize that we clicked on something. And this is the same for the Y location of our button. This is the way I do it. Maybe there are other ways, but for me this way is the most simple and the most logical. And then if all of this is true, we simply run the game manager.restart game, and then this means that when we click, we start this restart game function, which is in the game manager, and we simply restart the game. So that was everything for today. I hope that was clear, and I will see you in the next video. Background. Hi everyone, today is going to be quite a fun lecture because we don't have actually that much code to write, but basically what we are going to do is to display the background of our game. So again we're going to update the input manager and the game manager class. So let's do not lose any more time and go to the game manager, where we just need to go under the restart texture. So let me find it. So here's the restart texture, and below it I write static texture back texture. That's it. The next thing I will do is to basically initialize the game with the back texture picture. So let's write here back texture equals new texture, and then here let's write GDX dot files dot internal, and then let's add a bracket, and inside we'll write data background dot jpg. That's it. Next, let's write back sprite equals new sprite, and then inside back sprite, and then back sprite. So here we add some methods from the back sprite. Set size, and the size will be equal to the width and the height the game. That's it. Here I did a mistake. Back texture. That's it. So now it got recognized. Okay, and the last line, back sprite dot set position 0.0 F. So our position is at the complete 0. So our picture will start from the bottom of our screen. Actually, this is what F is. It's something like coordinates. Okay, so it's used basically instead of adding here the coordinates. Then let's go to the render game method. So the render game is here, and just above the first statement write back sprite dot draw in here batch. That's it. So here's how we always add the background inside our game. That's why it's very important to be in the render game class. And then of course, as any other major function, we have to dispose it. So let's write here back texture dot dispose, and pretty much that's it. We're ready with our game management class. Let's go to the input manager class. Actually, there we don't need to add anything, if I think, because basically the background doesn't update from our actions, but it always stays there. So this should be it. Let's just run the code and see what's gonna happen. Select OK. And as you can probably see on your screens and here as well, you can see actually the background, the doors, and the restart button. So you can see that now we are selecting and everything is working fine. Actually, I got the price 2 times. Let's see if I'm gonna be lucky in the third one. I'm lucky again, and here I failed. But whatever, I mean, you can see that the game is working fine. And as you saw, we didn't have any text inside our game, so now is the time, if you remember, to implement the text manager class inside the game. So I'm going to go here in the game manager, and the first thing I will do is I will import the text manager class inside the game manager. So you can write here import com.martiny dot managers dot text manager. So here is how we import the text manager, and after that what I will do is simply to go and under this level equals level dot start, let's add here the text manager method. So let's write text manager dot initialize. So here we'll call the initialization function of our text manager. Let's write width, height. That's it. So here we added the initialization method of the text manager inside our initialization method of the game manager. Okay, and there is one last thing to do. So inside this render game method in the for loop, so for every door and doors, I would like to add the display message function, which is, if you check, this one. Okay, so for that reason here, once we have door indoors, so when we selected one door of the doors, we would like to call the display message method. So let's write text manager dot, and here we have the we should have the display message method, which is this one. Okay, and here inside I'll write batch. That's it. So we should be sorted now. Let's run our code and see if we're going to display the text. So let's run the game. So I run the main class, and you can see that now we have the text displayed, and when we select doors, we get the different messages as well. Okay, and we're getting them, most importantly, on the right place. So that was, guys, everything for this video and actually for this section. I really appreciate that you watched it until the end. I hope you enjoyed that game, and I will see you in the next section. Set background. Hello everyone, just to be certain, I decided to create this lecture as well, even though I'm sure that you understood what we did in the last one about the background, because you created so many more complex things than this. But let's sum up. First we created the back texture, okay, and this is a texture file, so obviously here we would expect that we want to add the picture of the background texture, and we actually did it here. So first we added a picture, then we initialized the sprite, then we set the size of the picture and the position. That's it, very simple. Then in the render game method we simply wrote backsprite.draw. So this is the way that we draw our picture in the render method. And finally we dispose that picture in our dispose method. So here we dispose the back texture once we close the game, okay? And that's it. That was everything you need to know about the previous lecture and the previous code that you just wrote. Thanks for watching. Text management. Hi everyone, today we are going to actually create a text management class, and this class is basically going to handle all the text that is going to be displayed in the game. This is a very good way for adding a text inside a game because all the text is controlled from a single class rather than being spread around the entire number of classes that we have. So let's not lose any more time and head on to the IDE where we will simply create the text management class. So here I am in the IDE, and this is the text manager that we already created. So let's actually implement some code. And obviously the first thing I will do is simply to import all the packages that are needed in order to basically run our code. So I will import the com.batlogic GDX graphics.gdx batch g2d batch, sorry, and then let's write import com.pub.gameObjects.door, and then let's import com.packedpub.gameObjects, or actually gdx.graphics.g2d.sprite, and then batch. After that, let's import com.badlogic.graphics.cover, and that's it. And after that, import com.bedlogic.gdx.graphics.bitmap font, and here is how we're gonna add our fonts basically. So let's write now public class text manager, and here let's write static bitmap font and then font, and after that let's write static string start. So here we simply set our variables that we're going to use later, and then static string buffer confirm, and then static string win, then static string loose, then static float width, let's write width here, and then static float height. That's it. And then let's actually create a static method. So static text manager dot start equals select a door. So this is going to be our start message. Then text messenger dot win equals you win. Okay, and then text manager dot lose, and the message will be you lose. Okay, we're ready with that. And now let's move on. So I'll create a public static void initialize. So here we're going to implement our initialize method, and then final float width, then we're going to pass final float height, basically what we have in the other managers. Then right here text manager dot width will be equal to the past width, and then the text manager height will be equal to the height. And after that, let's write text manager dot font equals new bitmap font dot set color, and inside let's write color dot cyan, so this is a type of color basically. And after that, let's write text manager dot font dot scale, and in the brackets width dash 1600 f. Then text manager dot confirm equals new string buffer. There we go. Then you selected door number, and do you want to switch? So this is going to be a message. Once you select one door, this message will ask you to select another. And then let's write public static void display messages, or display message actually. So here let's write final SpriteBatch, then batch. Let's now write switch, then game manager dot level, and this is the level variable that we used previously. So here we want the first case, so in case start, so this means when we start the game, select text manager dot font dot draw batch, and here inside write comma har sequence text manager dot start comma, then again text manager dot width divided by 2f minus 50, and then let's write door in brackets, then game manager dot door dot first, then close sprite dot get y divided by 2 plus 20. And basically this is how we define our first case when we start, and this is how we define exactly that text. And after that, let's write what's happening in the case confirm. So here write text manager dot font dot draw, and inside batch, and then batch comma, then har sequence text manager dot confirm comma text message dot width divided by 2 minus 2050, sorry. That's it. And here obviously we're going to write the confirm message that we predefined in the previous lines. And here let's write door game manager dot door dot first close sprite, so we close our sprite, and then write brackets divided by 2f plus 20 again. And let's go now to the next line. So now we write break here, and then let's write another case. So in the case end, we would like to have an if statement here. So here we say if game manager dot has won. So if we're in the state has won, then so here we have actually two ifs. So in the case we have has won, then I'm writing text manager dot font dot draw batch, and inside we're going to define the parameters with which we're going to draw our batch. So here character sequence text manager dot win. Okay, so here we take the win keyword, which is you win, and then text manager dot width divided by 2f minus 50. So here is how we define actually the size of our font, comma, door game manager dot doors dot first, then close sprite dot get y divided by 2f plus 20, and then let's try the break. And in the other case, we have text manager dot font dot row. So if we didn't win, so if we are out of this statement, we write batch, then here har sequence text manager dot lose. So if we didn't win, obviously we lost the game. So here we would use the word lose, which is you lose, and I would just define the width and the height of that word basically. That's it. So here I write game manager dot doors dot first, and then close sprite dy divided by 2f plus 20. Okay, and since we're already here, now I can write public static void, and this is another method, set selected door. Okay, and here we're going to pass final int door index. Okay, and here I write text manager dot confirm dot insert text manager dot confirm index of, and then the door plus door number dot length. Okay, and this is the way that we're going to define exactly where the text is going to be displayed and how. Okay, and actually here we have semicolon to close this, and then there is one more. No, actually there is only one here. Okay, and we're getting some errors. Let's see what they are. So here in the close sprite, so here I think so the problem here is that we need to remove this dot here, and we need to place it here before close sprite, because it's obviously first dot close sprite dot dx and dy. So here place dot, here dot as well, and here dot as well, and the problem should be removed. As you can see, we're now problem free, which is quite good. Okay, we have one more error here in the draw. Yeah, and this is because I have one dot here, so I will just remove it. And let's see if we are going to have problem here. So now it's not underlined, the draw method. And pretty much that's it, guys. Let's see here. Again, we've got too many brackets. Okay, we need one more. So we have one that is closing this loop, and the other one I think is closing the whole class text manager. That's it. Okay, we're ready with the text manager class. Okay, and here I made the mistake, so here should be Martin Y. So very good job for today, guys. And in the next lectures we're going to develop the update method, and also I will implement this text manager class inside the game manager class in the end of the game, so you're able to display it. But about this we'll talk in our last video of this section. Thanks for watching. Text management. Hi guys, you just created the game manager class, and I wanted to give you a little bit more in-depth explanation on what we did. So usually when you're using text manager, one of the most common practices is to use bitmap font, and this is because with the bitmap font you can use predefined set of fonts in your game, and this is what we did here. We used a specific font which we added colors to. Okay, so you can use all the functions of the bitmap font. So this is basically a class that handles fonts. And then we simply added some variables like start, confirm, win, lose, and obviously width and height. So start obviously when we start the game, win when we win, lose when we lose, and these are strings. So these strings, we set them to have some value, and these were actually the text that was going to be displayed on our screen once we start, win or lose the game. So this is here is just a setup of our function, and then we started the big deal, which is the initialization of the function, and then displaying the messages. So obviously here in the initialize function, I don't need to say that you need to initialize the width and the height that you are passing to that function from your text manager. So text manager.width will be equal to the pass to width here, okay? And the same with the height. Then we also added the font as a bitmap font, and we set it the color of this font. Then we scaled our font with the bitmap font functions get data and set scale. So if I select the set scale here, you will see that we're going to the bitmap font, and here you can see the function set scale, and this is the way that you scale your bitmap font. So in every class like this, like the bitmap font, you would have these different types of functions that you need to explore in order to work with this class, and set scale is simply one of these functions. And then here we instantiate a string buffer in order to connect the confirm keyword to this string, which is going to be our initial message, okay, that we selected a door. Actually you selected a door, and then we were going to give option if we would like to change our choice, okay, and this is going to be displayed after selecting the first door, obviously. And then what I do here is I'm simply drawing each font, okay, and depending on whether we were in the start, confirm, and the end stage of the game, I'm drawing a different font. And how we draw a font? By writing text manager dot font dot draw, and then we simply draw the batch here, okay. And then what I'm doing next, I'm writing text manager dot start, so we're displaying this message, okay, select a door, and I'm casting, this is called casting, so I'm sure that the variable here is char sequence, okay, and char sequence is basically a sequence of characters. So I want to change this from string to char sequence. And then the next thing we're doing is simply setting the width and the height of this font. So text manager dot width, so the width that we already defined, divided by this scale factor by 2 minus 50, okay, and I decide for myself and also by tests that these are the good sizes of the fonts, okay. And I explain you the first one, and for the next ones it's absolutely the same. It's just we're in the different stages of the game, so we would like to display different type of font. So here we can choose either has1, or in the confirm stage we would like to display the confirm text, which is basically this one, okay. And in the last function we're simply selecting the number of the door. So that's it, guys. This was everything from the text manager. Obviously after that I'm sure that you understood that we needed to put it in our game manager class in order to initialize the text manager and then to render it, obviously. So that was it, guys. I think it was actually quite simple, and you understood absolutely everything of this game. Again, in case you have any other questions more than this what I explained, please ask in the Q&A and I will be very happy to help you. Thanks for watching. Overview: creating mole game project. Hi everyone, today I'm going to show you a very interesting game that is called the mole game, and you can see it actually in front of your screens right now. So the idea of the game is basically when you hit the mole, then you get this sign that you hit it, and after that you can have your score, which is collected over time, so you are gaining points. If you miss the mole, which means that the mole went inside the hole, this means that you are not getting points, so your result doesn't get updated. It is that simple. I guess you played this game. I think there are some mechanical types of this game, so you probably had it before, but now you will be able actually to complete it on Java. So here's what you learn from this section. So the first thing you learn is how to work with the covers and set the right covers for your LibGDX game. Then you learn how to animate the game characters and basically set up the initial screen of the game, and after that build your components inside it. Then I will teach you how you can add some randomness to your objects. So we will learn how to use the random function in order to place our objects at random places. Then you again learn how to play sounds. Actually, this we didn't cover in the last section, but now we will add some sounds in this game. And finally, I will show you how to use new techniques in order to display your score and to collect it basically. So here actually all the sections or all the videos that you are going to see in this section, and I just wanted to go over them so you have some understanding of what we're going to be doing in this section. So firstly, I will show you how to set your project to create your LibGDX project, and after that you will create the mole class character. This is the first thing that you will do, and also you are going to create the cameras and the viewpoints. Actually you are going to do this before creating the mole, because actually this is the initial part of every game. So first you are going to create the cameras and the viewpoints of your game. After that you are going to create the class of the mole, so you have it defined. Then you develop the game manager, which is actually going to manage the actions that are happening inside the game. After that you will be developing a way for you to display the host, and actually this is going to be the first time you are going to launch your game, even though it was not ready. Then you learn how to animate the mouse to appear up and down from the host. Then we're going to move on displaying the game score, and then we're going to add the sound and the text inside the game. And this is basically everything we're going to cover in this section. I hope you enjoy it. And so let's not lose any more time, and I will go to my computer and we are going to create the project and set up everything we need for this game. So see you in the IDE. Here you can see my screen, and the first thing I will do is to select the GDX-setup so we can create our LibGDX project. So you can see now the LibGDX screen, and let's type the name of our game, which is going to be 3_mole. So this is how the game is going to be called. And then let's write com.martiny.mole. That's it. And then the game class is going to be called mole. Okay. And after that, let's set the folder. So here I will take the folder. Let's set the folder to be in our project directory. So here we have our directories. Okay. And let's select the project one. Projects. Okay. So now we're in projects, and write a slash and then write mole, or actually 2_mole. That's it. So press OK here and you're done. This is all the setup you need to do. I hope you set it up already your SDK folder to be on the right place. We did this in the introduction, and I'll actually remove the Android, the iOS and the HTML files because we're working from desktop and we want the game to be displayed from the desktop. And then I will select generate. So now the game starts to generate. Now our project is ready, and let's actually import it inside the Eclipse. So here I am in Eclipse, and I will select the import button. Then select existing Gridle project, press next, then next again, and here let's select the game we just created. So I will go to projects, and then I will select 2_mole. Actually it had to be 3_mole, but it doesn't matter. I hope you did it with 3. It will not make any difference. Then select finish. And we're done. So you can see now the folder of the project, but we're not going to use that. It's called _mo, but the one that we need, the core and the desktop folder, are fine. So let's first just test if the project is working like it is. So we want to see the BetLogic logo. Let's run the project now. So here we see the BetLogic logo, which means that we properly installed our LibGDX project in Eclipse. Let's close it now. And before ending this video, I just want to import all the pictures and sounds that are for this game. So please download it from the resources, and from there you have two folders, and I will actually show them to you. So here I'm gonna go to my folders, and here you have the data and the sound folders. So these two folders, you can actually import them into the sets of the game. Okay, so what you can do here, and actually this is a different way comparing to the last time. So what you will do here is simply select these folders and drag them to the sets folder in your mode desktop. Okay, so I will drag them here, then copy files and folders, and here you get these files as packages. So in the data package you have all the pictures, and in the sound package you have the sound that you are going to be using. Just to mention, if you want to use another sound, please make sure that it is in the WAV format. Okay, this is very important. So that was everything for today, guys. I hope you managed to set up your game, and I will see you in the next video where we're going to start to code. Thanks for watching. Game Cameras. Hi everyone, today we're going to create one very common class for actually every LibGDX project. And this is going to be the class that is basically selecting your viewpoint in your camera. You cannot avoid that, and you need to create this for absolutely every game. So our class will be called Racamo class, and as I said, it will create the viewpoints and the cameras. So this is the basic sum up. Let's head on to the IDE where we will create that class. So here we are in the IDE, and go to this Mo core folder. So here inside in the src folder we have this com.martiny.mo. So I'll actually delete this package, okay, and I'll create a new one. So let's create a new package, and the name of the package will be com.martiny.wacamo. That's it. Press finish here, and inside this class we're actually going to create our Wacamo class. So here Wacamo, that's it, and press finish here. So here we have this class, and now I will start adding the data there. So the first thing that we will do is to add the package. So package martiny. So I will just go two places, two lines under the package name, and I will basically start writing the imports for that class. So the first thing I would like to import is a library from the BetLogic, and this is the GDX application adapter library. So this is what I'm doing right now. And then let's add another library which is called com.betlogic.gdx. Then let's import another library which is called com.betlogic.graphics.gl20. These are some of the libraries we will need. Another one, com.betlogic.gdx.graphics. And here we're going to import the orthographic camera. There we go. And after that, let's create the import.betlogic.graphics.g2d.SpriteBatch. Okay, and after that let's import com dot martiny dot mo dot managers dot game manager. We'll get error here actually, but this is completely normal because the game manager is not created yet. So let's create now public static rackmo, and this will obviously extend the application adapter, which is very common for the for this type of class that is setting up the cameras. So here I will create a SpriteBatch batch, and then let's create SpriteBatch for. So here I'm just writing an explanation. So this is the SpriteBatch for the drawing, and then I will create the orthographic camera. So here what I'm creating is camera object of the orthographic camera type, and let's create now a method which is called public void create. That's it. And this with this method basically we're going to get the window dimensions. So here we're basically going to create our initial objects, and yeah, let me just write the description. So here we're getting the dimensions and the viewpoints as well. That's it. Let's write now float height equals gdx dot graphics dot get height. Okay, then float width equals gdx dot graphics dot get width. So basically here we're getting the height and the width. Okay, and the next thing we will do, and I'm just writing it for you, we will set the camera viewpoint. Okay, so that's why I'm writing this, so you know it for reference actually. So camera equals new orthographic camera, and inside the brackets write width and height. There we go. And then we'll write center the camera at width divided by 2 and height divided by 2. So this is what we're going to be doing. So here what we're doing is camera dot set ortho false, then batch equals new SpriteBatch, and then the brackets. So this what we wrote here is the initialization basically of the game. So let's write now game manager, and here very possibly we will receive an error. So game manager dot initialize width and height. Okay, and after that we're going to create another method. Actually we're not creating it, but we're overwriting it. So this method already exists, but we're going to override it with our data. So let's write public void dispose. So we're going to override the dispose method. So super dot dispose, and what we're going to be doing here is simply to write a method that is disposing the SpriteBatch. Okay, and this is what we are going to do. So let's write here batch dot dispose, then game manager dot dispose. Basically everything we're creating we would like to dispose. After that we're writing the method that is called public void render, and then brackets. So this is our render method. So basically this is a method that is clearing the screen and then updating it. So this is why I'm writing here clear the screen, and then let's write gdx gl dot gl clear cover, and inside let's write 1 1 and 1. That's it. And then gdx dot gl dot gl clear, and then inside g20 dot gl underscore cover underscore buffer bit. That's it. And then what we're going to do is basically to set the SpriteBatch. Okay, So I'm just writing here this for your reference, so you know what is happening. And actually, when you go back someday and see this code, you know in each section what you wrote. So basically here we're going to set the sprite batches for the cameras, and then batch dot set project matrix, actually projection matrix, camera dot combined. And this is actually pretty similar to the previous project, so I want you to do these repeated things in order to get familiar, and next time when you need to create the game to be very simple for you. So let's write here. Now I'm creating the game object. So batch dot begin, then game manager dot render game, and here let's write batch. That's it. Then batch dot end, and that's it. We're completely done. I'll just leave these brackets. So as you can see, all the errors that we received are due to this, and it's always very important to mention that. So the errors we received are due to the fact that we don't have the game manager yet implemented in our project. Okay, but everything else is pretty common. So usually always in the class that is defining the cameras, you have this create method, which is basically initializing the screen. So that's why we use here the game manager initialize width and height. After that, you have this dispose method to say to the compiler what is going to be done once the batch and the game manager basically get out of scope and you want to dispose them. Okay, so we're setting this container here, and then we just have the method that is saying what is happening if, let's say, you complete certain action. So this is the render method, and basically with this method the screen is updated once certain action is performed. Okay, and just to be certain, before finishing off for today, I'm going to go to the mo.desktop, sorry, mo-desktop, and I'm going to go to the desktop launcher. Okay, and here you can see that we have predefined mo, but we actually changed this class to Racamo, and we would like the desktop launcher to launch this file here. So let's change this to Racamo. That's it. And the next thing I will do, because we still have this error here, you need to create the class that you imported. So this is usually predefined, and as we remove the previous package, we would need to import it again. So here I will have the package.com, com dot martiny dot rack a mo dot, and here I will basically import this class rack a mo. That's it. Okay, I'm usually not using too often the suggestion mode of Java, but you are probably going to get suggestion that you can select the Racamo class here. So that's completely fine. So as you can see, we're error free here now because we updated everything. I will just save it with Control S. But here you can still see that there is one error, but once we update the other classes, so the RackAmo class here, this error is also going to be removed. And here you can see that after we saved, actually, so we got an error, but after we saved the RackAmo class, then this error disappeared. So now we're error free here again. And that was basically everything from today. It's normal that you have errors here. They will disappear once you add the game manager class, but that was it for today, guys. So thank you very much for watching, and I will see you in the next video. Creating the Mo class. Hi everyone, today we are going to create the Mo class, and this class is basically going to define how the Mo is positioned and how the mole is basically displayed on your screens. So in this class is common that we're using the pictures that the mole is going to receive, and later on we're also going to add some logic here in order to perform the actions that the mole is going to do. So here we are back inside the game, and let's go to the mole core, and the SCR folder, let's create another package. So the name of the package, like we did in the last game, is going to be called com.martiny.gameObjects. So here are going to be all the game objects in our game. Luckily we have only one, so I'll press finish here, and inside I will create a single class that is called mole. That's it. So we have our mole class here. So here we're going to create a new package that is going to be called, like the last time, com.martiny.gameObjects. So okay, I missed T here, martiny.gameObjects. That's it. So let's create it, and here we have it. So inside this package I will create a class called mole. So luckily here inside this class we usually are adding all the objects inside our game. Luckily here we have only one object, so this is going to be our only class here, the mole class. That's it. I will delete this here, and let's actually the first thing we will do is just to import the libraries that we need. So let's right now import com.badlogic.gdx. That's it. Then import com.badlogic.g2d.sprite. So we're uploading the sprite. Then let's import the com.badlogic.graphics.g2d.spriteBatch. Okay, and after that let's import another package, so com.badlogic, and everything here we're taking from the libgdx folders, .mat.vector2, so we're uploading the 2D vector. And then let's import com.martiny.managers.gameManager. And here obviously we're going to get an error because we don't have this class yet, but we will. So let's write now public class mole, and then inside let's write public sprite mole sprite. That's it. And then I will just add a comment here, I hope you don't mind, so you know in the future what this is it. So this is the sprite that displays the mole, okay? And after that let's create public vector2 position equals new vector2. So we're creating an object vector2. And why I'm doing this? Well, it is actually very simple. So the vector2 is created to control basically the mole position, so it will hold the values for the mole position. Then I will create the public float height and width values, and these are basically going to be the height and the width of the mole, or I'll write here the mole dimensions, so you know. And then let's write public float, then scale factor 4000f. This is going to be a scale factor for the mole, okay? And here I will create an enumerator state, so the state will have the values of going up, going down, underground, and snet. Okay, so this will basically control the values whether the mole is up, in the middle, or down in the hole. And I will create a state object, so state will equals to state go up. Then I will create a float, so public float current height is going to be equal to 0.0f, so this is the current height of the mole. And then I will create another float which is going to be called speed and this speed is going to be equal to 2f, and basically this is going to be the speed that the mole is moving in the hole. So that's why I'm writing speed of the mole as it goes up and down. Okay, and then let's write public void, and this is going to be actually a method. So we're going to create the update method here, and I will again write a comment. So here we're going to draw some positions of the mole depending on the height. Okay, so here I will write mole sprite dot set region 0 0, and inside I will write an integer width divided by scale factor, comma, int, then current height, which we defined, divided by again the scale factor. Okay, and then again mole sprite dot set size. So here we're going to set the size of the mole. So I write here mole sprite dot get width, and then since we got the width, we will add the current height, and we are ready. That's it. Then let's write public void, then render, and here we will add our render method. So here it is, render SpriteBatch. Okay, and here I will add mole sprite. Okay, then draw, and here we'll draw the sprite batch. Then I will write public boolean handle touch, and with this function we're basically are going to handle the touch that we're going to develop actually later in this course. So I'm writing here float touch and float touch y, and then if the touch x is higher or equal to the position x, and the touch x is smaller or equal to the position of x plus the width, and the touch y is higher or equal than the position y, and also if the touch y is smaller or equal to the position y plus the current height, then, so if all this is true, so this means that we touch the mole, then we'll return true. Okay, so we had touch, and in any other case we'll return false. That's it. Wait, I have some brackets here left. Let's see if we can avoid them. So it's normal that we have error here, because we need to add some other stuff as well in order to make this method running. So let's press Ctrl S to save everything, and now we're ready. The only thing that I made here, and I could say it's a mistake, here is not mole, so delete mole, because what I'm thinking is to create this class martiny.managers without the mole keyword. Also here there are some errors that we need to fix in the mole class before going. So the first thing is that I noticed that we have here one extra curly bracket, so they should be 2 before the final, and then here I accidentally added extra semicolon. Okay, and here as well, and here as well. Okay, so let's save it now and see if we're still going to get errors. Okay, we still get errors. Let's see what the problem is. Okay, so the problem is that we're not exiting this method here, so I'll add a curly bracket here, so the method is exited properly and closed. Okay, so please add a curly bracket here, and please make sure that before the end you have both curly brackets, and also you have only one semicolon after each variable selected. So thanks for watching, and I will see you in the next video. Managing the game. Hi everyone, today we are going to create the game manager class, with which class you are going to be able to manage all the components inside the game. Obviously we're not going to create the full class, but we're going to create the most important foundation, in which later on we're going to add more objects and rendering features that we can use inside the game. So let's head on to the IDE now and let's start making the game manager class. Here we are in the IDE, and the first thing I will do is actually to create the manager package. So let's go here and select package. So let's write com.martinY.managers. Okay, that's it. We create our managers package, and here I will create 3 classes. So the first class is going to be called game manager. There we go. Next, we're going to create the input manager. Here we go. After that, let's create a new class called text manager. Okay, so now we're sure that we have all our manager selected and created basically. But now I'm going to go to the game manager. Okay, and here inside I'm going to start creating the game manager class. So here we are inside the class. Make sure that you select it, and now you're updating the game manager class. And as always, I will delete this line here. And now the first thing I will do is obviously to import all the packages. So let's import com.bedlogic.gdx.gdx. Then let's import the next package, com.bedlogic.graphics.texture. There we go. And then let's import com.bedlogic.gdx.graphics.g2d.sprite. Then I will import com.bedlogic.gdx.g2d.spriteBatch. And actually guys, this is going to be a long class to create, so I advise you to take a comfortable chair, concentrate, and really type with your full motivation. So let's import now the next class, com.martinY.gameObjects, and here we're going to import the mole class. That's it. And then let's write public class game manager. Here we go. And after that, let's write static array mole, and here mouse. Okay, so here what we're doing basically is we're creating array that is of the mouse. Okay, and the next thing I will do is to create a static texture mole texture. That's it. And then let's write here texture image. So here we're basically going to add a variable for the image of the mole, and then let's write another variable which is going to be a static texture background texture. That's it. And then 2 dashes texture image for background. That's it. So as you can see here, we're simply creating texture objects for our images that we are later on going to add. But let's concentrate here. Now I'm adding the sprite background. So sprite background sprite, and this is going to be obviously the sprite for the background. It makes sense, right? That's it. And then let's add some more variables. Actually, we're going to add here quite a lot. So let's add texture, whole texture. And here let's write texture image for background. That's it. And then let's write static array, and here let's write sprite holes or whole sprites. That's it. And then write array of whole sprites. Okay, we're ready with that. Let's add next private static float. That's it. Float mole resize factor, and this will be equal to 2500f, then private static, then write float, and here mole vert position underscore factor, and this is going to be equal to 3f. So here we're simply adding the factors we're going to be using later on. And now another factor, which is going to be called mo1 underscore horis position underscore factor 5.8f, then private static float, and then mo2 underscore horis underscore position factor, and this is going to be equal to 2.4f. There we go. Then for the next mo, we are going to create private static float mo3 underscore horis position, and this is similar to what we did actually to the last game. Underscore factor equals to 1.5f, and then let's create another variable which is called private static float how underscore resize factor. So this is obviously going to be the resize factor of the whole 1100f. Then let's create public static integer score, and this is basically going to be the variable which is going to carry the score of the game. That's why I wrote here score counter. There we go. And then public static void, and this is going to be a method. So here we're going to create the initialization method, so initialize, and this method will take the variables float width and float height. Here we go. And then let's write score equals to 0, then mouse equal new array mo. There we go. Then mouse texture will be equal to new texture, then GDX files dot internal, and here I will basically call the file that is for the mole. So here's how we're displaying the mole basically. Then here actually I will write a comment because I want you to remember this. So here what we're basically doing is we're creating a new mouse and we're adding them to the array we've just created, and I will show how this is done. So let's write a for loop. So for I equals 0, I is more than 9, and I is incremented by 1, mouse dot add new mole. That's it. And here's how we're going to create actually 9 moles from the one we have. Then I will simply write here background texture equals new texture GDX dot files dot internal, and here I write data slash ground, and here's how we're going to display the ground. Then background sprite, so we're going to create here the background sprite, and this will be equal to new sprite, and inside write background texture. And actually here, just to be certain and you remembered it, I will write a comment saying that this is the set background sprite. So here is how we're setting the background. But once we set it, we also need to add its dimensions. Okay, so here we're going to find its dimensions and position. So let's write here background sprite dot set size, and here's how we are going to set the size, and here write width and height. Okay, and these are predefined values. So background again sprite dot set position, and here is how we're going to position basically the sprite. So here I write 0 on 0. This means on the bottom left corner. This is how we usually display background. Then how texture equals new texture GDX, and here we're basically going to add the how in our game. So here is how we assess the how, and since we have the mode, the ground, now we have the how as well. So let's now create the how sprite, and we'll add new array sprite, and in this way with this for loop now, so I'll create a for loop from 0 to 3. There we go. And once I do it, you can basically call one how on the 3 positions that you have at the same line. Okay, so we're doing here the nested for loop, and I'm doing this simply because I want to display it on 9 positions. So I want to make a square that has 9 positions, and on each position I display one how. There we go. So I created here a new sprite and with how texture, and this is how we're creating the holes on different positions. So here I will simply write a comment so you remember that. Okay, so yeah, I think this is going to be fine, so you're aware. There we go. Next, let's write sprite dot set size, and inside sprite dot get width multiplied by width divided by how resize underscore factor. There we go. Then let's write sprite dot get height multiplied by width divided by the whole resize factor, which we just created in the beginning of the code, and that's it. Now let's create let's now define the position of the holes. Okay, so I write here a comment, of course, because I want you to remember what we're doing here basically. So now here I write sprite dot set position width multiplied by j plus 1 divided by 4f minus sprite dot get width divided by 2, and here is simply we're setting the parameters of how basically the holes are going to be centered on the ground, right? So here minus sprite dot get height, then whole sprites dot add, and here is how we're going to add the whole sprites, and inside write sprite. That's it. You don't need to know actually these calculations because obviously it's not part of the programming, but this is basically how we use the set position and what parameters. Anyways, let's create here a for loop, and inside it we're going to loop from I equals to 0 until I equals to 9. So let's create here an object from the class mo, and we're going to get I, so we're going to get the current value of I, which is going to change obviously. Then let's write sprite, so we're creating object sprite here, and we're doing basically the same, and this is going to be equal to whole sprite dot get I. Okay, and I is going to change its values from 0 to 9. Okay, next let's write mo dot mo sprite equals new sprite, and inside the brackets write mo texture. That's it. And the next thing we will do in this for loop is basically to set the dimensions of the mo. So let's write float scale factor equals width divided by 4000f, then mo dot scale factor, and this will be equal to scale factor. Okay, there we go. Then mo dot width is going to be equal to mo dot mo sprite dot get width, so we're basically getting the width of the mo, okay, multiplied by the scale factor that we chose. And then the next thing, let's write mo dot height equals mo dot again mo sprite dot get height, and here's how we're going to get the height transferred in the game manager class. That's it. Then let's write mo dot mo sprite dot set size, and in the brackets let's write mo width and mo height, and this is how we're basically setting the size of the mo inside this for loop. Okay, so since we set the dimensions of the mo, let's set the position. So let's write mo position x is going to be equal to 2 multiplied by sprite get x plus sprite get width divided by 2 minus mo dot mo sprite dot get width. And this is something that I estimated myself before starting this code, so again you don't need to remember this calculation. And the same we're going to do for the y position. So I define it by sprite dot get y plus the sprite dot get height divided by 5f, and that's it for the y position. And the next thing we will need to do is to write mo dot mo sprite dot set position. So we're actually going to use the positions to set the actual position of the mo dot position dot x mo dot position dot y that we just defined in the previous 2 lines. Okay, here I closed this for loop, and actually I closed the whole method, and now we're going to create a new one, which is going to be our render method. So let's write render game, and inside let's write SpriteBatch, and here batch again. There we go. So let's write here background sprite dot draw, and inside let's write batch. Okay, and the next thing we will do is simply to render each hole, and for this we will need a for loop. So let's write for sprite in hole sprites. So we're taking each sprite of the all hole sprites. So for each of the hole sprites we're going to write sprite dot draw batch, and this is how we draw the hole. Okay, every hole. So here I'm writing the for loop for the mouse, and we're basically doing the same. So for each mo of mouse we're going to update it, and then we're going to render the batch. That's it. We're closing this for loop, and there are just few lines left now. So the final method, obviously, that we cannot avoid is the dispose method. So everything that we created, we also need to create a way to dispose, right? So let's write now background texture dot dispose. So here's how we dispose the background texture. Then we will need to dispose the whole texture. So whole texture dot dispose. Here we go. Then we will basically, okay, actually I'll write here a message so you know in the future that we will need to dispose all the mode textures that we use to avoid the memory leaks. Okay, it's important to do this, especially in the LibGDX libraries. Let's write next mode texture dot dispose, and basically I think this is everything. I think these are all the textures that we created, so we need to dispose. Okay, that's it. Let's see if we're error free actually, and this class looks pretty fine. By the way, it's quite a big class, 122 lines of code, so if you bear with me until the end, good job. And of course we're also going to update this class in the future, but this was the main body of the class, so really good job. This was our game manager. And let's go back here, because here there is a slight difference from the classes. So here I removed this mo. Okay, so I want you to have com.martiny.managers game manager. Okay, in the Racamo class. I just noticed this error here. So I will save it and let's see if it's gonna be error free. Okay, it is. This is very good. So let's run the game as we have no more errors and we created the main things we need. So we cannot yet accept input, we cannot yet accept text, but we can display quite a good amount of pictures. So let's go to the mo-desktop and let's run this desktop launcher class. So single click on the right button and then run as Java application. So let's run it and see what happens. And this is actually a way that you see how you did with the code until now. So if you've done well, and I hope you did, you see the background, you see the host as well positioned on the right locations. If you don't see this picture until this state, please write me down in the questions in the Q&A section, and I will try to answer you in my earlier convenience. But basically this is it. I will show you once again actually all the classes that we created. So we created the Racamo class in Java. Here it is. We created the desktop launcher, which is in the desktop folder, and here it is. Then we created the Mo class, which is this one. Okay, and finally I showed you the game manager class. So until that point you should have all these lines of code and hopefully your program is running correctly. If not, I just showed you all the code, so try to find your mistakes. Okay, pause the video and try to find them. So thank you very much guys for watching. Now we have the foundation, and in the next videos we're actually going to start adding some functionality to our game. Thanks for watching. Class update. Okay, we've seen that we already managed to display the host. You saw it in your screens, but now there is time for more important job. And this time we're going to look specific at the moles and basically the way how they appear. So in this lecture and in the next one, we're basically going to try to display them how they appear and create an input in order to control whether we hit them or not. So let's first create the code for appearance for the mouse, and maybe I will start in this video, and if we don't have enough time I will finish it in the next one. Let's see. So let's first go to the Mo class, and I will actually launch it now because I don't think we have it. So here I'm in the Mo class, and the first thing I will do is to go just under this speed 2f, okay, just below this variable, and then I will write public float time underground, and this will be equal to 0.0f, and then public float max time underground equals to 0.8f. That's it. And these two variables are actually quite important, and the first one is the time that the mo is underground. So as you can see, it's at 0 seconds, so it immediately goes up. And then the other time, we're going to set the max time to be the maximum time that the mo can be underground. Okay, so we're going to create certain function that will control any time from 0 to 0.8 f, and at this time the mo will be underground. We don't know which one the system is going to choose because we are going to make it in completely random way. So inside our update function I will actually create the switch statement. So let's write switch state, then let's create the first case. So this will be case underground, and here I will create an if loop. So if the time underground is higher or equal to the maximum time underground. So this is basically what will happen if we have overflow. Then state equals state dot going up. So if we are on maximum time, then we're going up, and then time underground will be equal to 0, so we'll restart the time. And then I'll create an else statement here, and then here I'll write time underground plus equals gdx.graphics.get delta time, okay, and that's it. And then we write break, so we're out of this statement. And I will write a simple note for you so you're aware what this actually means. So let's write. So this means that here we're going to increase the height of the mole until it reaches the maximum, and once it reaches maximum, then we're going to place it at 0 position, so it will go in the hole. Then let's create another case going up. So if the current height, so here we make current height plus equals speed, okay, and if the current height is higher than the height, then current height will be equal to height, okay, so it cannot get higher than certain level. Then state equals state dot going down, and we'll start going down once we call this going down function, okay. And I will actually as well write a comment here. So I'll write here decrease the height till it reaches the minimum value. Once it reaches the minimum value, then we'll change it to the start state. So we're changing it once it reaches the value. And after that, I'll write case going down. So here we'll write current height minus equals speed. Okay, so here we decrease the speed, and if current height is smaller than or equal to 0, then current height will be equal to 00f, and then the state will be equal to state underground. So we will reach here the state underground, and here I will break this statement. Okay, and I will actually write one more state here, so this is going to be the case underground. Okay, and let's see how we're with the curly brackets. So this one is closing the switch, so I'll remove the other, and here it should be fine now. Yeah, okay. So let's sum up what this case statements means. So the first one is the case underground. So we call the underground variable. So when we use the variable underground, then we start basically increasing the height. And once the height reaches the maximum height that is set, then we change the state to going up. Okay, so now we move to going up. Okay, so we were underground, now we go up, and when we're up, we're going to decrease the height because we want to go down. So we're going to decrease the height until it reaches the minimum height, and then we're going to change the state, and then we're going to go down state, and here we're going to go down until we reach the state underground. Once we reach the state underground, then we're changing again the state to I guess underground or going up. So once going down reach the minimum value, then we go to the state underground. Okay, and this is repeating over and over again. I just noticed some error here, and let's say I think this is a spelling mistake. So here it's I wrote I with capital letter. Let's see if now it's fixed. Yes, now it's fixed. So this is fine, and we're ready with this big statement. So let's go now here under the mole sprite dot draw batch in the render method. So here I write public void randomizer or randomize, wait, time, and then here I write max time under ground equals float mat dot random multiplied by 2f. Okay, and basically this is the way that we are setting our mole to go up and down by random value. Okay, and here I think we have an extra curly bracket, so I'll remove it. Yes, so I remove this curly bracket here and I will place it here because I want the randomize method to be outside of the render method. Okay, so here I will put a curly bracket and now we are error free. We're ready with this. And that's it, we're ready with the mole class, but now we will need to move to another class to do some modifications there as well. Then let's go to the game manager class because we will need to do some modifications there as well. And here I will go just under the Y. 1 second, let me find it. Here. So under this statement here, okay, you can see it. Inside this for loop, you need to add mole dot randomize wait time. That's it. And this is basically the way that we add this randomization functionality into the game manager class. So let's save it with Ctrl S, and we're ready here. So let's launch the game now and see what we have achieved. So what you can see now is all the moles are appearing, and you can see that they appear in completely random times. Okay, so the computer is choosing by itself, so we have a random number as variable on whether we are going to set one or another time for appearance, and you can see how they appear in a random way, and basically this is the way they are going to do it. So in the next section I will show you how basically you can take inputs from the mouse or from your fingers in order to press to that game. Okay, so bear with me guys to the next one and I will show you some really awesome things. I promise we will not type millions lines of code, but it will be a lot of fun and you will learn something new. So thank you very much for watching and I will see you in the next video. Animating the mouse. Hi everyone, as I promised you in the last video, today we are going to animate the mouse and I will show you how to take the user input in order to do some action to the mouse. Okay, we are not going to do nothing fancy this time. We are just going to make sure that when the user click on the mouse, this section gets received. So this means today we're going to create the input manager class, and I will go now to the IDE, and here we are. So here I will create the input manager class. Okay, let's open it, and here we can see we have nothing added, so let's start updating it. We'll start by importing some of the most important classes like we do always. So first I will import com.bedlogic.gdx.gdx. Then I will import com.bedlogic.graphics.orthographic camera. Okay, so we have the orthographic camera here, we will need it actually. Then I will import the com.bedlogic.gdx.mat.vector3, so the 3D vector. Then import martiny.managers, and here I will import the game manager. So this class, the input manager class, will be pretty much connected to the game manager class. Then I will also import martiny. game objects.mole. So I import the mole class as well. And let's actually create the body of the class. So let's write public class input manager, and inside let's write static vector3 temp new vector3. Okay, so we're creating the temporary vector object, and then public static void, and here we'll write the function handle input. Okay, handle input, and as a passing object here we're going to create orthographic camera and camera. That's it. And here is how we're going to handle the input. So let's write here. Okay, so the first thing we will do, we will check if the screen has been touched. Okay, so I'll write this as a comment here, and then I will write an if statement. So if gdx.input.just touched hurt, okay, in that case, if it's just touched, we would like to take the input coordinates. Okay, so we would like to take the coordinates of the place that the screen was touched, right? So this is what I will write here as a comment, and under it we're actually going to do the actual code. So temp.set bracket gdx.input.getX brackets gdx.input.getY comma 0. Okay, so we're getting the X and the Y location, and after that we would like to take the coordinates, but with respect to the camera viewpoint. See, the view of the camera is not always exactly the same as the coordinates of the game. So this is what we're going to do. Let's write camera dot unproject temp. Okay, and then we'll create variables. Float touch x will be equal to temp.x, which is the x location on the camera, and then float touch y, which is actually the y location of the camera. And then just to check that everything works, so when we press the screen everything works, I write system.out println stun. That's it. And then we're going to do some for loop in order to make an iteration and to check if the screen was tapped, touched, or clicked. Okay, so let's create, I will actually write a comment first, and here I will create a for loop as I said. Int I equals 0, and we're gonna loop until the game manager mole size, and then I++, so we're going to increment this size by 1 from 0 until the mole size. Then let's write mole and object mole here equals game manager.mole get I, and that's it. We're ready with that. We're getting an error here, but don't worry about it for now. It will be automatically fixed once we start completing the other classes. And let's go now to the RackMule class. So here we will need to add some other things in order to connect this class. Obviously in the other one we also added the orthographic camera, so it's obvious that these classes are kind of related. So let's here import com.martinY.managers.input.manager. That's it. We imported the input manager, and after that let's go in the render method, and just under the GAO cover buffer bit, let's write input manager dot handle input, and in the brackets let's write camera. Okay, And here is how we're going to code this class from here. Let's save it. Okay, so we're done with the Rakamole, and here I can still see we have an error. So let's actually remove this because apparently this method is not supported for now. So I'm not sure if this is going to be the same once we go along with the code, but for now we're gonna change this method to just touched. Okay, in order to not get these errors. So let's launch the code now and let's see what is going to happen. Press OK here. And there we go. So you have your game, nothing is different, but see this system.out.print ln statement and then stun. So what I wanted to do here is just test this method. So once we click on the screen, we should get the word stun printed in our system here down below. Okay, so let's press on the monitor and you can see that the word stun is written. So this means we can click on the screen. Now I'm clicking with the mouse. That we can click on the screen and it's working and it's working perfectly fine. So if you get the same results, then very good. You're able to go to the next lecture and I will see you there. Animating player actions. Hi everyone, today we're going to do some actually quite fun exercise and we're going to animate what the player is doing on the screen. So once the player hit the mole with the mouse, then we would like some effect to happen. So we'll create some cool effect, and also not in this one, but in the next video we're going to add sound to that effect. So let's first create the effect and I will show you how it's done. It's actually quite simple. You've already done most of the game. So here please open the mole class. There we go, we have it here now. And the first thing you need to add is just below this 0.8, the max time underground. We're going to add some parameters in order to control the stun time, or the time that we display the action when we hit one of the moles. So let's write public float stun time equals to 0.1 f. Okay, and then public float stun counter equals 0.0 f. That's it. So first we needed to define the variables, and after that actually let's create also the stun sprite. So let's write public sprite stun sprite. That's it, and we're ready with that. So this is basically going to be the sprite that is going to display the stun image. Okay, and then here in the switch state statement we will need to add one more case. Okay, so case stunned. Okay, if you remember, we have this variable now, so let's write here if stun counter is higher than or equal to stun time, then we would like to send the mole underground. So let's write state dot underground. That's it. Sorry, here is equal sign. So state equals state underground. Okay, so this means that once we have it stunned, okay, this means that we clicked on it, so we would like the mole to be sent underground. Okay, then let's write stun counter equals 0.0 f, and then current height equals 0.1 0.0f as well. And here we'll add the random time, so randomize wait time. Here we go. And that's it. We're ready here with the statement. So here is actually some add, because I saw that here I wrote a short version. Okay, so I will just do SNED, and then here let's write else stun counter. Okay, I'll write it here for simplicity. So stun counter plus equals GDX dot graphics dot get delta time. Okay, so basically we're going to do this in the same way as the underground. Okay, and then here I write another bracket, and here write break. I'll actually remove this one, and here there is a semicolon. There we go. So we're basically done with this statement. So I hope you understood what we did here. We just added this bit that is what happens when the stun variable is touched, and if this happens, okay, if this variable is activated, then we call the randomize time, and if it's not activated, then the stun counter is incremented with the delta time. Pretty much this is what we're doing here. Now go here in the render method under the mole sprite and write if state equals state dot stunt, then let's write stun sprite dot draw batch, and that's it. Sorry, here's again SNED. Okay, that's it. This you need to add here, and after that let's go to the, I promise this is the last one for this class. So let's go here in this if statement and let's add stun sprite dot set position, and here position dot x plus width plus, sorry, here's minus bracket stun sprite dot get width, okay, divided by 2. That's it here. And then position dot y plus current height minus bracket stun sprite dot get height divided by 2 again. Okay, let's see what's there here. Okay, so S with, not with capital letter, and that's it. This looks fine. And after we complete this long statement, let's add another one which is not that long under it. So let's write state equals state dot SESNED. Let's see if it's gonna recognize it. SNED. There we go. Okay. And semicolon. That's it here. So as I promised you, we're ready with the mole class. And the next thing I want you to do is to go to the game manager class. So I'll actually open it. So game manager here. I'll open it and we will need to add some basic stuff. So go here under the whole size factor and write static texture. So we're creating new texture variable, and then stun texture. That's it. And basically this is a texture of the stun image, okay? And after that you need to go to this for loop. So in the initialize method here, okay? So in the initialize, go to the first for statement here, right? So go there, and actually just under its bracket here, we will need to add the stun texture. So stun texture equals new texture, and then GDX dot files dot internal, and here I will write the location data dash stun dot png, and this is basically the picture of the stun, okay? I will show you where it is in a second. So it is usually in the desktop, okay? In the desktop assets that we added it. So here you can see the stun picture, right? And this is what we import right here. It is that simple. Okay, we're ready with that. Let's see if there's anything else that we need to add. So I want you to go now in the other for loop that is here, okay? And just under this mole.moleSprite statement, write mole.stun sprite, okay? And this will be equal to new sprite stun texture. So we're basically creating a new sprite, a new object sprite, from the stun texture that we just added in the beginning, okay? And actually you can see the same we did when we were creating the mole here in this method. So I want you to go under this position Y here, so in the same for loop but just in the end, okay? I want you to write here mole.stun sprite dot set size, and then inside write mole dot width divided by 2f, comma mole dot height divided by 2f, okay? So here's how we set the size of the stun. I know that we added many related things in quite different classes and functions, but we cannot avoid this because if you want the stun to be there, we really need to add it in the various places. So this is something that you cannot avoid. But believe me, if you're creating the code by yourself, I imagine that you create first the game manager class and you create everything there, and then move on to the other ones. Why I'm doing it now in this way is because I want to constantly show you the game so you can see the state until you reached, and you can basically see if you've done some mistake and you can fix it earlier. That's why we're adding these things now. Otherwise I will create them class by class, if it makes sense. The last thing I will do here in the game manager class is, as we created the stun sprite, we would like to also disable it or dispose it, sorry. So let's go to the dispose class here, and let's write stun texture dot dispose, and that's it. We're simply disposing the stun texture. And the last thing I will do is I will go to the input manager class, because obviously when we perform certain input, then this is the way that you expect to see the stun. Okay, so we need to add one function here, but it's going to be quite simple. So it's basically an if statement. So let's go inside this for loop here, and we want when this happens. So for I smaller than game manager.mole.size, okay, we first want to generate an object mole from the class mole. That's right. And another thing we would like to create is to generate stun. Okay. And also here I want something about the score. You'll see how it's done. So let's write if mole.state is not equal to mole.state.sned, okay, and mole.handleTouch, which was a method there, and inside let's write touch X and touch Y. So this basically means that if the mole state is not stun and we touched it and we touch the screen with our finger or we pressed with the mouse, then we would like to have the game manager dot score. So here we're going to increment the score. Okay, so here we're incrementing the score by 1. Okay, incrementing. Okay, and this is a function that I wanted to add just in the future when we start creating our score, to be sure that it's updated, but about this later. So let's save this and let's run our game and see what is actually going to happen now. So I will go to the desktop folder here and I will run as Java application. So let's have a look. Okay, so you can see the game here, and if I press, you can see that near the head of the mode that I pressed, you can see the stun symbol. Okay, you can see it now. So this was the idea. When you hit it, you to get some verification that you actually hit the mole, because if I hit anything else I don't get stun, but since I hit the mole I get verification that I hit it. So that was it for today, guys. Bear with me to the next lecture where I will create a sound that will support the stun, so you get some better feeling about the game. Thank you very much for watching, and I will see you in the next video. Sound management. Hi everyone, today I'm going to show you how you can actually add sound inside your game. I promised you last time, so I'm gonna stand behind my promise. And today we're actually going to do it. And as you can see, we're going to learn how to import sound in our game and how to perform this sound once we've done certain action. So let's not lose any more time, head on to the IDE and let's start. Okay, so there is not much code actually to write here, but we have to write code in many different classes, okay, in order to import that sound. First go to your mole class, okay, and after that please go here under the state stun, okay, here in the last function, and just add game manager dot hit sound dot play, and that's it. Okay, now you're getting error because this method is not yet added in the game manager, right? You even get the option to create it there, okay? But we are going to create it actually manually. And see that this is when you code the function handle touch, okay? So once you touch the screen, then you should play the sound. But let's go to the game manager and add the more code there. So I will go in the game manager, and here under the score, let's find where the score is here. I will add public static sound hit sound. Here we go. So okay, and I also need to import the sound. As you can see here, I get the import option because we didn't import it in the beginning. So let's import it now. And you can see we've got the sound here. So once we've done this, let's go just above the render game method here, okay? And here I want some stuff. So what I want to do is, let's first check where the curly brackets finish. So I want outside this for loop because we don't want the sound to be inside. So outside this for loop, but still inside the initialize method. Okay, so see where we are. We're outside the for loop, but inside the initialize method. So go here and write hit sound equals GDX dot audio dot new sound. That's it. And here let's write GDX dot files dot internal, and here we're basically going to call the file that is already in our folders. Okay, so let's write here sound hit dot wav, which is the name of the file, and then simply semicolon here. Okay, you see we're error free. So the last thing we need to do in the game manager class is simply to dispose the sound texture. So let's write here sound texture dot dispose. So we're getting error here. I think it's because I didn't add the sound texture in the beginning of the code. So it's not in the beginning. Okay, so this was because the name was hit sound. Okay, so I'll change this with hit sound, and then I have spelling mistake here. Oh my god, so many mistakes. Dispose. Okay, now we're error free, which is quite good. And this was the last thing you need to do in the game manager class. So let's try out and see if the code is going to work and you're going to see sound. Okay, we're getting some error, so let's see what we missed. So what I can see here is that the file is not found, hit.wav. Let's go to the file here, and probably I did some mistake when I was calling it, right? So let's see. Okay, so the folder was called sounds, not sound, right? So that's why we're getting the exception, and this is the reason why I've got this error. So let's try the code again. So always when your code is not running, please read the errors here. So see, here I've got file is not found, sound hit WAV, and now I know where to check my code. Always, if you have problems with this is the first thing that you need to check. So let's go to the desktop launcher and let's run our application. Let's see if now it's gonna work. Okay, so by the way, I can hear it now. I don't know if you can, because I disable my computer sound, but I think my microphone should be quite useful. Let me increase the sound. Okay, so listen now. Okay, it's like you're really shooting them. Okay, So now I didn't got it, and it's starting to be fun, right? So now you can hit them, and once you hit them, you hear this amazing sound, and also you're seeing the stun icon, which is quite fun. Actually, the most fun effects are always the ones that you spent a very short code for. But the really hard job, it's usually the one that you're writing in the beginning just to initialize the game. Well, this is how it is. But anyways, guys, thank you very much for watching. I'm really happy that you managed to do the sound effects, and I will see you in the next lecture where we're going to do our final class, which is the text class. So we're going to display the score on our screen. Thanks for watching. Management. Hi everyone, welcome to the final lecture. I'm really proud of you that you achieved so much and you were able to actually create this very difficult game. The last thing we will do is actually something that is quite simple, but I want you to practice over and over again because it's also quite important. And this is how to display the game scores and basically displaying text on your gameplay. So let's get on to the IDE, where first we're going to add some calling functions in the game manager class, and we're also going to create the text manager class. Here I am in the game manager class now, and the first thing I will do is just to add some simple lines so we're sure that we can call the text manager from the game manager class. So the first thing I will do is I will simply import com.martiny dot managers dot text manager. So first I will import the text manager here, even though we don't have added anything inside this class. But the next thing I will do is I will go just above the render game function here, and here under the, or actually above the sound effect, it doesn't matter too much. So here I will add text manager dot initialize, that's it, width and height. Sorry, here is height. Okay, obviously we're getting error here because we don't have the initialize function yet in our text manager class, but this doesn't matter because we are going to create it in a second. The last thing I want you to do is to add in the render game. Okay, in the render game I would like you to add the text manager as well. So text manager dot display message, and here batch. Okay, also here we're still not going to see this as a non-error line because we didn't have the display message method yet in our text manager. Okay, so let's now create the text manager class. Let's go to the text manager, and I will delete these lines here. So the first thing, of course, is that we're going to import some classes, and the first actually packages, and the first package I will import is the graphics.color. Okay, because we're gonna use it here. Then we will import com.bedlogic.graphics.bitmap font. There we go. And then import com.bedlogic.graphics.g2d, and here we will import the SpriteBatch, and then I will also import com dot Martin Y dot managers dot game management. That's it. And then let's write public class text manager, and here we'll start to write the body of our text manager. So let's write static bitmap font. Okay, and we're doing always the bitmap font because this is the way that we can write our variable. So I will write this here as a comment. Okay, using this variable. That's it. And after that, we're going to start writing the viewpoints of the width and height. So let's write here static float width and then height. That's it. We're ready with that. And then let's write public static void initialize and then float width comma float height. That's it. And then inside I will write font equals new bitmap font, and then so we created the bitmap font. Then text manager dot width equals width, and then text manager dot height equals height. So this is how we call the width and the height. We just defined in the text manager into this initialize method. Then set the font size according the screen width. Okay, this is what we're going to do. So I'll write font get data set color, and here I will set red, and actually here we'll do the font size. So I want first to define the color, but then I will define the font size. So okay, on the screen, that's it. And here let's write font dot get data set scale, and here I will define the scale as width divided by 970. That's it. And then let's write public static void display message. Okay, SpriteBatch, there we go. And after that, so here inside we're gonna write float font width will be equal to 10. So this is the width of the text. Okay, that's it. And I'll write a small comment here. And after that, let's write. So here I'll write the score. So here is going to be basically displayed the score and is going to be drawn there. Okay, so let's write font dot draw batch comma score dots plus game manager dot score. So here we're gonna write score 2 points and then the actual score that we recorded, and the width minus the font width minus the width divided by 15f comma height multiplied by 95f. And here I will delete actually these 2 points. I don't know why they stuck there. And here I also have a semicolon, so I will delete it as well. So as I explained, here we define the color. You can choose whatever color. You can even type green. It's also going to get recognized, but I will keep it red for now. And basically what we're doing in the final statement is we're drawing the font here. Okay, so we're writing here the badge that is inside our display message, and then we write specifically the string score. Then we take the score variable from the game manager class, which is going to be incremented, in every loop. Then we're setting simply the display features of the font, and that's it. We're ready here. So let's run our project and see if we're going to have the font displayed. Yeah, actually, let me go to the Mole desktop and Java application. Let's run it. Okay, so here in the corner you can see our score. Okay, so here's the score, and you see how it's updated when we increase the size of the screen. So if I hit it 2 times, then the score is getting 2. Okay. Okay, it's actually, the game is actually quite hard to do, and I got already the score 6. So I think that game is actually quite fun. I think the quality of the pictures and in general the way it looks, it is really nice. So I really hope that you enjoyed creating it, and now there is nothing left except playing the game. Thanks guys for watching, and actually bear with me to the conclusion section. Conclusion. Hello everyone, I'm very excited that you completed this game. It was quite a big challenge for you, but you succeeded. Actually, you learned a lot, really a lot, from this section and from the first 2 sections as well. But let's summarize what you learned here. So you learned how to create a game and basically how to add different colors to the game, especially with the text that you added in the end. You learned how to animate objects. You remember you created case statements with the different animation states of your game. So this was actually quite challenging, but you did it. Also, next, you learned, of course, how to display the text, and you learned more options about it. And also I wanted here as well to mention that you learned how to implement sound in your game. And if you ever thought that this is something very challenging, well, it is not. You saw we did it in just a few lines. So I'm really proud of you. I'm not going to extend this video too much because it's the conclusion. I just wanted to thank you for bearing with me and to listening for me for so many hours. I'm proud of you, and I will see you in the next section. Hi everyone, this is the game that we're going to create, and I'm actually going to play it for you. It's called Catch a Ball. So you have a basket and you have a ball. And the aim is to catch as many balls as you can and increase your score. But what is going to be different in this game comparing to the other games? Well, here we're going to create way more functionalities. So first we have this back button that we can go back to the start menu, and we're actually going to have 2 windows inside the game. So we're going to have this menu with start and exit button, and we're also going to have the gameplay field. Okay, so we're going to have 2 fields, and I will show you how this is actually done. And once you learn this, you'll be able to create game with 4, 5, 6, 7, 8 fields, whatever you want. So here I am in the IDE, and I will start by creating a LibGDX project. So today we're actually going to set all the necessary packages and classes and the whole project of this game. So in the future, in the next lectures, when we start writing the code, we are going to have already the whole project set up with the classes and the packages. So let's turn on the LibGDX setup project, and the name of this game is going to be called for underscore catch ball. Okay, and then here the package name will be as always Martin Y. Then the game class is going to be called catch ball. Then here in the destination, as always, we're going to go to our projects folder that you should have a personal folder for yourself. So mine is in this folder here, so I'm searching for projects, and here I'll actually create a new folder by slash and writing for underscore catch ball. That's it. Press open here, and now we have this folder. You should be already saving all of your projects in the Android SDK, so you should have this folder. And here I will leave only the desktop setup project. Okay, because we're going to create this game on our desktop. And now actually I will click this box 2D and then I will select generate. Okay, now the project is created, so let's import it actually in our IDE. So here I will select import, then existing Gradle project, press next here, and let's go to our projects folder, which is here, and select the catchball folder. That's it. Select this, then finish. So you can see now we have catchball, catchball core, and catchball desktop. Let's first check if our application is working. So go to desktop, Martin White desktop, desktop launcher, and then run as Java application. So now what you should be able to see is the logo of BetLogic. Okay, this means everything is working for you. And the things we are going to do here is to create all the packages and classes, just the files, and also import all the pictures. So the first thing we will do is just to add all the data needed that you should actually download from the source section in this section. So please go to the source code and check the pictures. So the picture should be in the folder data, and I will simply add this folder data to our desktop assets here. Okay, so I will add it here, press OK, and I will add the folder data inside the core folder SCR, sorry, in the core folder assets. So in the assets I will add the all the files, so the data files. That's it. Press OK here, and here we added the folder data. So once you have access to the pictures and the music that we are going to play the game, you can actually have it from the resource area in that section. So once you download the resource data, here you will find all the data, so all the pictures and the music that you need to use in the game. And what you need to do is simply go to the core folder, okay, and then add it in the asset section here. Okay, so this is how it's done. I will take the data and simply drag it to the assets in our core file. There we go. So we have now the data here with all the fonts, sounds, and pictures. And then you can see that in the desktop you also have it. Okay, I will just delete the BetLogic picture because we're not going to use it, so there is no point of being there, and we are ready. That's it. So the next thing I will do is to go to this core folder and then to src folder, and here I'm going to create three classes. The first class is going to be called catchball, so package, sorry, the first package is going to be called catchball. So here I will write com.martiny.catchball. That's it. Then I'll create one more package. It will be called managers. So let's write com.martiny.managers. That's it. Press finish here. Then we'll create another package, and it will be called objects. So new package, and here com.martiny.objects. That's it. Okay, we're ready here. So the first thing, I will delete this class that was predefined, com.martiny. So I will delete it. And let's start creating our classes inside our packages. So the first class I will create is the class catchball. So here class. So in the catchball package, I will create the catchball class. Then I will create a class inside the same package, which is called main game. Then in the same package, I will create a class called menu screen. Okay, so here write menu screen. That's it. Then I will create the objects inside our game. So go to the package objects, and first I will create the ball object. So write ball here. And then I will create the basket. So logically we have ball and basket here that interact with each other. So for that reason we're going to have classes for each of them. So we're able to create ball and we're able to create basket. And then simply I'm going to create all the managers, and here we'll have one additional manager because now we're more advanced. So the first one, it will be game manager. Okay, then we'll have the input manager. After that, let's create another class called text manager, and finally I'll create a class called spawn manager. So class, and this class actually is going to be responsible for how the ball is falling from the sky to the ground, okay, and how we control from which position the ball is going to come when it falls on the ground. It's actually going to be random. This is just a simple hint so you know. But let's validate this class, the spawn manager, and that's it. These are all the classes we're going to work on. It's an average project. It's not a big one, but it's not also a very small one. And then in the desktop class, let's go to the SRC and then to the desktop launcher and just see how it looks like. So for now, I'm not going to change this manager. The only thing actually what I will do for now is to change the imported class here. So here you can write Martin Y dot catch ball, and that's it. So we're adding here the catch ball class, and here the catch ball package, sorry, and here the class we're going to be using is the main game. Okay, so this is how we set up the things for now, but again I'm saying this is going to change in the desktop launcher, as is going to change for the rest of the classes here. But since you set up all the classes, you are good to go, and now we can start with implementing our code and actually our game. So for this I will see you in the next videos. Hi everyone, welcome in the IDE, and today we're going to develop and actually write some code in the game manager class. It's a good class to start with because actually this is one of the most important classes, and basically this class controls the game overall. So I will start by simply importing some packages. So let's write import com.badlogic.gdx. That's it. Then let's import com dot. Actually, I'm going to copy this because we're going to create quite a lot of packages today. So com.badlogic.gdx dot preferences, then import badlogic.gdx audio dot, sorry, with small letter, audio dot music. Then let's import again audio dot sound. Then let's import graphics. So we're going to import everything from the graphics class, okay? And after that, we're going to import utils dot array. Okay, that's it. Actually, these are all the classes we need for now. Later, I might import some more classes that we have already here. Okay, so that's it. Let's now start building our game manager actually. Okay, so I'll go to the next line and let's write static texture and then basket texture. And this is going to be the file responsible for the basket. Then let's write public static sprite, so we're creating a sprite here, background sprite, and this is basically going to control the background images. Then let's write public static texture background again texture. Okay, so obviously these files are for setting up the background, and these are variables of a type sprite and of a type texture. Then let's write static texture bow texture, that's it. Okay, and then public static final, and here float bow underscore release factor, and here again we're going to write some factors for sizing the objects on our screen. So let's write again private static final float and private static float, sorry, and this is going to be the basket underscore resize underscore factor, which is 3000f, and then let's write private static float and then back btn for button resize factor. Okay, and these are actually things we're going to use very late in our code, but I want you to have them set up. Then let's write public static void initialize. So now we will start creating our most important methods. So first we're going to update the initialize method, and we're going to set it with width and height. And let's write here background texture equals to new texture, and in the brackets here write gdx dot files dot internal, and here we're going to place the file for the background, so data slash background dot jpg, that's it. Then let's write background sprite equals new sprite, and in the brackets we're going to write the background texture, so we use a sprite to display that texture, right? It is that simple. And then let's write background sprite dot set size, and here is how we're going to set the size of our background, and the size will be the width and the height that we are passing to the initialize function. Then bow texture equals new texture, then gdx dot files dot internal, and here I will set the file for the bow, so data slash bow png, and I will later show you where these files are actually. You already placed them, they are in the data folder, so that's fine. Okay, let's close this bracket here, and let's write a new method public static void, and then I'm going to write the render game method, and here we're going to pass the sprite batch and then batch. Okay, so this is going to be the main sprite batch for our game. Then write background sprite dot draw in the brackets batch, that's it. Here I will close that method, and after that let's write public static void dispose, and this is going to be our dispose method. And here the first thing we will dispose today is the background texture dot dispose, that's it. So here is how we're disposing this method or this variable, and then basket texture we're also going to dispose, and then bow texture we're also going to dispose, that's it. I will actually place the bow texture on the next line so it's better. Okay, so here that curly bracket closes the dispose method, and the other one closes the whole game manager method. I will just do some modifications here, and note that I think here I added too many semicolons, and I think here as well, yes. So we're getting some errors here, and I think this is because we had to import the exact classes from this graphics method. So this is what I will do. So right here graphics dot texture, okay. Then let's write, I will again copy this here, actually into graphics, because we are going to add only graphics. So here dot g2d dot sprite, then here I write dot g2d dot, sorry, I put two dots, so g2d dot sprite batch, that's it, and we're done. So when you go down, as we imported the right directories, now we don't have these errors here, and we're ready with our game manager class. I just want you to press Ctrl S to save it, and we're ready. We imported everything we need for now, so we have already the background and we have the bow here implemented. So that's it guys, thanks for watching, and I will see you in the next video. Hi everyone, welcome to the IDE, and today we're actually going to enable the main class. So as you can see, we have all our classes here that we're using. Actually, I thought this might be way easier for you to have them all set up and just improve them time by time once we go along with the videos. So let's go to the main class here, and as you can see, it is inside the package catchball. So today we're actually going to improve this class a little bit. So I'm going to add everything needed for you to be able to start the game. So as you know, our desktop launcher here is going to run the main game class. So this is the class that makes a connection between the desktop and all other classes and packages inside our core folder. But there is one difference here. As you remember, usually the class that connects the desktop launcher and the game usually have the cameras and the viewpoints, right? But in that case it's a little bit different, and this is because we're going to have two screens. So we're going to have our menu screen and we're going to have our game screen. So basically inside the main class we're going to call one of these screens, and this is going to be the screen that we would like to display first once we launch the game, and you will see how this is done. So once we're in the main game class, let's go inside and write import com.padlogic dot gdx dot game, and that's it. And then let's import com dot martiny dot catchball. Okay, so these are the classes we need to import for now, and then let's go inside the body of the main game class, and here I overwrite. So right here overwrite, okay, and then below public void create, and here we'll override the create class. So now let's write set screen new catchball, sorry, catch d ball, and then this. Okay, we're ready with that, and here I'll just write extends game. So our main class will extend game, and now this create method is recognized. So here I'm writing set screen, and here I will set the catch ball. So this means the catch ball class, which will control the cameras on the gameplay. So this class here is going to actually be the first displayed for now, but later on I'm going to change this one to the menu screen. So the first we're going to display the menu, and once you press button from the menu, then you will be able to display the game screen, right? So that's it. I will save this class for now, and that's it guys for today. This was a short code typing, so I'm very happy you completed it, and in the next sections we're going to continue with our coding. Thanks for watching. Hi everyone, as we already created the main game class, now I want to set the cameras and the viewpoints in the Catch the Ball class. Okay, so inside here, the first thing I will do, I will actually delete this, and let's import some packages, and they are going to be related to the cameras, and then we'll add all the necessary methods in order to run our gameplay display. Okay, so let's import com.bedlogic.gdx.application adapter. That's it. After that, let's import com.bedlogic.gdx.gdx, and then let's import com.bedlogic.gdx.screen. So here we import the screen class from the GDX toolkit. Then com.bedlogic.graphics.gl20. So this is a type of graphics. Then com.bedlogic.gdx.graphics. And here we're going to import the orthographic camera. Then let's import com.bedlogic.g2d.SpriteBatch. Okay, and here a few more packages. So com.martinY.managers.game-manager. So you see here we also import the game manager, and that's it. Let's start writing the class. So public class, and then the name of the class will be Catch the Ball. And also I'm going to implement here the screen class, because this is going to be a screen, and usually when you have more than one screen, it's always good to implement this screen class. So first of all, I'm creating the sprite batch. Then I'll create an object that is orthographic camera object. So now we have our camera setup, and then let's write public catch the ball. So here I will create catch the ball class. So this will have the main game class implemented, and then game. So here we're going to add an object of a type main game, and then let's write float height equals gdx.graphics.getHeight, and then float width will be equal to gdx.graphics.getWidth. That's it. So here's how we make the dimension. We make the dimensions of our window actually dimensionless, because if we resize the window, they will get bigger and smaller. So now I'm writing our camera. So camera equals new orthographic camera width and height, and then camera dot set to ortho false, and then let's write batch equals new sprite batch. That's it. And then game manager dot initialize width and height. So we're initializing the game manager with its width and height, and we use here the initializing method. So here is how we call the initialize method when we use actually the game manager inside the catch the ball class. So obviously here I write the dispose method, because we want everything that was created to be disposed. So first I will dispose the batch, so batch.dispose, and then game manager dot dispose as well, and that's it. This was the dispose class, and After that, let's write, or let's actually overwrite the public void render. So I'm overriding here the render method, float delta gdx.gl clear cover, and here I'll write 1 1 and then 1, and then gdx.gl clear gl20 dot gl underscore cover buffer bit. That's it. And then let's write batch dot set project. So here we're going to set the projection matrix as we normally do, and this is the way we're going to draw on our screen. Okay, and after that let's write batch dot begin, and then game manager dot render game, and here in the brackets I write batch. So here is how we render the game using our game manager, then batch dot end, and we're done with this. Okay, so I get error here. Let's see. Yeah, I need to remove these two curly brackets. So this bracket close the render method, and this one is closing the screen. So one thing I want to mention here is that, for example, here we're overriding. So what we're overriding, this is the render method in the screen class. So screen is a predefined class, as you can see here, and we need to override its methods in order to implement it for our specific case. Also, you are getting an error here, and this is because we haven't implemented the catch the ball methods. So we need to implement this type of methods in order our project to align with the screen. So simply press here add unimplemented methods. You see we don't have this error anymore here, but if you go down, you see that now we implemented the show, resize, pause, resume, and hide. And if we would like in the future to either have our window resized or write some code for pausing the game, some logic, we can do it exactly here. And this is why our program wants our methods to be displayed here and overridden. So that was it for this class. And as you can see, so now when I save it, Control S, so once you save the catchball class, you can see here that the main game class don't have any more errors, because now we implemented properly the catchball class here, so that's fine now. And also, if you save this desktop launcher, you can see that now here you also don't have any errors. Okay, which is very nice. Now you don't have any errors in your code because you connected properly the main game class, the catchball class, you use properly the game manager as well, so you don't have errors here, and the desktop launcher. So we're good for now. So if you run our project now, you will be able to see the screen and the background implemented. So you will be able to see this. And I just run it from the desktop launcher, okay? So you saw how I launch it, and this is how you can set the background and the main classes that are called from the main game and then from the desktop launcher. So this was the lesson for today. I hope you managed it until that stage, and I will be happy to see you in the next video. Hi to all of you guys. Today we're going to start with the real deal and actually start creating elements inside our game. So the first element that I want to make is the basket, and you noticed probably that the basket is located, one second, let me open it. So the basket is located in this com.martinY objects. So what we want is usually all the objects to be placed in the same class. Okay, so this is what we were doing, and since we have the ball and the basket here, we're ready to start with the basket. So I'm gonna go to this basket class here, and I will start implementing the main variables for the basket. But obviously, first we're going to import some libraries as always. So let's first import the sprite which is the most important. So com.bedlogic.graphics.g2d.sprite. Then let's import com.bedlogic.graphics.g2d, and here I will import the sprite batch. Okay. Now, the next thing I will import is the rectangular, because our basket is actually going to be a rectangular. Okay, so math.rectangular, and that's it. Let's write now public class basket. Okay, and here first I will set the sprite variable, so public sprite, then basket sprite. That's it. And now let's write public void render, and in the brackets SpriteBatch, and then basket sprite dot draw batch. That's it. And here we implement our render method. So we added our basket in the render method, and then public void set position float x and float y. Okay, and here we're going to set the position of our basket. So basket sprite dot set position x and y. Okay, and we are done. So we are ready with that. So what we basically did here is that we created the sprite for the rectangular, which is the basket. Actually at first I gonna save it. That's it. And we basically draw the sprite, so we draw the basket, and then we set the position of the basket with this function. That's it. Now let's go to our game manager class, because we will need to call our basket class from there. So first of all, here I will import this class. So import com.martinY.objects dot bow dot basket. That's it. So you see it recognized it. And then since we imported the basket, now we can import its elements inside our game manager class. And the first thing I will do is actually I will create a new variable. So public static basket, and then basket. There we go. So this is our variable for the basket. This is so this object here, that is with small letter, not with capital, this is the object, this is the instance of the class basket. So this means that the basket object will have all the methods from the basket. So it will have the basket sprite, and it can use the render and the set position method. This is the important part here. That's it. Let's move down, because I will need to add some other things regarding the basket. And then since we have already the basket, we would like to display it, right? So what I will do here in the initialize function in the game manager class, we'll create a new basket object. So basket equals new basket. That's it. And then we are going to implement the image of the basket. So this will be done by basket texture equals new texture, and then in the brackets gdx dot files dot internal, and then in the brackets we write simply data dot basket, which refers to the picture of our basket. That's it. And then since we have our basket displayed, I write basket dot basket sprite equals new sprite, and here obviously I will add the basket texture in the basket sprite. Okay, so as the sprite is a function that displays everything on the screen, we would like to add the basket texture there. So then let's write basket dot basket texture dot set size, and here's how I'm going to set our size of the basket. So let's write here basket dot basket size dot get width star, and then width slash basket resize factor, and we're going to use the resize factor that we stated earlier. And then let's write basket sprite dot get height, and for the height we're here going to use the other technique for using the basket resize factor. Okay, so here is how we implement this. And after that, let's write basket dot set position, and I'm going to write here 0 0. So why I'm writing 0 0 is because I want our basket to be displayed in the bottom left corner, and I want our basket to be with the, so here why we have width. So the width doesn't have any value, and this is because the width is controlled from the screen. It's proportional to the screen that we display. So why we have factors and we don't have exact dimensions is because we would like, when we resize the screen, our objects also to be resizable. So that's why here we write the width, which is depending on the screen size, and then some factor with which our basket is going to be resized. So let's run our code now and see what is going to happen. Desktop launcher, run as Java application, press OK here, and we still don't have our basket. So I think this is because we only initialize it, but we also need to add it in the render method. So let's write here basket dot render batch. That's it. And after I did this, and let's run the code now and see if we are going to display our basket. We should, because we added it in the render method. So if I show you the screen now, here you can see the basket exactly displayed in the 0 0 location. And if I resize, the basket is also getting bigger. Okay, so from 0 0 we display the basket picture, and this is how we're creating the basket in our game. So that was everything for today, guys. Thank you for bearing with me for reaching until this stage of the game, and thank you very much for watching. Hi everyone, today we're going to do another pretty advanced job, and this is to create the input manager. So you know, the input manager usually handles the user inputs, so we need to start this class, and in the future we're going to update it as we add new functionality to our game. So let's head on now to the IDE, and here I'm in the IDE. So let's go now to the input manager class, which is this one. So let's delete this here, and the first thing I will do is simply to import some of the most important packages for this class. So let's write com.bedlogic.gdx.input.keys. Okay, then com.bedlogic.gdx.input.adapter. That's it. Then let's write import com.bedlogic.graphics.orthographic camera. So here we also need the orthographic camera. And then let's write import com.bedlogic.gdx.mat.vector3. That's it. And after that, let's write import com.martinY.catchball.catchball. That's it. And then let's write public class input manager, and here I would like this class to extend the input adapter. Okay, so our class is called input manager, but we would like to have the features of the predefined class input adapter. That's why we use this extends keyword. And now I will simply create an object of orthographic camera, and then let's create a vector, a 3D vector, equals new vector 3. That's it. And then let's write public input manager, and this is called a constructor. So every method that has the same name as our class is called constructor. So when this class is called, we would need to pass an orthographic camera object in order to create an input manager. Then let's write temp this dot camera, and that's it. We're sure that when we create this class we use the orthographic camera object. So now the next thing I will write is I will actually override the touch up method, okay, in case you want to use your game on touch screen. Then let's write int screen x, int screen y, and int pointer, then int button, okay, and these are predefined values in the touch up method which we're overwriting. So let's write now temp.set screen x and screen y and 0. That's it. Then camera dot unproject temp. So we use here the temp variable, and then I write float touch x equals temp.x and float touch y equals temp.y. Then we will call here actually the game manager class. So I write game manager dot basket dot handle touch x and touch y. That's it. And here we'll return false. So you're probably getting impression of what we're actually trying to do here. I'll remove these brackets. So what we're saying here, that once we're touching the basket or we touch some position on the screen, then the basket will move, and also we're going to be able to do that with the mouse. Why you get error here? So you get error here because you don't have yet the handle touch method inside our basket class, but in the next lectures we are going to implement it, so this error will be removed. I'm actually going to do it right now because we have still time today. So I'll write this handle touch method inside our basket class. So go inside your basket class and let's actually create that method. So under this set position method, let's write public void handle input, handle touch, and in the brackets let's write float x and float y. So we're passing the x and the y variables as we did in the previous function, and then let's write if x minus the basket sprite dot get width divided by 2 is higher than 0.0, or this means 0, then so this means that if x, okay, so if the x position of the basket minus the width of the basket divided by 2 is higher than 0, then we would like our basket to move to this position, okay? So if we touch the screen or we press it with the mouse, we would like our basket to move. So if we press at certain location on the screen, we would like our basket to move there. So let's do this. Let's write set position, and what we would like to do now is just to copy this here, because we would like our basket to move to the same position that we pressed. So here inside the brackets I will place the same thing. Here we go, comma 0, because we would like it to be displayed in the bottom. That's it. So this is what's happening when we perform certain touch or click with the mouse on the screen. We would like our basket simply to move there. And why we're setting exactly the get width variable here and the x variable here is because we would like, when we resize our game, everything to be dependent on the width and the height of our sprite. Let's save the input manager class. Okay, so everything looks fine. So let's go now to our catch the ball class, because we would also need to add there the input manager. So let's write here import com dot martin y dot managers dot input manager. That's it. So we added it here. And then in order to reapply our input to our games, we would like to add it in this class under the game manager dot initialize here. As you can see, you can add gdx dot input dot set input processor. Inside the brackets, let's write new input manager camera and then semicolon. That's it. So we added our input here in this create the ball class. Okay, sorry, catch the ball class. So we're ready. Let's run our desktop launcher and see if we're able to move the basket. So here's our basket, and if I press on another location of the screen, as you can see, the basket is going there. Okay, and it goes there exactly centered. That's why we divided its width by 2. Okay, so as you can see, it goes on the X location that I pressed minus its width divided by 2, and that's why it comes in the middle. Okay, and this is exactly what we wrote in our basket method in order to handle the position of the basket. So that's everything, guys. I hope you enjoyed that video. You see progress in the game, for which you should be quite happy. I am. Thank you very much for watching, and I will see you in the next video. Hi everyone, today we are going to create the bow with the bow class. So you remember last time we completed the basket, and today I'm going to create the bow as another object in our package of the objects. So let's head on to the IDE and I will show how this is done. So here, let's go to the bow class. That's it. And then you can see here we can start implementing our bow. So I'll remove this for now, and I will start by obviously importing our packages. So firstly, I will import the bedlogic gdx.gdx. Then we're obviously going to add our graphics. So com.bedlogic.gdx.g2d.sprite, and then let's import com.bedlogic.gdx.graphics.g2d.spritebatch. That's it. And then let's import com.bedlogic.gdx.mat, and here I want circle which will represent our bow. Then let's add com.bedlogic.gdx.mat.intersector, and we're going to use the intersector actually to create intersection between the bow and the basket. So here I'm adding another package which is going to be the vector2. Then let's import com.martiny.managers, and here I will also import the game manager. That's it. Next, let's write public class and then bow, bracket here. So here let's write public sprite, and here I write bow sprite, and then let's create a vector. So public vector2 position equals new vector2, and this vector will represent the position of the bow. And then let's create another vector2. It is going to be called velocity, and the reason for this is because this vector is going to handle the velocity of our bow, so the velocity will change. Then let's write public final vector2 gravity equals new vector 2 inside 0 and minus 0.4f, and this will represent the acceleration or the gravity of our bow. Then let's write public boolean is alive, so this will handle only values of true or false, and then I will create the update method here as well. So let's write velocity dot add gravity. Okay, so this is how we add the acceleration to the velocity, and then position dot add velocity. So you know the position, velocity, and the acceleration, they are of course dependent, and we need to add one to get the other. So let's write now bow sprite dot set position, position x, and position y, and here we're setting the position of the sprite. Okay, and then let's write public void render sprite batch, and this is going to be our render method. So here write batch as always, and then inside this method let's write bow sprite dot draw, and inside the brackets let's write batch. So we're drawing our batch for the bow, and that's it, guys. We're ready with that. So as you can see, what we actually created here is the bow. So we're setting a boolean of whether the bow is alive or not. We're setting the gravity or acceleration. So this is how the bow accelerates, how faster it falls. And as you can see here, we're first updating the velocity, okay, and we're adding gravity to our velocity, okay. So this means depending on the gravity, the velocity will get higher and higher as the bow goes down. And after that, we're changing the position of the bow with this velocity. So the position of the bow also increases, and for that reason, the bow is also going down. So once we're ready here, let's press Ctrl S to save this class, and let's go to the game manager where we also need to implement the bow. So let's here import com.martiny.objects.bow. Then let's go here under the background texture and let's create the bow variable here. So let's write bow and then bow. That's it. So we created the bow object here, and then let's create here one array. So I write public static array bow, array bow. That's it. And then bows. So this is the name of the array, and here I write new array bow. So this is basically going to be an array of bow objects, because obviously we're going to have more than one bow. We would like to have array with them. And then let's go down, and here in the render game we're going to create one loop actually. So let's write here spawn manager dot run bows, and here actually will not get recognized because okay, here is spawn, that's it. So the run method will not get recognized because we haven't yet added this method inside the spawn manager, but later on when we add it, this error here is going to be removed. So let's write here for bow, so we create object bow in bows, so in the vector bows. So for every object there, if the bow is alive, then we'll write bow dot update, okay, and bow dot render, and in the brackets batch. That's it. So for every bow we want to check if it's alive, and if it is alive we would like to update it and to render it, so this means to display it. And then let's write here in the end spawn manager dot cleanup and then bows. That's it. Okay, also this method is not getting recognized because we didn't add it yet in the spawn manager class, but this will change. And finally in the dispose class I will just add bows dot clear. So we clear, once we exit this class, we clear the array of bows. And that's it, guys. We are ready here. We are not able yet to run the program and see the bow, but once we implement the spawn manager, which will control how the bows are going to fall from the sky, then we are going to be able to do it. But I think it's enough for this video. Thank you very much for watching, and I will wait for you in the next. Hi everyone, today we're going to start implementing some logic that will basically control the creation and the deletion of the bows. Also in the next lectures I'm going to implement the random way with which the bows are created and they're falling from the sky inside our game. But let's start by developing the spawn manager. Here we are in the IDE and I'm selecting this spawn manager class here, which is from the managers package. So let's delete this, and the first thing I will do is start importing the most necessary packages for the spawn manager. So let's import java.util.random, and this we're going to use for the random objects, basically for the random bows that are going to be falling from the sky. Then I want libgdx.gdx. Then let's import com.bedlogic.gdx.graphics.texture. That's it. Then I will import com.bedlogic.gdx.graphics.g2d.sprite. Then let's import the next package, com.bedlogic.graphics.mat.circle, and then com.bedlogic.gdx.mat.vector2. There we go. And then let's import bedlogic. So com.bedlogic gdx.utils.array, and after that I will add, so I will import com.bedlogic.gdx.utils.intArray, so array of integers. Then let's import the bedlogic.gdx.utils.pool, and this is basically pool variables that we use also for the randomizing the bows. Then I will add com.martinY
dot objects, and obviously we will need to pass here the bow object. Okay, so let's start off writing our method. So public static spawn manager, then bracket here, and I want static float delay time, and this will be equal to 0.8f. So this will be the time between the failing of the two balls. After that, I want the delay counter will be equal to 0. So this counter will basically track the delay. After that, let's write static float width and height, and this will be used for the viewpoint width and height. And then let's write static texture bow texture, and this will be used in order to have a variable that refers to the image of the bow. And then let's write private static final float, and then bow resize factor equals to 500f, and as the name says, this is going to be the resize factor of the bow here. And then let's write static int array remove indices equals new int array, and this will hold all the indices of the bow to remove. Okay, so this will hold a number of the bow that we want to remove. And then let's write static random, and then I will create a random object from the random class equals new random, and that's it. So this will be the object of the random class. Then let's write public static void. So public static void, and here I will create the initialize method in the spawn manager. So initialize, and here inside I will pass the width, height variables. So to access this method we will need to select width, height, and texture, bow texture. Okay, and we also need to pass a bow texture here. Then let's write spawn manager dot width equals width, then spawn manager dot height will be equal to the height that was passed with the initialize method. Okay, these are pretty simple lines. Then let's write spawn manager dot bow texture, and this will be equal to the bow texture that is passed to the initialized method. Then delay counter will be equal to 0.0, and this is the restart of the delay counter. And then bow pool dot clear, so we clear the pool of the bow. And then I will create another method which is going to be called pool bow, and then pool bow equals new pool bow. Okay, so inside this method I'm going to override the new object method. So this method will be used when a new object of the bow is created and the pool needs to be empty. Okay, so that's why here I will create and override the new object method bow equals new bow, and then here we will do the instance of the basket sprite. So bow sprite equals new sprite bow texture, and here we will return bow. Okay, so here is how we do this. And after that, let's write public static bow, and this method will be called reset bow, and it will take a bow object in order to run. And how we are going to reset the bow? So first I write bow sprite dot set size. So here we will set the size of the bow. So bow sprite dot get texture dot get width multiplied by the width divided by the bow size factor, as we always do. So we're able to resize our window and the bow to resize accordingly.
then bow sprite dot get texture dot get height. So the same we're going to do for the height, multiplied by width divided by bow resize factor. And we're doing width here again because it actually doesn't matter, because the width and the height of the bow are basically the same. Then bow position dot set, and then the position is going to be random. So I write here random dot next int, and inside int width minus bow sprite dot get width, okay, and then height minus bow sprite get height. That's it. And here we're setting the position of the bow. Then bow dot velocity dot set 0 0, and finally bow dot is alive true. So once new bow is created, obviously it will be alive, and then return bow. So this method will return a new bow object, right? Then let's create public static void clean up. So here we're gonna clean up basically our window, and we're going to pass array of bows here, and then write remove indices dot clear. Then we're going to create a for loop here. So for integer I equals bow size minus 1, for every I higher or equal than 0, and I minus minus. So if the bow is not alive, then we would like to remove the index of that bow. So remove indices dot add I. That's it. We're ready with that method. With that statement. And then another for loop we're going to create. For I equals 0, I smaller than remove indices dot size I plus plus, and here we write bow, so bow object equals bows dot remove indices, and then I. Then let's write bow pool dot free, and inside let's write bow. So we free the bow pool. Okay, that's it. Let's close the method, and let's create another one. So this method will be called write public static void run array bow, and then bow. And this is going to be our run method that will actually run the bows. So let's create a new loop here. So if delay counter is higher or equal to delay time, then we create a bow object which will be equal to bow pool dot obtain, okay, and then reset bow, and inside bow let's write this, yes, and then bow dot add bow. Okay, so here we're going to call another bow if the delay counter is higher than delay time, and then we're going to set the delay counter back to 0, and if the delay counter is not higher or equal to delay time, then delay counter plus equals gdx.graphics dot get delta time. Okay, and that's it. We're ready with this. So I'm just gonna remove this curly bracket here, and so this bracket is closing the whole class as I see, and this one is closing the run method. So basically what we have here is that first we set up some variables. Okay, so we set up our random variable, the delay time, the delay counter, and then we called this initialize function with which we're going to basically initialize the width and the height of the bow inside this class, and also the bow texture, okay, because we would like to use them. So once we initialize them Then we're overwriting the new method object, the new object method in the bow class, and we're saying that here in the new method we're going to create a new bow, okay? And also the new bow is going to be displayed with the bow sprite, and the bow sprite will implement bow texture, which is actually the picture of the bow. After that, we're resetting the bow. So here we're adding the random method in order to reset the bow once it went out of scope. So that's why here we have bow alive true. So we're creating a bow here, or actually resetting it. And here we're basically setting the size of the bow, okay? So we're setting the width and the height. Then we also use our pool in order to store the bows, to choose bows from the pool. So here we're saying that while I is smaller than remove indices size, so I smaller than the size of the indices, then we would like to free the our pool, and here we're basically cleaning up the array of bows, okay? So we're saying that if we don't have a live bow, so if we have bow with value of alive equals to false, then we would like to remove that bow from the indices, okay, from the array. And finally, we're implementing this run function in order to know when we should run a bow or we should create it. So this usually happens if the delay counter is higher than the delay time. So this is happening at real time. Then we're creating a new bow object, and we're calling this reset bow function, as you can see. And we're calling the add function for the bow, so we're adding it in the array. And if this is not the case, then we would like to set the delay counter as a delta time, which is the current time in the system. So pretty much that's it for the Spawn Manager class. Let's save it. Then let's go to the Game Manager class here, and in the function initialize, we would need to call obviously the Spawn Manager. So just under the bow texture, let's write Spawn Manager dot initialize, and then width and then height. So we run the initialize function of the Spawn Manager inside here. Okay, let's see what there is here. So initialize, and let's go to the Spawn Manager. Okay, let me save this. Yeah, so we're getting error here because obviously we need also to add the bow texture. So we're passing the bow texture from this class as an input for this initialize function. So we pass the width, the height, and the bow texture. And that's why now we're not getting error, because these are all the inputs that the initialize function, the Spawn Manager, needs in order to run. Let's save this now. And now you can see that we no longer have any errors. So that was everything for today, guys. In the next lecture, I will show you how to randomize and display the bow, and we're actually going to run the program and see how the bow is falling from the sky. Okay, so thanks for bearing with me in this lecture, and I will see you in the next one. Hi everyone, today we're actually going to run our bow, and I will show you how to basically display it. So we're going to implement certain variables in the Spawn Manager class, and actually in many other classes, so bear with me, and I want your full concentration for this lecture, because we're going to update I think 4 or 5 classes here. So let's head on now to the IDE, and the first class that I will update will be the Game Manager class. So go to the Game Manager class, and let's first go in the initialize method here, okay, and just under the set position 0, 0, let's write basket dot basket rectangular dot set size, and here in the brackets write basket dot basket sprite dot get width in brackets, then comma, basket dot basket sprite dot get height, and that's it. And then let's go down here to the basket class, okay, and inside the basket class, so let me go there, inside the basket class, so I will save this, and you will see we've got error here because we don't have this type of method inside the basket class. So I will create it right now. Let's write it just under the basket sprite, public rectangular basket rectangular equals new rectangular, and that's it. We're ready here. Let's save this, and as you can see, the error here is removed. And before continuing with the code, I will just run the game because we don't have any errors. So I want to see how the balls are falling from the sky for now. Let's see. So as you can see here, the balls are now falling. Sorry. The balls are now falling and the basket is moving, and the basket can obviously go everywhere. However, you cannot see any interaction between the basket and the balls, okay? The ball look like it's going through the basket. And in the next lectures we are going to change that, okay? But let's first set all the rectangular and the bow variables, and after that in the next lecture I will show you how you make the bow and the rectangular to intersect. So let's go to the basket class, and here we need to add one more thing in the set position here. So we're gonna write basket rectangular dot set position x and y. That's it. And basically what we're saying here, we're creating an imaginary rectangular around our basket, okay, and later on we're going to use this imaginary rectangular in order to intersect with the bow circle. So let's go now to the bow class, and inside there we're going to do something similar to what we did in the basket class. So in the line under the gravity I will write public circle bow circle. That's it. And this is basically the imaginary circle that is around the bow, and this will be used for the collision later on. Then in the date method I'm obviously going to set the position and check for collision around the circle. So let's do it. Bow circle dot set position, and then here position dot x plus bracket bow sprite dot get width divided by 2, and then comma position dot y plus bow sprite dot get height divided by 2. Okay, so basically from the bow position x we add the change in the position, okay, in the width and in the height. And just under it I will write check collisions, and that's it. So here this is not yet recognized because we didn't create the method, but I will create it soon. So here under the render method let's write public boolean, and then check collisions with ground. And here this is the function. From the name you can say that here we're going to check if the bow has collided with the ground. So if the position y is smaller than 0, then is alive will be equal to false, so the bow will be dead. more or less, and then here we'll return true, and that's it. And if we're out of this if loop, we'll return false. Okay, so let's create another method, and it's also going to be boolean. And again, here actually we're going to check if the ball is collided with the basket. So simply write if intersection dot overlaps ball circle comma game manager dot basket rectangular. So if the circle of the ball intersects with the rectangular, then what we would like to do is to set the ball alive to false, so the ball will be removed, and then we will return true of this function. And if this is not the case, if they don't intersect, we return false of this function. Okay, so I will close the function here, and lastly I will write public void check collisions. Okay, so with this function we're going to call the previous two at the same time. So here I write check collision with ground, and then collisions with ground, and then I will just copy this check collisions with basket. That's it. Okay, and I will just close the function here. Okay, yes, so that's it. And here I will just add a semicolon, and here's how we create and check for the collisions inside our ball class. Then let's go to the spawn manager, and inside the reset ball, where it was, the reset ball here, we will need to add some more lines related to this. So here we will set the center of the ball sprite. So I will write vector2 center equals new vector2, and that's it. And then center.x equals ball.position.x plus ball sprite dot get width divided by 2, and then center dot y will be equal to ball dot position dot y plus ball sprite dot get height divided by 2. Okay, and finally let's write ball circle equals new circle, and then let's write here center, so this is the center of the circle, and then in the brackets ball sprite dot get height, and again divided by 2, and here is with I. Okay, so now we're error free here. So here what we're basically doing is we're centering the center of the ball in the center of the ball sprite. Okay, this is what you can see here. That's why we have the width and the height divided by 2 in order to get to that middle. Okay, the middle of the centered line, and this is how we then add it to the ball circle. Okay, and here is how you basically manage to create interaction between the ball and the basket. So you can see that here we have a small rectangular around our basket that we already created, and now we're displaying also the ball. So now they both interact, and if you actually see the game, you will get proof of that. But here it's important to know that you have an imaginary rectangular around the basket in an imaginary circle around the ball. So when they interact, the ball should disappear. So let's run our game now and see what happens. So let's run as Java application, and here you see that when the ball falls inside the basket, okay, let me have closer ball, it completely disappears, it doesn't go to the ground, okay, you see? So if you take a close look, when the ball goes to the basket, it basically disappears before reaching the ground. So it gives you the impression that we actually caught the ball with our basket, okay? And pretty much that's it, guys. This is how you display the ball and make the ball and the basket to interact. So thank you very much for watching this lecture. I will wait for you in the next one when we are going to start working on the text managers and basically how to save the highest score and the current one. Hi guys, as we added the main functionality of our game, we're pretty much done with the logic behind it. However, in order to make the game interesting for the user, we would also need to display the results and other variables on our screen, so the user actually have certain aim once he's playing the game. So in the next section, you will first create the text manager, then you will add things on the screen, and then I will show you how you can make the start screen, which is going to be another screen, and then we're going to learn how to play sounds. But let's start by creating the text manager. So here I am in the text manager class, and the first thing, obviously, I will import some packages. So import com.bedlogic.gdx.gdx. That's it. Sorry, here's gdx. That's it. Then import com.bedlogic.graphics.color. Then I will copy this line here until graphics, because we're going to add two more graphics, okay? So here I will import g2d.bitmap font and then g2d.spriteBatch. That's it. So these are all the imports that you need, and now I will start writing inside the game manager class. So the first thing I want is the font from type bitmap font. So static bitmap font and then font, and this is, with this variable we're basically going to draw text on our screen. Then let's write static float width and height. That's it. So this is the width and the height of the viewpoint, and then let's write public static void initialize. So here we start the initialize function, okay, and we'll pass to this function the width and the height. So float width and float height. That's it. And inside let's write font equals new bitmap font, sorry, m with lowercase m. That's it. And then in the brackets gdx dot files dot internal, and here write data slash fonts slash can.fnt. okay, and this is basically, if you check now in this folder, let me find it in assets data.fonts. Here you can find the font that I already provided to you, and it's inside this data folder. So what we're doing here is basically referring to it. And then let's write text manager dot height, sorry, dot width will be equal to width. And I can notice there is an error here. Let's see what it is. Yeah, here it's font not fint, obviously. And then here we initialize the width and now the height. That's it. So now we want to send the color of the font. So font dot set cover dot red. Okay, and then let's write text manager dot font dot get data dot set scale width 1400f divided by 1400f, and this is basically how we're going to scale the font depending on this scale factor. Okay, so it's resizable. And lastly, let's create another method, and it will be called display message. We created similar methods in our previous game, so you should understand that. So let's write public static void display message, and inside let's write sprite batch and then batch. That's it here. And inside this display message method, we're going to add float font width equals 50. That's it. And this is basically the width of the font that is going to be displayed on your screens. And here we're ending with the text manager. We're probably going to add more things here in order to display the high score and stuff like that. But now let's move to the other class, which is the game manager class. And here, just under the spawn manager, we would also want to add the text manager. So text manager dot initialize and then width and height. And here's how we're passing the width and the height that are created inside the game manager class. We're adding them as initialization variables to our text manager. So that's it for today, guys. We're not yet ready yet to display our scores, but in the next lecture I will show you how you can add your score and add the whole logic behind the score and display it on your screen. But that was the initial thing to start writing your text manager class, and I will see you in the next video. Hello everyone, I actually left the same slide from the last time because this is pretty much related to the previous video that we did where we created our text manager, but now we're going to add the whole logic and all the variables that you need in order to display your font with your text of score and the highest score. So the idea is that on one side of your screen you have your score, your current score, and on the other side of the screen you have the highest score achieved since the game was turned on. Okay, so this means if you made a score of 20 and then you play the next game, you see in the highest score field the score 20, so you try to beat that score, right? And this is basically the idea. But how we're going to implement it? Well, let's go to the IDE and I will show you how this is actually done. So here we'll need to update certain classes, and let's start by updating the text manager class. So the only thing you need to do here is to draw the fonts that you already set up. Okay, so I will draw here two font functions. So let's write font dot draw and then batch comma score double dot plus game manager dot score, and maybe we'll get error here because we didn't create this variable yet, and here width minus font width minus width divided by 15f, which is a scale factor, then height multiplied by 0.95f, which is also a scale factor for the height. Sorry, there is no bracket here, and I will also delete this one. Let me make space here. So plus game manager dot score comma width minus font width, and let's write the other function. So font dot draw batch comma high score, and then plus game manager dot high score comma width divided by 40f, comma, height multiplied by 0.95 f, which are the scale factors. And sorry, here is also multiplication sign in the previous method. Okay, even though we get errors, we're done here because we need now to create the high score variables and the score variables in the game manager class. So let's move there and start creating them. And now just under the array bow here, let's create the score variables. So let's write public static int score, then public static int high score, and then we'll create another variable for the preferences instances. So let's write static performance perfs, and that's it. Sorry, performances preference, sorry, as our class that we added here. Okay, preferences. Okay, so we need to create these three variables, and then let's go here under the spawn manager and between the text manager and the spawn manager, and let's write score equals 0. So this means our score will be initialized at 0, which is exactly what we want once we start the game. And below the text manager, let's write prefs equals gdx dot up dot get preferences, and then my preferences, that's it. And here I spelled wrongly the prefs, so it's like this prefs, and now we get the matching here. And after that we're going to get the current high score, so let's write high score equals prefs dot get integer, and here write high score. And this might be confusing how this is done, but this is actually something predefined. So we usually use this get preferences exactly for this reason, in order to get the previous result of the game. So I advise you just to remember this logic and start implementing it in your games. Then here below the spawn manager cleanup bows, okay, let's actually call the text manager display message function from the text message method. So text message dot display message, sorry, text manager is here, text manager dot display message, and in the brackets let's write batch, because this is what the method wants, and we're ready here. And after that, so actually once we go out of this loop and we go to the dispose, once we're here, so we're not yet in the dispose method, so once we're here, let's write prefs dot put integer, and then high score, comma, score integer, that's it. And then prefs dot flush, in order to flush our preferences. That's it. And finally, what's left is the bow class. So what we basically want is that once the bow is caught from the basket, that we increment the score, okay? And also to be able to receive the high score of all the games. So this is what we're going to do in the check collision with the basket function. So we have here check collision with the basket function, and it's logical that this method is here because once the bow collides with the basket, then we would like our score to improve. So let's write here game manager dot score plus plus, so increment the score +1 once we hit the basket. You can also increment it with 2 or 3 depending how you want to count your score, okay? And then let's write a new loop. So if game manager dot score is higher than the game manager dot high score, then we would like game manager dot high score to be equal to the game manager dot score. Okay, and this means that if for some reason our current score is higher than the high score value, we would like our current score to become the best score that was achieved in the game, right? So for that reason I'm adding these values here and the logic behind it. That's it. Let's save everything. Let's save also the text manager. And there is actually still some error with the font, so maybe I did a slight mistake here. Let's see what's wrong. So yes, as I can see, these two functions, I put them out of the display message, and they need to be inside the display message, obviously, in order to have the sprite batch. So I will just place them here, and as you can see, they get recognized, okay, because we're in our display message method, so we actually can use this batch variable here. Otherwise, if we're outside, we cannot do it. So if I save it and then I run the game, let's press run as Java application, and here you can see the maximum score that was achieved was 2, and now I will make score 3, and you can see that our high score and our current score are improving because we are currently having higher values than the maximum score that was achieved. Okay, the thing is that now I cannot stop the game in any way and restart it because I don't have yet the menu screen, but once I have it, then you will be able to restart the game and see if you improved your score and it's highest than the higher score ever recorded in the game. So that was everything for today, guys. I hope you are happy with what we have done, and I will see you in the next video. Hi everyone, since we created the main screen that we're actually playing the game there, now it's time to create the menu. And this is something that we haven't done before, but in this game I decided that I want to do it, so you know how you're able basically to display two screens on a single game. So let's start it. Here I am in the IDE, and let's go to this menu screen class. We actually haven't done anything inside this class yet, but now we're about to write plenty of code there in order to define the buttons and the screen. So I will delete this, and the first thing I will do is to import the main packages that we are going to basically use in that class. So the first I will start by adding the application, the LibGDX, and then I will add the screen. After that, let's write com.bedlogic.gdx.graphics.gl20. Then let's import the bedlogic.gdx.graphics.orthographic camera. So we import this here because we need viewpoints, as this class is also going to be a window and a screen, so that's why we need this. And then let's import com.bedlogic.gdx.graphics.texture. That's it. And then bedlogic.gdx.graphics.g2d.sprite, and then bedlogic.gdx.graphics.g2d.SpriteBatch. Okay, and finally let's import com.bedlogic.gdx.math.vector2 vector3 in this case, and then we can start actually writing our class. So here we can start the menu screen class, and this class is going to implement the screen class, and we're going to override some methods there. Okay, so let's write now SpriteBatch batch, and here is how we're creating the sprite batch for our game. Okay, and here I will write a comment that this is the sprite batch for drawing the screen. Then let's create the orthographic camera. That's it. Then we will need to set up some other variables, so let's write here texture, start button, texture, okay, and then texture, exit button, texture. So this is what I told you. We're going to have here the start button and the exit button. So we need to create their textures. Then texture, background texture. This is going to be for the background, which is actually a picture. And then let's write sprite, SpriteBatch, sprite button sprite, actually start button sprite. Then we will create the exit button sprite, which is going to be responsible for setting up and displaying the badge of the exit button. And then background sprite. This is done. And then let's write private static float, and here actually I'm going to state all the factors. So firstly I will create the button resize factor. So button resize factor equals to 800f. Actually you can play with these factors and see how your buttons and pictures are going to change. This is actually some very good practice. So let's add the next factor, and this is the start vert position factor, and this will be equal to 2.7 f. Then let's write private static float, and then exit vert position factor, okay, this is going to be 4.2 f. And now let's create an object game from the main game class, and also let's create a vector temp equals new vector 3, and this is a temporary vector that will capture the input coordinations, okay. Then let's create public menu screen, and here we will implement the main game, okay. So we need the game object from the main game class in order to start the main screen, the menu screen, if that makes sense. Then write this game equals game, and then float height equals GDX dot graphics dot get height, and then float width equals GDX dot graphics, and here will be the get width. So these are basically the dimensions of the viewpoints that are going to be implemented on the menu screen. Now let's create a camera viewpoint. So camera equals new orthographic camera, width and height, there we go. And then let's create another camera. So here is actually going to be the center of the camera, so we're going to center it in width and height divided by 2. That's why we do center ortho to false. And then let's write batch equals new SpriteBatch, and then let's write the initialization of the button textures. So here we're going to call the images. So let's write start button texture equals new texture GDX dot files dot internal, and we're going to check all the internal files. So the file we want is data slash start button dot png, which we already have in our file directory. Then let's write exit button texture equals new texture GDX dot files dot internal, and then data slash exit underscore button dot png. Here we go. And then we will need only to set the background texture. So background texture equals new texture GDX dot files dot internal, and here in the brackets write data slash exit menu background dot jpg, and this is going to be the background image of the menu screen. So let's write now start button sprite, and let's connect all the sprites to our images or to our textures. So sprite start button texture, there we go. And then exit button sprite will be equal to new sprite exit button texture, and finally background sprite equals new sprite, and then here write background texture. And after we're ready with the setup, okay, now we would like to size our objects and to position them. So let's start by sizing the start button. So start button sprite dot get size, and here start button sprite dot get width, and then brackets multiplied by the width divided by the button resize factor that we already created earlier on. Here we go, comma start button sprite dot get height, and again here we're going to multiply this by width divided by button resize factor. That's it. And then we're going to do a similar thing for the exit button sprite, basically the same thing. So here we write set size exit button sprite dot get width multiplied by width divided by button resize factor, okay, comma exit button sprite dot get height, then brackets multiplied by width divided by button resize factor, okay, then semicolon, and after that let's write background sprite dot set size, then comma, and here we're going to set the size of the background, width and height. That's it. This is the only thing we need for the background. And then let's set the position of the start button. So start button sprite dot set position, and we want to position them in the middle, and that's why I will write width divided by 2f minus set start button sprite dot get width divided by 2, okay, and width divided by start vert position factor, and this is the factor that we also predefined, and this is how we display the button in the middle, okay. And we also want the exit button to be displayed just under the start button. So let's write exit button sprite dot set position, and then let's write width divided by 2f minus exit button sprite dot get width divided by 2, comma width divided by exit vert position factor, which is different from the start position factor because we want the buttons to be in the middle but not in the same location, right? So then let's write background sprite dot set alpha, and this is because alpha is setting the transparency, so we would like 0.2 transparency on our background just to look more cool. So now we have to override certain methods. So first I will write public void show, and we're going to override this method. Actually, instead of doing this, there is actually easier way. So I will remove this curly bracket here, and I will go here to the menu screen, and I will press add unimplemented methods, okay. And this is because since we are implementing the screen class here, we need to also create implementations of the screen methods, okay, because screen is predefined class and menu screen is the class that we are now creating. So press add unimplemented methods, okay. Now you see this error disappears, and you can see that here we now have all the unimplemented methods. See how many they are. So first of all, in this float delta method, let's write gdx dot gl clear cover 1,1,1, and then gdx dot gl dot gl clear gl20, and then gl underscore cover buffer bit, okay, and then let's write batch dot set projection matrix, and this is normal to add this statement here as this is our other screen, so we would like to have the projection matrix here, and then let's write camera dot combined, that's it, and then let's write batch dot begin, so we begin our batch, then background sprite dot draw, so in our render method we're now drawing our background, then start button sprite dot draw, and here add batch, okay, and then exit button sprite dot draw as well, so we're adding the background, the start and the exit button, and finally batch dot end, okay. That's it with this method. As you can see, everything gets accepted here, and what we basically did is in the render method that we have, we override it and then simply add these functions which are common for every render method, okay, in main class, and then we simply begin the batch, we draw the background, we draw the start and the exit button. This is what we're doing here. And finally I will go to this dispose method here, and I will add start button texture dot dispose, okay, then exit button texture dot dispose, and finally batch dot dispose, and this is our container, okay. So here we dispose the objects basically, and we're done with the menu screen for now, okay. So once you are ready, if you try to run the game now, let's see what is going to happen. So obviously now when you run the game, you don't see the menu screen, okay, you immediately see the game screen, and this is not right. So this is because here in the main class we're calling the set screen function as catch the ball, okay, which is this class. So this means that we're going to start first this class, but what we actually want is to start the menu screen class, okay. So what I will do, I will write here menu screen, okay, and this also gets accepted. So now this main game class refers to the menu screen, and if you run the game again, see what is going to happen. So now you can see the start, the exit button, and also the background, which is slightly transparent, okay. You cannot select them yet because we didn't add this functionality in the input manager, but this is how you can display the screen, and in the next lecture I will show you how you enable these buttons in order when you press them to go to the gameplay class. So that was everything for today, guys. I hope you enjoyed it, and I will see you in the next video. Hi everyone, as I promised you in the last lecture, today we are going to make our menu screen functional. So all the buttons that are displayed there are going to have their functionality for entering or exiting the game. And here is how it's done. Here I am in the IDE, and as you can see, all the classes are displayed here. So firstly, I will go to the input manager class, and I will do just one thing here. I will import com dot martin y dot catch ball dot menu screen. However, I'm writing this here because we're going to use it when we're creating the back button, but we're not doing it today. I just want to add it here once we have it already created, but the most important thing we will do today is I will go here in the menu screen class, and here under the dispose method I will create a handle touch function. So let's write void handle touch, and it is void because we're not going to pass any parameters to this function, and let's write an if loop. So if GDX dot input dot just touched, okay, so if we touch the button, then temp dot set gdx dot input get x dot get y, comma 0, and here I will add one other line. This will be camera dot unproject temp, so the touch coordination is with respect to the camera. Okay, so if we touch, then we will say this input that is with respect to the camera. Then let's write float touch x equals temp dot x and touch y equals touch y dot temp dot y, and this is implemented actually for every game. This is not specific to our game. This could be implemented to absolutely every game, so please feel free to use it also for other games. We're just setting up the functionality of the selecting a button. But now what I'm doing here, so touch x, if it's higher or equal to start button sprite dot get x, and if the touch x is more or equal than sprite start button sprite dot get x plus start button sprite dot get width, and touch y higher or equal than start button sprite get y, and if the touch y is more or equal to start button sprite dot get y plus start button sprite dot get height. That's it. So basically in this statement we ensure that we selected the start button. This is why I add this location, and if this is true, game.setScreen new catch the ball. So here if we selected the start button, we're displaying the screen for catching the ball, okay, or our main game screen. And this is basically what we're doing in these lines. And now I'm going to set the button for the exit screen. So I will say else if, so if the touch x higher or equal to the exit button sprite dot get x, and here in this long code we are simply saying that if we selected this button, but we need to add it in this way so the system understands us. So and the touch x is more equal to the exit button sprite dot get x plus exit button sprite dot get width, and the touch y higher or equal to the exit button sprite. This is actually going to be the same as the first sentence dot get y, so you can actually copy it from the first sentence and simply select exit button sprite instead of start button sprite. So here is like dot get y plus exit button sprite dot get height, okay, and that's it. So if this happened, gdx dot up exit, and this is the way that we're exiting an application in libgdx. So what we're saying here is that we want to exit the app if this button was selected, okay. Let me remove the extra curlies here. Is that all? Okay, let's see. Yeah, so with this curly bracket we get out of the handle touch method, which is good. So that was it, and this is how we handle the touch of the buttons in the menu screen. But I want you to notice something very important here. So notice here that we're checking the touch x, so the x location of the touch of the mouse or of our finger is higher or equal to the SpriteBatch.x. So that means if the x location of the touch is at the start button get x, and if the y location is at start button get y, okay. And we're basically, if you see, we have here 4 statements, okay, 1, 2, 3, 4. So imagine in one of the statements we say, okay, I want the x coordinates of my touch to be higher or equal to the x position of the button, okay, higher or equal, which is in that direction. And then I also want the the touch location to be also smaller or equal to the start batch plus the button width, okay, which is in that direction, and we have only one position, okay, but that's why here we add the start button get width, which means that in any X location we press on the width of the button, we are going to activate it, and this is the same with the Y, okay, so think about up and down. So this means that there is certain location which is exactly the button location and the button width that when we press there, then the button will get activated. I hope you understand this explanation, but if you don't, everything is written here so you can follow it easily. And notice also here that if we select this button, of course, then we activate game.setScreen and we reset actually the screen to the start the ball screen, which is this one and is displaying the game. And if we select the exit button, obviously we're exiting the game with this line here. Then let's go up here, and after the batch end, let's write handle touch and the brackets, just to add this handle touch function here. So once we're ready, let's actually run our game and see if everything is going to work properly. Press OK here. And now let's select the start button and see what's gonna happen. Okay, so when we select the start button, the game is actually starting. Okay, as you can see. And since we don't have the back button yet, so I cannot go back, I will close the game and start it again. So let's run a Java application. And then I will select the exit button to see if I will exit the game. There we go. And when you select the exit button, you're actually exiting the game, which is normal. And this is exactly what we stated here. So that was everything for today, guys. I hope you enjoyed. Bear with me to the next lecture when we're going to build the back button. Okay, so thanks for watching. Hello everyone, we already created the menu screen, but there is one problem. We don't know how to go from the game screen back to the menu screen. So once we start our game, we cannot go back and restart again or exit the game in any way. So for that reason, we will need a back key displayed in our gameplay screen, okay? And this is what is going to be basically done in this class. So once we have the menu screen, we want to be able to start the game or to go to the game screen, and then we want some key, and this is the back button key which we will create today, to go back to the menu screen in order to have the option to start the game again or to quit the application. Okay, this is the idea. So let's go now to the IDE where I will show you how this is done. So first of all, I will go to the catch the ball class because we will need to add some variables there, and under the orthographic camera I will add a new variable called public static main game, and here game. Okay, and this is an instance of the main game class, which is this one, and we'll use this main game later. So in this catch the ball method I will actually use it. So let's write catch the ball dot game equals game. Okay, so we're creating an object here. I did a spelling mistake. Catch, that's it. And then down here in the hide method, just write dispose. Okay, and I think this is the final with this catch the ball class that we're going to do for today. So let's move on to the game manager class, where just under the background texture I will define two more variables: back button sprite and back button texture, obviously in order to have access to the picture of the back button and in order to display it with the sprite. So let's write public static sprite back button sprite, and then let's write public static texture back button texture. Okay, So that's gonna be it for the definition of these variables. And then go down here under the high score, the prefs, okay? And here I will define how we're going to add the picture and where we're basically going to add the picture of the back button, okay? So let's write back button texture will be equal to new texture gdx dot files dot internal and then data slash back button, and here's how we import the picture of the back button and connect it to our button texture, back button texture. And then let's write back button sprite equals new SpriteBatch, sprite, and inside back button texture. So we connect the sprite to the back button texture, and I will move this here actually, so they're on the same indentation level. And just under it, let's write back button sprite, and here I will set the size of that back button. So let's write set size, and inside back button sprite dot get width multiplied by width divided by back btn resize factor, comma back button sprite dot get height multiplied by width divided by the back button resize factor, and obviously here again we're going to use these factors that we created. And then let's write back button sprite dot set position. So after we set the size, we're going to set the position of the button, and this will be width divided by 2 minus back button sprite dot get width divided by 2, comma height multiplied by 0.935, and that's it. Then I will write gdx dot input dot set catch back key, and here write true. And this method might be marked as obsolete, but that's fine for now, and I can ensure that everything will work fine. Then let's go to the render game class, and just under the cleanup method, or actually let's place it under the text manager initialization here. So let's write back button sprite dot draw batch, and that's it with this one. And finally, in the dispose function here, just above the clear method, okay, I will add back button texture dot dispose, and that's it. Did I do a spelling mistake here? Back, yes, here is E, back button texture dot dispose. So we're disposing this button after we use it, okay? Okay, done here in the game manager class. I'm going to save it now. And then let's go to the input manager, and here I would like actually to create this button. So I would like to handle an input that will be applicable to this button, okay? So here under the function touch-up, we'll create two more functions. So let's first create the handle back button function. So I'll write public void handle back button, then float touch x, comma float touch y, and then inside this method we'll only need to write an if statement similar to the one we created before, and here we're going to try to set the location of that button. So touch x, if it's higher or equal to game manager dot back button sprite dot get x, and the touch x is smaller or equal to the game manager dot back button sprite dot get x plus game manager dot back button sprite dot get width, and then and the touch y. So now we're doing the ifs for the touch y. So touch y if is higher or equal to the game manager dot back button sprite dot get y, and the touch y is smaller or equal to the game manager dot back button sprite dot get y plus the game manager dot back button sprite dot get height. Okay, and this is it. We're ready with that. So now let's write catch the ball dot game dot set screen new menu screen. So this means if we select the button, we'll go back to the menu screen. It is that simple actually. Basically the reverse thing on what we previously have done. And I will actually write in the comment. So here I write bring the menu screen to front. Okay, we're ready with that. Then let's close this loop. And now I overwrite one method here. So this will be the key up method. And I write public boolean key up and then int key code. And here I write if the key code equals key dot back or the key code equals keys dot escape, then I would like to have catch ball dot game dot set screen. Okay, and here inside I write new menu screen. So I would basically write the same menu screen catch ball dot game. Okay, that's it. Let me actually drag this ones a little bit closer so it looks nicer. Okay, and after that I will simply close actually this method. Okay, so after this bracket is closed, I will return false. Okay, so we're not using this unless we're in this if statement here, and that's fine. Let me put semicolon here and check the brackets. Everything is fine. I'll remove these ones from here, and we're ready. So now we have the handle back button and the key up functions here. Okay, now I want here also the handle back button function. So handle back button touch X and touch Y, and here is with double T. So now this is recognized, and we're basically calling the handle back button function inside this touch up function. Okay, so we're ready with this class, guys. We're done with it, so I will save it, and we're not getting any errors. And let's see now what is going to happen if the back button is going to be displayed and actually work. So I run the game and then I will start it. So you can see now here we have this green button, and when I press it I simply go back to the menu screen. Then I start the game again and I go back. Then I start it again and I go back. And this is the way that you switch from the game screen to the menu screen, and this is the way that you can run the game, always play it, and when you get bored, simply to stop it. So that's it for today, guys. I hope you enjoyed this lecture, and in the next two lectures we're going to learn how to import background sound and also sound once action is completed. So thanks for watching. Hi everyone, in the next two videos, as I said earlier, we're going to learn how to add basically three sounds. The first two sounds are going to be an effects. So once the ball hit the basket or once the ball hit the ground, you would like your game to make certain sound, so you basically know where the ball hit it, okay? And the other sound will be the background sound that you will always hear while you're playing the game. And today we're going to create the two sounds that are the sound effects. So let's head on to the IDE where I will show you how to do this with just a few lines of code. Here we are in the IDE and I will go to the Game Manager class where we will add our sound effects. So obviously first of all we will need to add the variables that are going to be related to our sound variables, okay? So under the back button texture, let's write two more variables. Public, static, back button, sprite, sound, ground, sound. And this is going to be the sprite for the ground sound, and then public, static, sound, basket, sound. That's it. These are our two sound variables, and we use the sound class here, as you can see, in order to create them. Then I will go here under this obsolete method. So what we would like now is to relate our sound variables to our sound files. So let's write ground hit. Was it hit or was it not hit? So only ground sound will be equal to GDX dot audio dot new sound GDX dot files dot internal, and here I will write the location, which is data slash sounds slash ground hit dot WAV. Okay, you can apply also other sounds, just bear in mind that they need to be in WAV format. So let's create now another variable, and this is going to be basket sound will be equal, was it basket? Yes, basket sound will be equal to GDX dot audio dot new sound GDX dot files dot internal, and again we're going to set the location of the other sound, data sounds ground basket hit dot WAV. Okay, and then semicolon here, and we're ready with that. So we stated our sounds here, and finally, as we created the variables here, we would like to dispose them. So I will go here to dispose method, and here I will write ground sound dot dispose, and then basket sound dot dispose. Okay, that's it, we're ready. And finally, I'm just going to go to our bow class because we also need to implement certain things there in order to implement that. So we want to play actually our sound inside the bow class. So how to do this? Let's go to our check collision with basket function, and here in this if statement, so basically here we check if the ball hit the basket. Okay, so if the ball hit the basket, then we would like to say game manager dot basket sound dot play. That's it. So here we're playing the basket sound, if there is intersection. And then here above, if we on the other side hit the ground, okay, so if we are here, then let's write game manager dot ground sound, okay, dot play. So we're playing the ground sound if we have collision with the ground. And here I did a small mistake, so game manager, that's it. So basically, if we hit the ground in this collision with ground function, we play the ground sound, and if we hit the basket, we play the basket sound. That's it. So I will save that and let's play the game. I will start now, and here I'm getting an error that some of the files is not found. So I will go back to the game manager class and check how I initialize these files. So here I did a mistake. I wrote downs instead of sounds. So I will fix this, and then I will run the game again. Let's press OK. And here is the game. Let's press start. And now you can see that when the ball fell on the ground, we hear one sound. However, when it falls on the basket, the sound is slightly different. So that was it for today, guys. Thank you very much for watching, and in the next video I will show you how you can play the background sound of your game. Hi everyone, today with very few lines of code I will show you how you can play the background sound of your game. And first of all, we're going to start adding these variables in the game manager class. So we're going to go to the game manager class, and firstly I obviously add the variable for the background sound. So here I will select public, and here I will add music but not sound this time, and then background music, okay. And after that, to set the background music file, I will go just under the sound file and I will add the background music. So let's write background music equals new equals gdx.audio.new music, and here I will set the location where our music file is. So gdx.files.internal data slash sounds slash backmusic.mp3, okay. And then let's write background music dot set looping true. So once the music finishes, it will start again. This is what we are saying. And then background music dot play, because we can start playing the music immediately here, okay. And here I'm getting a mistake or an error because maybe I didn't write well the background music variable. So let's check that. Let's write here static, and now we're left without any errors. So this is good. This is actually really good. And then let's go to the dispose class and finally add the background music dispose method there. So background music dot dispose, and we're done. So we're ready with the game manager class. And then as we want to start this immediately once we start the game, we need to go to the catch the ball class, okay, and inside it, in the dispose method here, I will simply write game manager dot background music dot stop. So I want when I end my application this music to stop, because imagine that you start your application and you haven't stopped it, or you haven't stopped the main screen that you're playing the game in, and you're going back to the menu screen, then you would like the music to stop playing, right? So this is what we're doing here. Let's run the game and listen to the music. So as you can see and hear, on the menu class we don't hear any music, but once I press the start button, you can hear some game music, okay. and that's quite exciting music, and you can really go into this game while listening it. So now this really looks like a real game that you can play everywhere with your friends and you can be proud of completing. So that was it for today, guys. Thanks a lot for watching this section. This was the final video, and I wait for you in the conclusion section where I will summarize what we've done so far. Thanks for watching. Section Conclusion. Hi everyone, welcome to the concluding section of this set of lectures. So I just wanted to sum up what we have learned in this very excited section where you learn a lot. So you basically learn how to implement physics of motions inside your game, and you did this by making the ball accelerating once it was falling on the ground. You learned how to make interaction or intersection between different elements in your game, and from these intersections to increase your score. You learned how to not only implement your scores, but how to save the highest score inside the game. You learn how to work with different scenes. So you had the menu class and you had your game class, and in that way you learn how to switch between them when you are making two types of buttons. So you firstly made in the menu class the exit and the start game button, and then in the gameplay display you made the go back button, which were enabling you to go back to your menu screen. And this is very important because once you learn how to work with two screens, you can then increase this number of screens because the logic behind this is absolutely the same. So you really learned a lot here, and I'm very proud of you that you reached that far. I will see you in the next section, and thank you for being with me in this course. Get the cheese. Section Overview. Hi everyone, I'm very excited today because today I'm going to teach you to a very interesting game which is called Get the Cheese. So this is the gameplay that you can see in front of you, and the idea is simply to get the cheese with the mouse that you already have. Once you get the cheese, you receive the result, you win, and then you win the game. The interesting thing here is that you have a map that you can explore. So once the object is moving, the map is also moving until you reach the end of the map. And I know that you probably have seen many similar games, so now you will be able to create one. The game will basically have this simple graph. So we're first going to write our initialization functions to start up the game, then we're going to wait for user inputs. So once we select certain button on our keyboard, then we are going to start the game, and then we have the choice whether we would like to stop the game or not. If we would like to stop the game, then we will get out of the game, but if we decide to play, then we will be able to update the gameplay and to render, which means to display the new components and the new pictures which are representing our objects. Talking about this, I just want to mention all the videos that you are going to see in these sections, because it is nice to have first an overview of all the videos and then starting them one by one. So we'll start by developing the cheese game class in the first video, then you create the base screen class. After that you create the mouse as an actor, then you animate the mouse in the fourth video. And once you do this, in the next video you create the cheese level class, in which you are going to set up your game, and you will also be able to see finally your object or your mouse on your screen. And after you achieve this, so after the first 5 lectures, you will be able to already see how the game works until that level. But after that, we're going to upgrade it. So firstly, we're going to add the cheese. Then we're going to add the functionality of interaction between the mouse and the cheese. So the game knows that once the mouse finds the cheese, this means that we won the game. Then we're going to display finally the map or the background on your screen. Then we're going to make the game a little bit more interesting by adding time and also adding a text once we win. And this is going to be the complete game, and after that I'm just going to wrap up and talk about the conclusion and what you learned from this section. So that was the section overview video. Please head on to the next one when we're going to set up the whole project. Thanks for watching.
And cheese
Game class. Hi everyone, today we're going to set up and basically create our cheese game project in Eclipse. So let's start by something fun, and I will show you how the game actually works. So you can see the mouse, how it's animated and it moves on our map. So once I move the mouse around, the map is also moving, and once we reach the cheese, then we won the game. And you can see the text you win, and you can see your time 50 seconds. Okay, so this is basically the idea of the game, and you can still explore the map with the mouse. And once I press, let's say, M, then I go back to the main screen. Once I press S, then the game starts. It is that simple. So this is the game, and let's now create our LibGDX project to start it. So let's now select GDX setup file here. This is in my computer. In yours it might be in different folder. So here we are in the LibGDX project setup, and let's first give a name to this game. So this will be 5_get cheese. Then the package will be Martin Y. Then the class name will be main. And after that, let's choose our destination. So as always, go to your projects folder that you should already have. And let me show you my project folder, which is here. And once you're in this folder, write / and then write the name of your game, which in my case is also going to be 5_get cheese. Okay, you can see the folder here. Then I hope you have your SDKs set it up. And here I will remove the HTML, iOS and Android because we are going to develop the game for desktop. And I will simply generate the project. Let's generate it. And once you're ready with setting up the project, let's go to our Eclipse, select import, and then existing Gradle project, press next, select next here, go to your projects folder and find the name 5_get cheese, select OK, and then finish. That's it. So you can see that now we have all these projects here. So as always, let's first test if everything works fine. So I'll go here to the desktop launcher, okay, in this class, and I'm going simply to run it to see if we're going to display the BetLogic logo. Okay, we have the BetLogic logo. So now we can start building our first class actually. And this will be the cheese launcher class. And actually we're going to modify here the desktop launcher in order to be able to run our game. So I will leave this and this line as well. And then here instead of desktop launcher, let's write cheese launcher. You get error here, so hover over it and select rename the file to cheese launcher. Select it, and as you can see now your file is renamed to cheese launcher. Okay, so the class name here matches the name of the file, and then inside this we're going to do very slight modification. So let's write here cheese game config equals new, and here write cheese game. That's it. And then just under it I will delete this line and I will write LWJG L application launcher equals new LWJG L application. Okay, and inside here I'll write my program. Okay, and this is just to set up and be able to run your main class. So that's fine here. So this is here config. Okay, so we match this variable here. I was thinking to make it my program, but I just decided to keep the config variable that we already had. Anyways, for now you get error here because we still don't have this cheese game class which we're going to run in our cheese launcher. So for that reason, I will just create all the necessary classes that you need in order to run your game. So in this class com.martinY, I will delete the main class here. So press OK, and I deleted it. And then we're going to create a few classes. The first class I will create is called Animated Actor. Then create one more class that is going to be called Base Actor. After that, I will create a few more classes. So this will be called Base Screen, and here we want the functionality for the base screen in which we are going to play the game. Then let's add a class Cheese Game, which is going to be our connection class between the desktop and the core module. Then create another class called Cheese Level, and here we're going to add all the functionality of how the cheese interacts with the mouse and what is being displayed in our screen. So I noticed that I made a slight typo mistake here. So press F2 in order to be able to modify this and write cheese game. Okay, press finish. And you can see that your class is now modified. Then let's create one more class, and it will be called, actually this is the last class we are going to create, it's going to be called Cheese Menu. Okay, and this is going to be the entry menu, and this class is going to be one of the last that we are going to do. That's it. So since you did this and you have already all of your classes displayed, go here and instead of this main class that was pre-selected here, delete it and write Cheese Game. So we import the Cheese Game class here, okay? And we will not need this application configuration class as well. Okay, so select here Cheese Game, and that's it. So there is no longer error here. So I can see another spelling mistake here. Instead of Cheese Game, I wrote G's Game. So let's change that as well. So again, press F2 and change this to C. That's right, press finish here. And now we change this to Cheese Game, okay. So that's fine, we don't have any more errors. And let's go here and now martinY dot cheese game, that's it. And here we have no longer errors displayed. And that's it. It is normal that you have an error here for now, but this will soon be removed once we start updating our other classes. So I think that was enough for today, guys. Thanks for watching, and I will see you in the next video. Screen development. Hi everyone, today we're going to actually create the base screen of our game. So I will go to the base screen class, and actually in this lecture I am going to import all the packages so we don't waste time adding them here. So these are all the packages. Please stop the video here and simply type them inside your program. But let's go to the most important part. Let's start updating the base screen class. So first I will delete this because we are going to do a big modification here. And what I will write is public abstract class. So this will be an abstract class, and we'll implement the screen. So implements screen and input processor, because here we're going to use features from the predefined screen class, and also we're going to define some inputs. Okay, so first let's write protected variable game of a type game. Okay, and then let's write protected stage min stage, and then protected stage UI stage. These are just some variables that we need to add before typing the logic. Then let's write public final int view width, and this is going to be the width of our view, 640, and then public final int view height, and this is going to be also an integer of the height of the game, which is 480. That's it. Then let's write private boolean post, and this is going to be the variable that controls whether our game is paused or not, so it can be either true or false. Then let's write public base screen game g, that's it, and then let's write game equals g, so the object game will be equal g. Then min stage equals new stage, and in the brackets let's write fit viewpoint, then view width, comma, view height, okay, and then user interface stage will be equal to new stage, and here inside write new fit viewpoint, and again view width and view height. This is a different way of setting up the viewpoints for the user. Okay, then let's write post equals to false, so our game don't start post, of course. And then let's write input multiplexer IM equals new input multiplexer, then this comma UI stage, and then min stage. That's it. And then write gdx.input.setInputProcessor IM, and basically this is going to process all the inputs that are coming from the user. So now I'm going to create the create function inside as well, and we're ready. Let's write public abstract void create, and here I will just remove the semicolon because we have one extra and it gave us an error. Then just under it, let's write the update function, and inside I will write update float dt. So dt is a time parameter. So here we will add the game loop, and then we will render it. So I'm adding here the render method. So here again float dt. That's it. And then let's write UI stage dot act dt, and here we're going to add the pause input. So if the game is not paused, then what would like to happen is that the min stage dot act dt, and then we would like to update it. So this means that we're continuing the main stage of the game if it is not paused. And then I'll write the render rows. So here gl clear cover 001, and then gl, then gl clear, gl20, gl cover buffer bit, which is a common thing, and then write min stage dot draw, and then UI stage dot draw. And here is how we're drawing the different stage of the game. Let's close these brackets here, and then let's write public boolean is post, and then return post. So here we're basically going to add a few pausing methods, okay? And let me actually delete this semicolon here, and I notice that we have two here, okay? And then I will continue with the post methods. Then let's write public void, and here I will add a set paused method, which will have boolean b, and inside I will write paused equals b, and then I will create another method, public void toggle paused, and then inside I will write paused equals to not paused. And these are simply a standard post methods that you don't need to remember, but you can be aware that you can add them if you want to add post functionality in your game. Then let's write public void resize int width and int height. And this is our resize method for resizing our game. So I want here min stage dot get viewpoint dot update, and here I want the width, the height, and true, as this is what the update method takes. Then let's write UI stage dot get view point dot update dot width dot height, and then equal to true. Okay, we're done here. And let's then write a few more methods. So the first one will be public void pause and then nothing inside. Then public void resume and then nothing inside. Then public void dispose. Okay. Then public void show method. There we go. And then public void hide. That's it. And finally, we'll add some methods that are required by the input processor interface. So the first method is the key down, and inside int key code, then return false, then public boolean, and most of them are booleans actually, key up, and then int key code, and inside I will write return false again. We always need, if we're implementing methods, we always need to define them in the end. So this is very important. So let's write here public boolean key typed character C, and then return false, and then we'll add the mouse moved method. So public boolean mouse moved, and then int screen x and integer screen y. So these are the values that we are passing. Here we go. Then render false. That's it. Then public boolean scrolled, and we're going to add int amount, and then we will return false as well. So let's return false here. Okay, and after that let's write public boolean touch down, and then int screen x and integer screen y, then int pointer and int button. That's it. And there are just two more methods left here. So let's write public boolean touch dragged. So this means if we press and drag some element, then int screen x, int screen y, and int pointer. Okay, and this will also be false. And finally, let's write public touch up, int screen x, int screen y, int pointer, and then int button. Okay, and this function will also be giving us false result. False. That's it. And we're ready here. I will just delete the rest of the code list. So we need to have only one left below. And as you can see here, we don't have any errors. So our class is complete, and this class is pretty much just defining these methods. We are not doing actually much action on them, but we need to do it in order to run our base screen. So let's save this method. And that was everything for today, guys. So bear with me in the next lecture when we're going to create our base actor, which is the mouse. Thanks for watching. Creating the mouse actor. Hello everyone, since we already created the base screen class, now it's time to create the mouse actor or the base actor. So we're going to work today on this base actor class. And what is interesting here is that we're going to define the mouse here, then animate it in the other class, and finally display it from the cheese game class. Okay, or actually from the cheese level class, and this is important to know. So today we're going to do two things. We're going to create the base actor, and the other thing that I will do is I will also create the game cheese class. So today we have quite important job to do, and I will say let's get started. So firstly, we're going to update the cheese game class, and here I'll import com.bedlogic.gdx.game. Okay, and I'll also import actually I think that's enough. So let's start updating this, and this class will extend game, obviously. Game, and it extends. Okay, so the cheese game will extend game, and then inside I'll write public void create, and then inside this I will create cheese level cm equals new cheese level this, and then set screen cm. That's it. For now, this is how the class is going to look like, and what this class is actually doing, let me save it, Control S. So as you can see, this class is related to the cheese level class, okay? And also if you can see in our cheese launcher, okay, now I saved it here as well, you can see that we previously had error, but now we no longer do. And this is because here we exactly what we call is this cheese game class, okay? And since we already added data inside this class, in the cheese game class, then we're not getting error here. So once we want to run the game for the desktop, we're going to run this class, which is going to call the cheese game class, which on its side is going to call the cheese level class, where the logic of our game will be implemented. Okay, and enough for now. I will talk about this later as well. But let's start now creating our base actor class, where the data for the mouse is going to be located. The first thing I will do is I will copy all the imports that you need inside the class. So pause the video here and just write them down, or you can even copy them from another class if you have them, if you're lazy to write. So these are all the imports that you need. Then I will delete this, and let's actually add data inside our class. So let's write public class base actor, and it will extend the actor class that we already imported in our project. So this will extend the actor class, and then inside we'll create some variables here. So public texture region. Okay, so we create object region from the texture region class. Then we're going to create a rectangular with a name boundary. Then I will create another object which is called public float velocity x. So this is going to be the x velocity of the mouse. And then I will create another variable velocity y, which is going to be the y velocity of the mouse. Now let's write public base actor, and this is going to be the constructor of our base actor. Write super, then region equals new texture region, then boundary equals new rectangular. That's it. And as you can see, this is how we're using basically our objects that we created earlier, and also the velocity x and the velocity y, we're going to set them to 0. And that's it. So now let's write public void set texture, and this is going to be a method, and it will take texture t. Okay, so to this method we will pass a texture, and let's write int w equals t dot get width, and then int h equals t dot get height. Okay, and then we will set the width as w and we will set the height as h, and then write region dot set region, and let's write t here. So this is how we are setting our region that we're going to use, and then let's write public rectangular get bounding rectangular, and then inside boundary dot set, then get x, comma, get y, comma, get width, and then get height. So our rectangular is in exactly the same shape as our boundary, then we return the boundary. Okay, and here's how we set our rectangular, and then write public void act float dt, which is a time variable, then super dot act dt, and then move by velocity x multiplied by dt, and velocity y multiplied by dt. And here we're actually going to implement in this function the movement of the mouse. Okay, so we're moving it with the velocity multiplied by time, which equals to position, and this is how we move it to x and y direction. So now it's time to create the draw method. So draw batch and parent alpha. So first of all, let's create a cover. So cover c get cover, then batch dot set cover, and this is how we are setting the cover of the batch of our mouse. This is actually another way to set cover that I haven't showed you yet. Then write if is visible, then batch dot draw, and in the brackets region dot get x dot get y dot get origin x and get origin y, comma, get width. Okay, and then get height, comma, set scale x, set scale y, comma, get rotation. And this is what we're adding in our draw method in the isVisible function. Let's delete these two curls here, and that's it. So this is how we're drawing basically our mouse with this method, and we're adding the x, the y location, the origins of our game, and the get width and the height as well. And there is some error here. Let's see what it is. Okay, I've added an extra bracket here, so I will delete it, and now you can see that the error is removed. Let's save this class, and we're ready. So this is our base actor class, which defines basically the movement of the mouse and the mouse itself. So in the next one, we'll create the animated actor class, which is going to create the pictures of the class and the pictures of the mouse, and will show us how it actually is going to move and be animated. Thanks for watching. Hello everyone, today we are going to write the class animated actor, and we're basically going to learn how to animate the mouse. But before that, I want you to get from the sources the assets folder and add it inside your game. So I will go here in the cheese core, and I will go to assets and delete the BetLogic JPG. Okay, and now inside this assets folder that is inside your game, add the other assets folder. Okay, so I will add it here. Press OK, and you can see that how you have assets, and under it you have another folder with the same name, in which you get all the cheese and the mouse pictures. Okay, so it's important that you have this folder, and once you do it, now you can start writing the animated actor class. So first of all, as always, I want all the imports that you need, which are these ones. They are actually not that many this time. You need to add the batch, the texture region, texture, animation of the graphics method, and the math utils, because we're going to use some math functions here. And then delete this, and I will start writing it from scratch. So let's write public class animated actor extends the base actor. So basically, the animate actor extends the previous class we created, the base actor, okay? Then let's write public float ellipse time, and then write public animation anim. So we're creating an object from the animation class, which is predefined in LibGDX. Then write public animated actor, and this is going to be our constructor, and inside write super, then ellipse time equals 0, and then anim.new, okay, and then public void set animation, and to this method we will pass an animation object a, okay, and here write texture region t, so texture region t equals, in brackets, texture region a dot get keyframe 0, that's it, and then set texture, and in the brackets t dot get texture, okay, and then write anim equals a, and we're ready with that method. And then let's write public void act float dt, and this is going to be our act method. So let's write super dot act dt, then ellipsed time, so now we use the ellipse time that we created, plus equals dt. So if the velocity x is not equal to 0, or the velocity y is not equal to 0, set rotation math utils dot attend to velocity y velocity x multiplied by the math util radians to degrees, and that's it. And then write public void draw batch, and inside write batch, comma, float parent alpha, and then texture region t2 equals texture region anim dot get keyframe. And basically here you're drawing your mouse, you are drawing the animation of your mouse, and you are setting some functions in order to choose which mouse picture to be used. So region set region t2 dot get texture, that's it. Then write super dot draw batch, comma, and then write parent alpha, that's it. And we're ready with this class. I will just remove the curls here, we have 2 extra. So that was it from the animated actor class, and in the next section I will display you, and I will show you basically how to display the main character of your game. Thanks for watching. Hi everyone, in the last lectures we finally completed the base actor class, the animated actor class, so now it's time to actually display the mouse that we were creating classes for. And to do this, we're going to enter this cheese level class, okay? So we're going to update this class, and you will be able today for first time to run your game. As this type of class is going to actually be quite big, we're going to import a lot of libraries. These are all the libraries that you need to import, so I would advise you to pause the video and just import each of them. They are all related to the LibGDX toolkit, so you need to import the game, the GDX, the different types of graphics, as well as some math functions. Okay, so pause the video now and please upload all of the libraries that you need for this class. Since you've done that, now we're ready to start actually coding our class. So let's write public class cheese level, and this will extend the base screen class. Okay, so this will extend the base screen, and you remember in the base screen we were actually using the cheese level class in order to run that type of screen. So here I will create a private variable of animated actor, and this will be called Mousy. And then let's write private boolean win, win, and then let's write private label, time label, and this is the variable for our time label, and then let's write final int width map, and this is going to be the width of our gameplay, and then final int map height, and this is going to be the height of our window, which is the same as the width. It will be equal to 800. Then let's write public cheese level, and this is going to be our constructor, so we require this to be related to the game class, and write inside super g, and that's it. And then let's create the create function. So public void create, and inside let's write Mousy equals new animated action, and that's it. So we created an instance of the Mousy class in the create method, and then let's write texture region, then two brackets, frames. So this is going to be an array of texture regions, new texture region, and here in the brackets let's write 4. Then let's write for int n equals 0, n smaller than 4, n plus plus, then write string file name, and this will be the name of the picture that we're going to pass here. So right here assets mouse plus png. So this is basically some logic of how the pictures are going to be displayed in our screen. So let's write here texture text equals new texture gdx dot files dot internal dot file name, and that's it. So what we are basically doing in this for loop, as you know, depending on the direction on which the mouse is moving, we would like to use different pictures for the mouse. Okay, and if you can see in the assets folder, okay, we have here, so we have mouse 0, 1, 2 and 3. Okay, so we would like to use each of these 4 pictures, which are the direction of the mouse. Okay, so this is 1, so this is 0, this is 1, this is 2, this is 3, and this is 4. Okay, so this is the main picture. So this is the pictures that are related to the animation, and as you can see, in every picture the mouse is moving its tail and its nose. So this is the way that we are changing the pictures for animating the mouse. And what I'm doing here is simply I'm saying in this array here in the file name, so this is not array, but anyways, in this file name I first going to use the mouse picture 1. Okay, then I'm going to go to the exact file and display it. Then I will use the picture 2 because in the next instance of the for loop the n will be equal not to 0 but to 1. Then I will use the next picture, and this is how we're going to animate the mouse. So we have here texture that is called text, and the text file is the text object is actually related to the file that we are using in this for loop. Okay, then let's write text dot set filter texture filter dot linear, so we're setting here a linear filter, comma texture filter dot linear. Okay, that's it. And then frames n equals new texture region, and inside this texture region let's write text. So we're creating new frame, we have 4 frames as our array sets. Then let's write array texture region frame array, that's it, equals to the new array texture. So we're creating new array texture region here with our frames. And then let's write animation anim equals new animation, and let's set the parameters of the animation. So the size factor is 0.1. Then we use the frames array, which are 4 frames that we have with all our picture. Then write animation dot play mode dot loop ping pong, and this is how we are basically looping our pictures to be displayed one by another. Then let's write mousey dot set animation, and this is how we relate the animation to our actual mouse object. Then mousey dot set origin, and here we will set where the mouse is going to be displayed at first. So mousey dot get we divided by 2, and mousey dot get height also divided by 2. So our origin is exactly in the middle of the mouse. Then let's write mousey dot set position, and the position will be 2020, and these are coordinates on our window. I will show you where they are once we run the game. Then write main stage dot add actor, and in the main stage we're adding the actor mousey, which now has all the pictures and the animations. And then win equals to false. Now write public void update float dt. Okay, and here we're not going to do anything yet in this function, but later I will add functionality, and we need to add a few more functions. So let's add public boolean key down int key code, and we're also not going to add anything in this function for now, but later I will actually add some data there. But for now this function will return false. And finally let's override the scrolled function. So let's write public boolean scrolled, and in the brackets float amount x, and then float amount y. Okay, and this will be auto-generated method. Okay, and then this method will return false, and let's try the brackets here, and we're ready. So I'll remove the extra 3 curly brackets that I got, and now this is the bracket that closes the method, and this is the one that closes the scrolled method. Okay, we're ready with this class. Let's press Ctrl S for save, and as you can see now in the cheese game we don't have anymore this error, because now we have the cheese level class implemented and we call it here. So that's fine. Since we don't have errors, now is the first time that you can run actually your game. And I will go here in the cheese launcher and then select run as Java application. So now as you can see, you have your mouse and you see how your mouse looks like it is moving. And this is because we're using all the 4 pictures that I just showed you, and we're looping them one by another. And this is creating this actually moving impression of the mouse. So you can say that this is really some type of animation. So we cannot move it yet. So if you press the arrows on your keyboard, you cannot move the mouse yet, but soon you will be able to, actually in the next lecture, and this is exactly what we're going to be doing. So thank you very much guys for watching, and I will see you in the next lecture. Hi everyone, welcome again to my course. today we're going to do something that you would probably like a lot, and this is the mouse movement. So after this lecture, actually, you see how small amount of code it will take us to make the mouse move above and to connect the arrows from the keyboard to the mouse. The only thing you need to do is to go here in this update method in the cheese level class, and once you're here, you first need to write mouse dot velocity x, and we'll set the velocity x of the mouse as 0. So this is going to be the initial x velocity of the mouse, and this is 0. Then the velocity y is also going to be 0, the initial. And then we're going to create a four if loops. And in the first if loop, I write gdx.input.is key pressed, and then key left. So if the key left is pressed, then we would like mouse.velocity x to be deduced by 100 if we press left. Okay. Then if gdx.input.is key pressed is equal to the key right, we would like to increase the x with 100. So I write mouse.velocity velocity x plus equals 100. And then if GDX input is key pressed and then key dot up, so if the up key is pressed, then we would like mouse.velocity y plus equals 100. And then let's create another if loop. So if gdx.input.is key pressed, and then we'll check for the key down, then what we would like is the velocity y to deduce. So if we go down, we would like the velocity y to deduce with 100, to be actually subtracted from the current velocity. And then let's write mouse.set x, and here we're going to set the x and the y locations depending on the keys we just set it. So that's why I write matunis.clamp mouse.getx 0, and then mapWidth minus mouse.getWidth. That's it. And then for the y location, so set y, again we're going to use matunits.clamp and then mouse.getY, 0, and then let's write map height minus mouse.getWidth, get height here, and that's it. So basically here we use what we already had. So we're getting the x and the y location of the mouse component, and this is how we're performing these inputs. So this was the update method. Let's run our game and see if we can control the mouse now. So here's the mouse, and when I press the arrows, you can see how the mouse is moving. Okay, it even disappears from our screen because we do not follow it, but we will change that. So the screen for now is not moving with the mouse, but that will definitely be changed. So you can see that here the mouse cannot cross, here the mouse cannot cross, but here it crosses. However, the camera doesn't move with it. So now you are able to move your mouse, guys. That was it for today. Thanks for watching, and bear with me to the next lectures when we're going to add the cheese and also the map of the game. Thanks for watching. Displaying the cheese. Hi everyone, since we already have the mouse displayed and we're able to move it, now we can think about how to display the cheese actor. So the actor that the mouse is hunting and want to catch inside the game. So again, I'm gonna implement the cheese in the cheese level class. So here I will actually add under the animated actor mousey, I will add here private base actor, and then I write cheese. That's it. So this is the variable for the cheese, and then inside the create method here, so go here, let's write cheese equals dot new equals new base actor, okay, and this is stating that the cheese is a new actor in our game, and we'll just need to set some components. So cheese dot set texture, new texture, then gdx dot files dot internal, and here I'm going to define the location of the picture of the cheese. That's it. And then let's write cheese dot set position, and here I will set the initial position of the cheese, so it will be on 400 comma 300. That's it. Then let's write cheese dot set origin, and the origin of the cheese will be cheese dot get width, so this is the width of our picture, so get width divided by 2, and then get height divided by 2. So we're dividing the width and the height of our picture by 2, and this is where the location of the cheese on the map will be. Then let's write main stage dot add actor, and this is how we're adding the cheese. So let's run our game and see how the cheese is going to be displayed there and how the game will look like. Let's press OK here, and after that you already see your game that the cheese is here and the mouse already here. So now we can hunt the cheese. However, you can see when we go over the cheese, it doesn't disappear, right? So in the next lecture, I will actually show you how to improve this as well. And this means that we will do an intersection between the mouse and the cheese, so you are able to actually hunt the cheese, okay? So that was, guys, everything for today. I hope you enjoyed this lecture. I will just go once again here. So here we're basically creating the object cheese, then we were referring the file where the picture of the cheese is, then we set the position of the cheese on the map, then we set the origin, or where in the system we theoretically locate our cheese in which point of the map, and this is in the point of the cheese divided by 2, the width of the cheese divided by 2, and the height of the cheese divided by 2, which means that our origin of the cheese is going to be in the exact middle of that picture. And finally, we're adding the actor cheese inside our gameplay. So that was everything for today, guys. I hope you enjoyed that video, of course, and I will see you in the next one when we're going to do intersection between the mouse and the cheese. Mouse cheese intersection. Hi everyone, as I promised last time, today we're going to do intersection between the cheese and the mouse. And we already have the mouse created, we already have the cheese, so what's left is just to add a function that is defining the intersection between these two game objects. So instead of making the cheese simply disappearing after the mouse reaches it, I decided this time to make it a little bit more complex and interesting for you. So we would like to have a fading effect and also rotating effect once the mouse reaches the cheese and the cheese starts disappearing, okay? So let's do this. So here, just under the mouse set y function, let's write rectangular. So first I will create rectangular of the mouse and the cheese so they can intersect. So rectangular, cheese rectangular equals cheese dot set bounding rectangular, and this is making an imaginary rectangular around our cheese, and the same is going to be done for the mouse. So rectangular, mousey rectangular equals mousey dot get bounding rectangular. That's it. And then let's write if not win and cheese rectangular dot contains mousey rectangular, so this means if the two rectangulars are in the same location, then win will be equal to true, so this means we will win the game. And also we would make the code for disappearing of the cheese. Let's write action spin shrunk fade out, and this is what we're going to do. The cheese is going to spin, shrunk, and fade out. Actions.parallel, and first let's write actions.alpha1. So here we're setting the transparency value. Okay, then actions dot rotate by, so we're going to rotate by 360 degrees. Then actions dot scale to, and here is how we're going to reduce the size. Okay, and xy, so we're going to scale it to 0 for 2 seconds. Then actions fade out, and this is the duration of how long it will take the cheese to fade out. That's it. Then let's write cheese dot add actions spin shrunk fade, and this is how we add this action to our actual cheese. Okay, then let's write action fade in cycle forever equals action sequence, so action dot sequence, and then action dot alpha 0, and again this is the transparency value. Then actions dot show set, so this is how we set the cheese to be visible. Then actions dot fade in, and we'll write 2, so this is the duration of the fading again. And then actions dot forever, and then actions dot sequence, and inside I'll write actions dot cover bracket new cover, and these are going to be the numbers of the cover. And then we're going to select another cover again with numbers, so let's select action cover new cover, and this is going to be 0011 and then 1. That's it. Let's close the brackets, and we're done here. So I actually think that there is one more bracket. No, actually that's it. So let's remove this line here, and let's bring these ones back so the indentation levels are clear that this is under the previous one, and here as well. So let's add one more curly bracket, and then the method is going to be finishing here. So here we close the update method, and as you can see we don't have errors anymore here. So let's run as Java application, and then let's see what's gonna happen. Okay, so when we move our base actor to the cheese object and we go there, you can see how it disappears and it fades out, and this is exactly what we were expecting. So that was everything for today. In the next lectures we're going to add the background and also the score recording and the winning functionality of our game. Thanks for watching. Hello everyone, today I'm gonna show you how you can display the background of your game so we avoid having this black screen on our background. And the first thing you need to do is to add the background variable up here. So just under the cheese variable, write private base actor and then floor. Okay, so we're adding new base actor which is with the name floor, and then you need to implement this base actor. So inside the create method, let's write floor equals new base actor, then brackets, and then floor dot set texture, and here I'm going to refer to the picture file that is of our floor. So let's write new texture gdx.files internal, and we're going to access assets titles dash 800 dash 800, which is the name of our picture. Then let's write floor position, so floor dot set position, and obviously the position of the floor is going to be at 0 0, and then main stage dot set actor, and the actor will be floor, so we set the floor in our gameplay. So then go inside our update method, and just under the if loop here okay, just under the if loop, we're going to add a functionality for adjusting our camera. So when the mouse is moving, we want our camera to adjust. So let's write here camera cam equals main stage dot get camera, okay, and now the object cam is referring to the camera of our game. Now let's write camera dot position set mousey dot get x plus mousey dot get origin x comma mousey dot get y. And as you can see, what I'm doing here is basically I'm setting the camera to be pointing at the position of the mouse, so the camera will be moving with the mouse. So mousey dot get origin y and then 0. Then let's write the bounce of the camera to the layout. So what I'm writing is camera dot position dot x equals mathutils clamp cam dot position x comma view width divided by 2 map width minus view width again divided by 2. Then let's write cam dot position y equals mat units dot clamp and then bracket cam dot position y comma view height, so similar to the previous line, comma map height minus view height divided by 2. And also would like this to update, so would like our camera to update when the mouse moves. So cam.update, and that's it. We're done with this class, so let's go now to our game and see what are the results of our code. So if you can see now, we have our map displayed, and let's actually not get the cheese, but you can see now, wait. So once I reach the middle of the screen, then the camera is moving, right? And it's the same if I move up. So if I move higher than the center line, then the camera moves with me, okay? And this is what we did in the adjustment section, okay? So this is how the camera is adjusted, and if I get the cheese now, you can see how the cheese disappears. And we're pretty much ready with our game. What we need to add more is the time, the win result, and also the entry screen, the entry menu. So this we'll do in the next lectures. Thanks for watching, guys, and I will see you in the next video. Text graphics to your game. Hi guys, in this video we're finally going to add the text and the graphics in order to make our game to look more interesting and be more challenging for the player. So first, again, we're going to work in the cheese level class, and the first thing I will do is again to go up and create the win text variable, okay? So just under the floor variable, write private base actor and then win text. That's it. Then I want one more variable here, so this will be called private float time ellipsed, okay? And then in the create method we're going to set the time ellipsed to be equal to 0, because we'd like our time at first to be equal to 0 and then start gaining, okay? And then in the same create method, let's implement the time and the u1 text, okay? So let's add them actually here. So just under the add actor mousey in the create method. So the first thing, let's write win text equals new, and again base actor. So we have new variable win text, and then let's write win text dot set texture, and here we're going to use the image for the win text. So let's write new texture GDX dot files dot internal assets slash uwin dot png. That's it. So as we see the picture, now we need to position it. So WinText.setPosition, and the position on the map will be 170 on 60. Then let's write WinText.setVisible, and here will be equal to false because we would like to create it at first equal to false. Then UIStage.addActor WinText. That's it. Then let's write a font. Bitmap font equals new bitmap font, and this is going to be the font for our time. So here we're not going to use picture but predefined font. Let's write string text equals time 0, and then let's write label style equals new label style, and let's write inside font comma color.navy. So this is going to be the color of our font, and then let's write time label equals new label text comma style, and then time label dot set font scale, and the scale will be to here, and set position, and the position will be 500 on 440, which is exactly the bottom position of our gameplay. Then write UI stage dot add actor time label. Okay, and this is going to refer to the time. And here we're getting an error, so maybe I didn't define the WinText variable properly. Let's go up here and let's see. Yes, so here I wrote WinText instead of WinText, so I will remove the D. And now when we go down, you can see that all of this is accepted. Okay, and I would say that maybe the error finding in Java, the predefined error finding in Java, is probably the best comparing to all other languages out there, because it really helps to find your errors and fix them in a timely manner. But anyways, let's go down here and add the loop with which we are going to decide whether we want to display the WinText or not. So here, inside this if loop that we are checking if not one, okay, so inside here let's write, so just outside this add action method here, okay, so let's write here WinText dot add action, and inside fade in color cycle forever. Okay, here is n, that's it, and this is actually this variable here. So as you can see, the variable that we created previously is actually the one that is going to display our WinText, and it will fade in and fade out. Okay, so previously we wrote this function exactly for this WinText. Okay, and finally we will need just to create an if loop here in order to increase or increment the time while we're playing. Okay, so as you can see, we're doing this in this update function. Okay, so in the update function, just after the WinText add action, and just after this curly bracket, so we're outside the loop, where we can write if not win. Okay, so if we don't win, then what we would like to happen is time ellipsed plus equals dt, which should be 1 second, and then time label dot set text, and here let's write time plus int time ellipsed. Okay, and then let's close this if loop. Okay, so well, yeah, basically here, let me bring this in. So basically here we're checking that if we haven't won, then what we would like is our ellipse time to increase by 1 delta time, which is usually 1 second. And then also, if we haven't won, we want the time label .getText to display time plus the time ellipsed value, or the value of the time. And pretty much that's it, guys. So let's run the game now and see if we're going to get the win text and the time. So here you can see that we're getting the time, and the time is increasing from 0 until infinity. And let's see, once we get the cheese, we should see the win text. Let's have a look. So you can see here that we have the win text, and actually the functionality for changing the color of the win text is actually working. Okay, so you can see how it's changing its color from blue to red all the time. And also the time stops once we won the game, which is exactly what we were expecting. So that was it for today, guys. You pretty much developed the whole game. Actually, the game is completely done. The last thing we will do in the next lecture is the entry screen. So when you enter the game, you would like to see a certain screen, and when you press certain button, then you would like to start the game normally. And this is what we're going to be doing in the next lecture. So see you there. To your game. Hello everyone, today we're going to add a screen to our game, and let me show you the class that we're going to be updating. So this is going to be the cheese menu class. We haven't touched it yet, but now we're going to write the whole class, and we're going to enable the game to run the cheese menu first, and then if the user press certain button, he will be able to switch to the actual game. But before updating the cheese menu class, let's first go to the cheese level class, because there we need to add a small if statement in order to run this cheese menu class in our cheese level class. So let's go here in the key down method. I told you that we need to write it, and I will later use it. So inside this key down method, let's write an if loop. So let's say if key code equals keys.m, and then game dot set screen new cheese menu, and in the brackets write game. That's it. So this means if the M button is pressed, then we're getting back to the cheese menu. And then if kcode equals keys.p, and p usually stands for pause, then toggle paused, and that's it. So this is the function that is going to be used for the paused method, and this is the function that is going to be used for the method that will bring us back to the cheese menu. Okay, so that was it, what I wanted to add in this class. And then let's write the cheese menu class. So again, I'm going to just copy and paste the imports, so you can stop the video here and simply add them into your code, and then we can start writing the cheese menu class. So first let's write public class cheese menu, and this will extend the base screen, as this class is a type of screen. It will represent a screen. Okay, then let's write public cheese menu game G, and then inside let's write super G, as this is a super class. And after that let's write public void create, and this is going to be our create method. Okay, so inside let's add base actor background equals new base actor, and this is going to be the background of our cheese menu class. So this is going to be the background of this type of screen. And then add background dot set texture, and inside the brackets write new texture, and then gdx dot files dot internal, and then assets dash title menu dot jpg, and we're ready here. After that, let's write UI stage dot add actor and then background. So we're adding the background for our menu screen, and then I will create another actor, so base actor, title text equals new base actor, okay, then close the brackets, that's it, and then title text dot set texture, and here we're going to set the texture for the cheese please, and this is going to be another texture that will be displayed on our screen. So gdx.files internal assets cheese dash please dot png. Okay, there we go. Then let's write title text dot set position, and the position here will be 20 on 100, and finally let's write UI stage dot add actor title text, and that's it here. Then we're going to create a font, and with this font, so I'm creating bitmap font here, with this font we're going to display a text that is going to ask the user to press S to start or M for the main menu. So string text equals press S to start, comma, M for main menu. That's it. And then let's write label style equals new label style, and then in the brackets font, comma, color yellow, and this is how we set the color to be yellow. Then label instructions equals new label, and write inside text and then style. Then let's write instructions dot set font scale to, okay, so we scale it by 2, and then instructions dot set position, and here is where our position of the text will be displayed. Then let's write instructions dot add action, so we're going to animate slightly our text that is going to be with the instructions. So let's write here actions dot forever actions dot sequence, and then in the action sequence first we're gonna set action dot color new color 1101 on scale factor 0.5 f, and then action delay, and here we're going to delay the action by 0.5 seconds, and then we're going to switch it to another color, so actions dot color new color 0.5 f 0.5 f 01 0.5 f. Okay, that's it with this section. We can close these brackets and then write UI stage dot add actor, and here we're going to add the instructions actor, which is with the instructions for the buttons. Okay, we're ready here. Then let's write public void update float, and inside this method we're not going to add actually anything because we don't want our screen to be updated. And let's add here another method, public boolean key down int and then key code, and inside this function I will add an if loop. So if key code equals to S, so if we pressed S, then we would like a game dot set screen, and inside we will add new cheese level game. So with this line we're saying that if we pressed S, the game will start, so we'll go to the cheese level screen, and then actually let's place this function here in the beginning, as it's gonna look way better. That's it. And then let's say here return false. Okay, so we're ready here. Let's save it, and we are getting an error, so let's see what the error is. So there are some unimplemented methods, so press add unimplemented methods, and as you can see we need to have the scroll method here, which is added automatically in our class. So let's press Ctrl S now for save, and now our class is completely saved. But see now, if you try to run the game, let's run the game, you can see that our entry screen is not displayed, and this is very simple to solve. So let's go here in the cheese game, and let's remember in the cheese game why this cheese level class. So that's why, because we're immediately running the cheese level, that's why we're not seeing the cheese menu class. So let's here simply write cheese menu, and here as well cheese menu. That's it. So this gets accepted, we don't get errors, and now we should be able to see our cheese menu class, so the menu of the game. So you can see here that you see cheese please, the text that we wrote in this shape, and this is actually a picture, but here below we wrote that string, and you can see how it is blinking from two colors, gray and yellow. And if you see, when I press S, the game starts. When I press P, the game is paused. Okay. And if I press M, we're going back. And this was the whole game, guys. It is completed now. I hope you enjoyed really that section. It was really challenging, but at the same time very interesting. So thank you very much for watching, and I will see you in the conclusion section. Hi everyone, congratulations for completing this game. I just want to wrap up on what you learned inside specifically this section. So you practiced how to process your keyboard inputs. Until now we were concentrating basically on the mouse inputs, but now you also know how to perform keyboard inputs in order to control your game. So you used the arrows and you used certain keys to start, go back to the menu and pause the game, which is quite important. You learned how to structure your game and use different actors for the mouse, the cheese, the background, and so on. So you are adding each object of the game using this create actor class, which made your job way more structured. Also, you wrote the cheese level, which is connected to the stage class. So now you're able also, if you want, to create more stages of this game with more complex maps and so on. You are able for first time to make your actors more visually interesting, as you were able to use 4 pictures in order to animate your main character, which was the mouse, and the mouse was looking like moving on your game, which is quite an interesting thing and really distinguishes the beginners from the professional game developers. You also learned very interesting features regarding the fonts. So you learned how to add animation to your fonts, so how to make your fonts blinking, and basically how to display the time while you are playing the game. So that was it from this section, guys. I hope you really enjoyed it and you learned a lot from it. Thank you very much for watching, and I will see you in my next videos.